In this video, we are going to cover a very important topic, and that is routing. So typically with React, you either are going to use one of two main libraries, at least the majority of React projects will. You're either going to use React Router or you're going to use Reach Router. They both are different libraries that essentially tackle the same topic, which is how do you determine based off the URL, i.e. the navigation on a website, what pages to render. Remember, in React, everything is a component. So you want to think about pages the same way. So let's look at a visual example. So at a high level, we understand what these libraries are doing. Because while these libraries are different and they'll go through iterations and they'll go through different versions, essentially they're trying to achieve the same thing. And as long as you're able to understand the high level topic, what the actual implementation details are is largely not that important. So imagine that you had your browser. Inside your browser, you have your website, your URL. URL-based navigation is pretty much the standard way that we navigate throughout a website. Let's say on this website, when you land on your homepage, you have some component like a navigation bar. Those little black lines, imagine that those are different links that take you to different routes on this website. Let's say that you selected the first website and it takes you to, let's just say Crwn-Clothing and then /route 1. When you navigate here, we might expect a specific page to render. What we'll notice though, is that that page is an entire component. I want you to think about it like that. Imagine that entire page that just got rendered when we navigated to Route 1 is a brand new component that we mount onto the page in response to navigating to Route 1. Now, what I want you to notice though is that the navigation bar component is still there. I've graded out a little so you can see and highlight which link we're currently on. But if you think about a lot of our applications, we know that in many applications, regardless of where you navigate onto the page, there are certain components that are always there, particularly navigation bars, side panels, all of those are always present. And the libraries that we use, whether it be React Router or Reach Router, should allow us that functionality. We should be able to modify and change what lives on the page based on the route. And what's changing is going to be what components render and don't render. So in our particular case with the navigation bar, most of the time, we probably always want it there. So there's a composition here that's important to think about because it really extends into how you would intuitively build applications. So we know we have a navigation bar. The content below the navigation bar is the one that typically changes on the route change. So here we see at Route 1, we've rendered in this different component at the bottom that reflects a page. Now let's say instead we navigate to Route 2, the second link. Here, what should happen is that we should render in some new content as we expect. On the side here, I want you to notice that there is now this sidebar. This sidebar might be some kind of navigation for the content within this route, meaning that depending on what you select inside of this side navigation, it may also additionally determine what gets rendered on the content to the right. So this you can imagine as a subroute within a main route that we're nesting in. This is a very common pattern that you see in web applications as well. Some things like Facebook Messenger chat is a good example of this. Depending on what you choose, the content on the right will render a different conversation. So similarly here, let's imagine that we selected the first link. We might render some specific things inside of here. If you look at the URL, you'll notice that now we're saying Route 2 /sub route 1, meaning that we're in the first subroute of Route 2, which is indicated by that first link that we've clicked in our sidebar. So the right content reflects accordingly because the right content is the components that are being rendered regarding this route. Now let's say, for example, we chose a different route, sub route 2 inside of our sidebar navigation. Here, of course, we expect the content inside to change again. So what I'm hoping that these diagrams have shown you is a very common pattern that we see throughout different web applications. We know that depending on the routes that we navigate to, certain parts of the page may change. Certain parts may not, such as navigation bars. within the parts of the pages that are changing as we move throughout the application by routing to different links, there may be certain routes that have components that stay with deeper subroutes. So in those subroutes, an even smaller portion of that website is re-rendering and coming in with new components and showing new content. But as we've seen here with our side navigation bar nested in Route 2, that component may also stay as long as you're nesting in Route 2 and navigating through these nested subroutes inside of Route 2. Now, once again, perhaps if we were to change the main route, let's say we went to Route 3, in this particular case, of course, everything underneath the main navigation bar re-renders, and that is expected behavior based on what we've been discussing so far. So again, this is a very common pattern that you see in how websites are built throughout probably the majority of the web applications you use on your day-to-day. We just want to be able to replicate this behavior with routing inside of our own application. In this particular app, we're going to be using React Router. So in the next video, let's learn how to implement the newest version of React Router inside of our application. I'll see you in the next video. Welcome back, everyone. In this video, we are going to implement React Router, which is version 6 right now at the time of this recording, into our application. If you're here from the previous 2 years of the last iteration of this application, you'll know that we were running React Router version 5. And this is the first major version update with a significant amount of changes in terms of just the implementation syntax. As far as how the actual library works and what it does for us, that is the exact same. It follows largely the exact same concepts we covered in the last video when we walked through how a web application, depending on the route and the subroutes you navigate to, will either decide to keep or remove and change different components on the page. And what those different components will be is largely up to our choice. The library just helps us execute on those decisions that we make. So let's talk about how we actually implement React Router version 6 into the application. So here, let's just walk through the docs really quickly so that we get a good familiar understanding of majority of how most React libraries work for us. So you can either choose to read the docs or start the tutorial. The great thing about starting the tutorial is you get to go through a very simple setup of how they'll want you to walk through the major features of React Router version 6. I'm not going to do it. I'm just going to show you how it actually is implemented because I understand how this routing library works. But if you're ever curious, go through this tutorial and just follow the instructions for this tutorial. It's really great. You get to build a sample application and just see step by step how this routing is built from the bottom up. We're going to go through as well in our application, but this one is straight from the library creators themselves. But the great thing about the tutorial is they have to show you how to install the application. And it's honestly really simple. All we have to do is just initialize the actual library into our packages. So here, they're really just using Create React App the way that we have to create some kind of tutorial application that you can walk through in case you don't have one. We can skip all this because we already have all this stuff. But what we really need is we need this part where we install the browser router. But first, we have to install the application. So to install the application, you just want to look here. Install React Router dependencies. npm install React Router DOM at 6. You can use npm. I'm going to use yarn. So let's go back to our terminal and let's install into our application React Router. So we're going to say yarn add React Router DOM at 6. So that's saying, hey, give me React Router DOM version 6. Now, the reason why it doesn't give you the latest one, sometimes depending on React Router DOM themselves and the package maintainers, they may be having some kind of conflict between a lot of these different versions that they're supporting. Version 5 may still be the most popular. They may be rolling out version 6. Therefore, they want you to specify when you want 6, even though it may be the major version they support. Again, a lot of times these libraries are heavily dependent upon by the majority of different applications in production that rely on them. So there's a lot of heavy decision making they have to make when rolling out major versions, especially ones that have sweeping breaking changes, like version 6 in this particular case. Here, version 6 also is not backwards compatible yet at the time of this recording. meaning that if you have version 5 and you upgrade your application's library to version 6, your application will not work because version 6 does not support the features that existed in version 5. So this is a very important thing to understand about a lot of these libraries. They may want to make updates, and they may do so, but oftentimes there will be conflict in how they do it because of the fact that with the upgrades, maybe they have better patterns or better ideas of how they want this library to work. Now, sometimes in order to do that, they may not be able to support the previous working functionality. When that happens, they have to come up with a strategy, and different libraries and different companies that support these libraries may have different strategies, which is an unfortunate side effect. In this particular case with React Router DOM version 6, some students who have taken this course when we were doing version 5 may have experienced a lot of frustration trying to use version 6 because it's not backwards compatible with version 5. This is an unfortunate side effect of the library's decision when they rolled out version 6. So this is an important thing to think about when it comes to when to upgrade a library. So with React Router DOM, I want to highlight one thing is that oftentimes in them, they'll have an upgrade guide. So if you watch the upgrade guide and go through it, you will understand some of the key features in the upgrade from one major version to another. Usually they'll lay out steps about what components or what features have now been removed and are now being upgraded. And similarly, they'll also tell you when you can actually directly update the version. So here, if you read through this guide, it really lists out the major steps required. First, you got to upgrade your React version to at least 16.8 or greater. So another thing to note about a lot of these libraries is that some of these libraries, depending on the version of the library you downloaded. So in this case, React Router version 6 requires you to have React version 16.8 or greater. Version 6 of React Router DOM will not work with anything lower than React version 16.8. So that is one of those considerations you may have to make when upgrading libraries. Another one is when upgrading React Router version 5.1 and above, you have to remove certain components. I know these might not make sense to you if you haven't touched version 5, but the main thing that this really shows you is that they may want you to remove old features, and they may also want you to refactor certain code patterns from those old libraries. That's all these two really represent at a high level. So that's one important thing. You may have to do this first before you actually follow through with the final step, which is where you upgrade the version of the library itself. So these are some important things. If you don't do these properly, you may see a ton of breakages across your application, which may be significantly more difficult to resolve once you've actually upgraded. So this is one of those important things that it's a really good moment to understand about a very particular case that does happen a lot when working with React, which is that some of the supporting libraries that you use may go through major version changes. When that happens and there are breaking changes, there is a process of going through the upgrade with them. It's oftentimes kind of painful, but it's definitely one of those things that is a great moment to really understand how these libraries work with your application, but also the general development cycle and life of an application that you're building in production as a professional developer. So I just wanted to highlight this thing because it's really on top of mind, and we actually went through it together inside of this course. Now, for some of you who have not gone through it earlier when we did version 5, this may not be as relevant to you in terms of the actual experience of building out the application and the Capstone project, but this is still a very good learning moment to understand that these things can happen. And I just want to guide you through some of the steps that you can take in order to go through these kinds of upgrades. So it's really not that scary. It seems way scarier than it is, but it's just one of those things that you just want to follow the instructions and go through your application, take it slow, one by one, and then finally make the upgrade. So now that we have installed React Router version 6, and I've gone on this little tangent right now about explaining some of these library changes, let's actually implement React Router version 6 into our application. Welcome back, everyone. So now that we have React Router DOM and we have an idea of how routing works, let's just go over with our final application what it is that we need to build. We know that inside of our actual application, we've simply implemented this component, the directory component. What we need to do now is we need to separate the couple pages that we have. We know that this directory component primarily lives on the home page, which is the page that you have when you land on the website. We know that there's also a shop page, which will render this directory of all of the different collections that are available. And then we also know that deeper down, we have this further library page that contains the products for a related category. So what we want to do now is we want to think about what we want to break up. So currently we have no pages, no routing setup. Everything lives on the main page, and even on this main page, we notice that this navigation component also is intended to persist while we navigate through the website. So this kind of harkens back to that lesson where we were talking about how routing works. And what we're essentially saying is that the home page should be the component that renders when your URL is just the base URL. This navigation bar should always persist no matter what different page you navigate to. And then at the very least, we'll have a couple other pages based on this route changing. So let's start implementing some of this stuff with React Router DOM. Let's go back to our application. In order for us to confirm and tell our application that we want to use React Router DOM, what we need to do is we need to actually wrap this entire application in a router component that React Router DOM gives us. I want to do it in the index.js because this is where we render the app as its entirety. So I want to wrap it as well in this same file. To do so, what we need to first do is we need to import the browser router component from React Router DOM. If you're wondering why there's a browser router, the browser router is the generic router. It leverages the URL in order to keep track of the history of where the user is navigating through, and it behaves as you typically would expect any kind of routing based on URL to behave. There are other forms of routers inside of React Router DOM, but you won't really use them a lot. And at least for our application, most of it is going to be working with the browser router. The other variation ones you can take a look at. Once you understand essentially how routing works overall, there's just a couple nuanced detail differences between them. So it's still relevant for you primarily right now just to focus on the browser router. Now, the browser router, as I mentioned, is a component. So that means it behaves like a component. There's an open tag and a closing tag. And what we want to do is we want to make that the parent of our entire application. So we want to make sure that we save this. And what happens now is that because we've wrapped our application component inside of our browser router component, we can access all of the different features that come in React Router DOM specific to this browser router that is now going to control all of routing inside of our nested application. If that sounds confusing, don't worry. It'll make sense once we start going through it. So let's start thinking about what we need to break up. Right now, app represents our entire application. However, it renders the directory directly. We don't want that anymore. Instead, now we want to render a home page, and the directory kind of just lives on the home page. So in order to do this, what we want to do is we want to actually set up some components to help us. And these components we're actually going to make a new folder for, and we're going to say that these are our routes. Routes is a folder that will hold all of our route top level components. So let's do one so we understand what we're talking about here. I'm going to make another folder inside of the routes folder called home because that's the route we're trying to make. And I'm just going to call this home.component.jsx. This is not some specific naming structure you have to follow for React Router DOM to work, but this is just the way that I like to break up this application. So it's very clear to me what the separation of concerns is, because the components inside of the routes are related to routes. They're not these generic components that we're building that we can use in numerous places. Essentially, these home components or these route level components are really only used for routing. And I'll talk about more about that once we get to the portion where we use them. But first, what we want to do inside of our home component that I've just set up here is we want to actually replicate what we had inside of our app. because this right now reflects almost the entirety of our application homepage. So just copy this entire file over, paste this in, and instead of app, let's call this home. Similarly, we want to make sure that we make sure to export home as the default. So nothing new here. This is really the only difference. Another thing we might have to do is we have to fix this relative pathing, because right now we're probably not actually going to the correct place. So what we want to do is leverage the autocomplete. And from here, we know that we're going to see home. What we want to do is go to components. So there we are pointing to our components folder, and then that in turn will point to directory and get the directory component file. So here, this home component is really all we're looking for. So just to make sure it's still working, what we're going to do for our entirety of our app now is just import home from routes, home component. And instead of rendering all of this, I want to just render the home component. This is just a test that this component works. Remember, even though it's nested inside of the routes folder, it's still just a generic component. It's just a functional component that returns what we had before inside of our app.js. But now we're just exporting it as a component and then just returning it. So it's just an extra step of rendering an additional component, but everything is the exact same. Let's just go back to our application, make sure everything is working. Everything is still working. So let's go back. What we want to do now is we now want to actually leverage routing so that we know how the routing works, with this actually being the thing that only renders when the URL is pointing to home. So to do this, what we need to do is we need to import the routes component from React Router DOM. So routes is a specific component that we get back. And we also need to import a route component. It's with these two components that we can actually assemble the routing at our application level. So I want to take routes, and just as we did, we want to wrap anything that is going to be routable inside of this routes component. Let me just fix this bracket here and fix some indents. So what essentially routes does is that it allows this application to register these route level components that will then in turn render a specific component when it matches this specific route that you're looking for. So how do you know what route you're trying to match? Well, the way you do that is you actually give it a specific path variable. Path is going to be a string, and the string is going to try to match whatever you give inside of it. So when you want to match, say, just a slash, this in turn will say, okay, when I match path slash, meaning that because this is at the base URL level, when we just land on the URL, then I'm going to match. So you can kind of see slash as in this is the end of the path we're trying to match there. So this is the relative path. And what I'm going to say here is that the moment this matches, I want you to now render this element. Element in this particular case is the component. And this is going to take literally a rendered component, and I'm going to render in the home component. So now I want to save this. And what we should expect to see in our application is that nothing has changed. So here we see everything still working. Let's just also quickly open up our developer console. We see there are some generic errors for dev tools, or not errors, but warnings. So everything is actually still working as we expect. But in case you're a little confused about this, because we learned a lot very quickly, and we have to kind of scaffold some of this out before I can deep dive into this topic, let's just take a look at this. As I mentioned, if you want routing to appear in your application, here we have to say, oh, there are these routes that I'm going to leverage and show you in these components. You're saying that by using this routes component, I expect there to be some routes inside. And the moment you match a route where the path value matches the string, then I want you to render this element. So let's be even more experimental. I want it to specifically be when it's at /home, then I want you to render the home element. Here, if we go back now, we actually see, remember, we're on the base route, which as I mentioned is the single slash. as you can see here. We, in fact, even get a warning that says no routes match for location /, which makes sense because we are not rendering anything for this route. We are trying to match /home. So if we navigate instead to /home, here we see the component rendered. So now we can see how we're rendering specific components based on the route, as in the URL that we are specifically navigating through. So here we are enabling that functionality, as I mentioned. I want you to render specific components based on the URL, which is exactly what we're doing. So if you're a little confused, don't worry. We'll do a lot more practice and we'll do a lot more experimenting with this library because it's a little complicated if you've never come across routing before. So don't worry. If any of this was confusing, rewatch the parts of this video where we walk through implementing these routes because there's a couple steps and they're all pretty crucial. We'll definitely explore them though in the upcoming videos. So this is how we set up our home page. Let's continue in the next video. Welcome back, everyone. In the last video, we started learning about leveraging the routes and the route component from React Router DOM. We're going to dive much deeper into routes especially because there's a lot that we can do with this and there's a lot more nuance that we're going to learn about. But I want to highlight one quick thing. The reason why these components are able to connect to the URL and therefore render the appropriate element is because of the fact that these are nested inside of the browser router. You remember that I mentioned that you want to nest your application inside of the browser router component or whichever router component you choose to use and leverage, most of the time it being browser router, because by doing this, you're extending that ability to read from the URL and keep track of navigation history and all those things and respond in turn with it because those components, the routes and the route component, rely on being wrapped in an outside browser router component. So our app component is really just the entry point, but all of those components that we leverage are now nested inside a browser router. So that's what I meant earlier in the previous lesson when I said you want to wrap your application inside a browser router so you can leverage the underlying browser functionalities when it comes to navigation. Now inside of the home route, I have switched the path back to just the /, and we're going to dive a little deeper into understanding how this route component works. So you don't have to type this along because we're going to delete it anyways. This is really just to highlight a quick point. I'm going to make a really quick component, and it's just a component that renders an H1 that says, I am the shop page. And what I'm going to do is I'm going to duplicate this route. And instead here, I'm going to say, when you land on -shop, render our shop component. So I'm going to save this. And now when we go back to our application, if we navigate to /shop, what do we see? We see that we've entirely removed the home component and now we're rendering the shop component. So everything here behaves as we expect. We know that when we pattern match, we want to strip out everything that we had before, but now we want to render in what's appropriate. But as I mentioned earlier, what we want to show is this consistent navigation bar. So how do we do this? Well, as it turns out, there's actually a few patterns that exist within React Router DOM and its components that allow us to do exactly that. So in order to understand that, we're going to have to modify our code a little bit. The first thing we're going to explore is this concept of nested routes. In order to nest routes within the other, what we do is instead of making these just one-line closed components, we essentially make them components where we can embed children between them. So here I'm going to take this shop route and I'm going to nest it inside of the home route. So instead of using the auto closing tag, I'm just going to open up this component and then nest the home route inside. What this now does is actually a couple things. The first of which is it makes the path that's nested inside relative to the path of the parent. So what this means is that you can imagine that for this route path to match now, it's going to have to match the parent first, so /, and then it's going to have to match the inside, which is shop. So I know this doesn't really seem any different from what we had before, because before our path was matching this anyways, but they're no longer siblings. This is a child. So what this means is that if this top level was /home, in order for this to match, it's got to be /home/shop. So let's just keep these paths so that we know what's happening here. So let's go back to our application. We notice that now we're no longer rendering on the empty plain URL. Instead, we now navigate to /home. We see our home component as we expect. What do you think is going to happen when we navigate to /shop? Let's see. Well, isn't that interesting? We still see our home component, but we don't see our shop page component. Why is that? Well, there's actually a couple things to notice. The first is that the parental component is still rendering, despite the fact that we're now matching beyond /home/shop. And this is one important thing. This means that our parental component at that parent level route is going to render unless we tell it otherwise. So that's one important thing, and I'll explain how we do that after. But the other thing is that even though we have /shop matching, our route is not displaying its element. Why is that? The reason for that is because we have not actually told our code where we want this matching /shop component to go. The way that we do that is we actually have to go into our parent level component, and we need to tell it exactly where we want React Router DOM to render this nested matching element. And the way you do that is you use another component that we get from React Router DOM called an outlet. This outlet you can see as an outlet where the code that we want to render should come out from. And we would use it inside of our component. Now, because as I mentioned, you always need one parent level component, I'm just going to make a new div, and inside I'm going to render the outlet. Wherever you render the outlet is where, when this route matches, is going to render the element. So shop here is going to render above the directory. So let's back to our code, and here we see that's exactly what happened. If I move this outlet below the directory, we see now it's below our directory. So that is very powerful because the outlet now allows us to leverage this pattern matching and this nesting structure in order to dynamically change portions of our code based on the routes and the nested routes. So with this in mind, we can kind of start to see a pattern emerge where we can keep the navigation bar, but just change the content inside using a specific nesting strategy. That's what we're going to do in our next lesson. I want you to think about it a little bit first, just so that you're familiar, because we learned something really interesting just now, and it might be a little confusing with these nested routes. But just really sit and think about it a little bit, and imagine in your head how you can imagine this composition we're about to do in the next video is going to look, so that we can maintain a navigation bar. So think about that, and then join me in the next video, and let's do that together. Welcome back, everyone. In the last video, we learned about nested routing and the outlets that in turn will render whatever the nested matching route will be. So here what we see is that this directory component is staying persistent despite what gets rendered as a subroute. So what we know then is that perhaps we can leverage this pattern for our navigation bar in order to continually render our navigation bar regardless of what path we navigate to. So let's leverage this idea. Let's go back to our application and let's actually think about what we need to create. We need to create some top level navigation component. I'm just going to call it navigation for now. We can rename it after, but for the purpose of this lesson, let's just make it very clear. This navigation component is going to contain a div. Inside of this div, I'm just going to put some kind of div placeholder that has an h1 that says, I am the navigation bar. We'll fill it with an actual navigation bar after. But with just this, we know that this is going to be some component that always lives on the page. It's going to be essentially the parent level component because it holds the navigation bar. Inside now, whatever's underneath the navigation bar should render the home page or the shop page, respectively, depending on the path. So to do that, we're going to utilize an outlet. So I want you to set this up first, and then I'll explain in detail what's happening in case this is a little confusing. So this navigation bar should be at the top level. So at the very top level, this should nest everything. And it should nest it under /, and the element that it points to should be this navigation component. Inside of here is where we now want to render our appropriate sibling components. So instead, remember, shop is nested under home. We don't want that anymore. We want these to be siblings of each other. And I want this home, just to be explicit, let's just keep it home for now. And now let's nest these inside of here. Now, if we save this, what we should see is that when we're on the home page, we just see our navigation bar. If I go to /home, I see the directory. If I go to /shop, I see the shop page. So far, the navigation bar is persistent. But when we land on our website, we do want just this base path to show the directory instead of having to go to /home. So how do we do this? Well, instead of pattern matching path like this, we can actually use the term index. And index is an attribute. If you pass index like this, it's actually equivalent to saying index is equal to true. It's just shorthand. But what this tells this route is that when you match just this /, so with nothing on it, then this should be the home component. That's what you render at the outlet level. So match this / when it's empty as the base component. So we know that we already have a parental component, but render whatever the base is inside of the outlet. So here now, if we save this, we go back, we see that we don't have anything. We don't have /home, but we see our directory. And now if we navigate to /shop, we should see the directory disappear and we see our shop page. But the main thing is now we're persisting this navigation bar. So this is actually our top level component. This outlet will now in turn render everything else inside. So we have now leveraged that specific pattern utilizing the outlet that we had previously in our home component, but now we've moved it to this top level navigation component. And this top level navigation component is kind of like the template. It essentially represents the thing that should always be present. And the thing that we decided to be present was going to be this navigation bar component. Inside this outlet, this is what we'll swap based on the remaining route matching inside. And this pattern matching, this deeper nested route matching, you can do continually, however nested deep you go. And that's the big advantage of React Router DOM. It takes a little bit of time to wrap your head around this concept, but we'll get a lot of practice. But here we can see how we leverage this outlet pattern now in order to persist the navigation bar. So we're definitely going to leverage this pattern a lot throughout the rest of this application. In the next video, let's style this navigation bar so it looks closer to what we actually have in our final application. And then we can continue building out our routes and building out our pages. So I'll see you in the next video. Welcome back, everyone. In the last video, we learned about nesting components inside of the routing structure, and we're starting to set up our initial navigation bar component. In this video, we are going to dive deeper into actually styling it out and structuring our code according to our folder structure. So the first thing that I want you to do is I actually want you to take this navigation component and put it inside of your routes. So I'm going to make a new component or a new folder for our component inside of our routes folder called navigation. Inside of navigation, it's going to follow the same format where we have a navigation.component.jsx file. Then we're going to go back to app.js. We're going to cut out this code for navigation, and we're going to paste it inside of our navigation component file. Then we're going to copy this outlet code because that's where we need the outlet from React Router DOM. Because remember, we're using the outlet in order to actually render these nested components inside of our navigation. And then I'm going to export default navigation. The same setup we've been doing all this time. Now inside of app.js, because we're now no longer leveraging navigation that we had defined inside, we need to import it in. And we also need to get rid of outlet because it's no longer a dependency. And here we're going to go up to our routes folder, our navigation, and our navigation component. And now all our code should work the exact same. So let's just check. we see that we have our navigation bar and we have our navigation bar on our home page. So everything's still working. When we look at our application here, our final application, this is what we want the navigation to bar to look. Right now, it's just some text. So let's start building it out. Let's go back to our navigation component, and let's remember what these divs are. This outside div is almost like a div that contains everything, so the entire page. Instead of using a div here, we can actually use a fragment. And a fragment is something that we get from React. It's essentially a component that actually renders to nothing when it actually gets mounted on the DOM. The whole reason of using a fragment is because of React's rules where a component must have a parent, a top-level parent containing a component. A fragment is useful if you don't actually want to render some specific HTML element. For example, if I just want a div that represents the actual navigation, and then I want the components that represent my pages down below, I don't need a wrapping div. I can just use a fragment. So with this fragment, once it actually finally renders, nothing's going to render on the page, and we'll check this out. So let's save this code, and let's just give this class name for now, navigation, so that we know what we're looking at when we look inside of our code. So let's save this, let's go back, let's refresh, and let's just inspect the elements on this page. So here inside of elements, what we see is that this is our navigation, and then right away it's our root. This root is the entry point. If you remember, we use react-dom.render targeting this div. But other than the navigation and then the inside div that contains the homepage element of directory, there is no other wrapping div. So as you can see, there's actually no fragment on here. And that's the beautiful thing about React Fragment. Very useful. So let's go back and now style the rest of our navigation. So we have this navigation component. And what we know is that there is a logo component here. So for now, I'm just going to make a div, and inside I'm going to say logo. We're actually going to import in the logo SVG file, and I'm going to explain that after. But I'm just setting up the initial basis of the application first. There's also a div. And inside of the div, this is going to hold all of our links. So here we can say that this is the links container, because that's what it's going to contain. It's going to contain all the possible links that we can go to. And then inside of here, we're going to actually have links that take you to the different pages or routes that are available. So inside of here, let's import in the link component. And link is essentially an anchor tag, but what it does is that it actually appropriately dynamically uses the correct browser that you have installed, and it will take your application to that specific place. Now, this is not so important for us because it behaves pretty much just like an anchor tag inside of a browser router, which is what we have. But if you were using other types of routers, there might be a little bit of different behavior. That's not so important right now, because right now, all we need to know is that this link component is what we utilize in order to leverage proper routing, just like we do with anchor tags. Now, because we're probably going to want to style these, we should also give it a class name. So I'm going to give it the class name of link. We can even call it navlink if we want to be more specific. In fact, let's call this navlinks container. So here is navlink. And then inside, in order to tell this link where we want to go, we give it the to property. And here we just match the string we're trying to navigate to. So I want to go to /shop. Inside of the link, we put some text. Let's say we say shop. And then finally, this should be the very formative basis of our component. So once again, because we want to style this, let's just see what it looks like first. We see there's a logo, and then we see there's shop. If I hit shop, it takes me to shop. Right now, there's no way of going back other than pressing the back button, but we want our logo to be the thing that will allow us to actually go back as well. So the great thing about link is that it's just like an anchor tag. Whatever you wrap in a link will give you that navigation functionality. So let's make a new link that we wrap around our logo. As for the link itself, instead, this class name should be our logo container, because that's what it is. It contains the logo. We might want some different styling for it than we do for our nav links. And then instead, where it should navigate to is the slash, because that is where our homepage lives. So now if we save this and we go back to our application, if we click shop, it takes us to the shop. And now if we click logo, it takes us to the homepage. So here everything behaves the way we want it to. We've got in some navigation behavior now, all thanks to the link component that we get from React Router DOM, which again behaves like anchor tags, but with a little bit of additional functionality according to the needs of React Router DOM. And finally, we have separated out our navigation component into its own component. So a lot of good work with navigation now. In the next video, what we're going to do is we're actually going to bring in that Crwn SVG for our logo. And we're also going to start styling out this navigation. So we'll see you in the next video for that. Welcome back, everyone. In the last video, we learned about implementing our navigation component as well as utilizing this link component we get from React Router DOM. In this video, we're going to actually replace this logo with an actual logo. And we're also going to implement some styling for this navigation bar. To begin with, we need to bring in an SVG that I provided you for this logo. So first, what you're going to do is you're going to make a new folder, and you can call it assets at the top level. Inside of this assets folder is where you're going to place your SVG. So inside, if you open up your resources folder, you should find this crwn.svg file. And I want you to drag that, download it, and put it into your assets folder. Here, you'll see that this is what the actual logo looks like. And what you'll also notice is that if you look in the actual file itself, it's a bunch of HTML. SVG is a scalable vector, which means that no matter how big or how small you make it, it will always have these crisp, clean lines. There will not be any of that pixelation that you see with PNG and JPEGs as you scale and reduce them. So that's why they're great for logos. So once you have it in, you need to actually use it. And the great thing about React is that we can actually import these as components. So here I'm going to say import React component. And I'm going to say this is as the Crwn logo. And I'm going to import this from our assets folder. And you can just directly use this like so. It'll be a component. And the other thing we want to do is give it a class name of logo. And now if we save this and we go back to our application, we see that we have our Crwn logo now. If we go to shop, there's the shop page. If we click it, it behaves the way we expected it to. So this is everything that we wanted it to. The next thing we want to do is we want to implement the styling. So what you should do is open up navigation.styles.css, add that to your navigation, just like we always do. And what we're going to do now is you're going to go again into your resource folder, download the navigation styles file, and then paste it in. Now, once you've pasted it in, just save your styles file, and remember to import this styles file into your navigation component. So let's just import the relative route, as we've always done, importing navigation.styles.sass. Let's save this, and let's go back to our application. And here we see that our bar and our styling has been implemented. Now, one thing you might notice is that the shop link has this underline. This is because the default styling that browsers apply on our anchor links. So we don't want this, and we want to change this behavior across all of our anchor links. So let's go back into our application. And we're actually going to make a couple tweaks to our index.sass file. So this index.sass file is the default applicable styles that we want inside of our application. This essentially is styling that we want to do when we need to reset things or when we want it to apply across everything, which is why that's where we put our font family. There's two things I want to do. The first is I want to modify our anchor tags. And here I want to make it so that there's no text decoration. Text decoration none. This will first of all get rid of that underline when you've got a link that's been visited. And then I want to change the color to black. And here if we save this now and we go back, we see that our link behaves the way that we expect it to in our final application, where it just looks like a black text. Now, there is one more thing that I want to modify. And to modify, I need to show you something. Let's first inspect our element of shop. Looking at this div here, let's say that inside of our styles, let's just imagine that what we did is we added some hard width value of 50 pixels. So here we see that this has a 50 by 70 dimension. So 50 width, 70 height. If I were to add padding 25 pixels, now if you highlight it, you see that the actual dimension has gone up to 100 by 120. So the overall width and height of our element has increased by 25 pixels on each side. If you scroll down, you actually directly will see a visual representation of this. So you'll actually notice that border and padding will both increase the width of your element. This is not intuitive. What we actually want is for the padding to be accounted for inside of the actual width and height of the elements that we have. You don't want to add padding and add borders that will modify these values. It just seems unintuitive because if I say that the width of this element is 50 pixels, the width should never change. The way that we're going to do this is we're actually going to say that I want this box sizing to be border box. This now, instead, if you hover, you'll see that because of our padding, it's kind of thrown off the placement of it in terms of where it's being highlighted. But you'll notice that the width and the height is still 50/70. So this just means that if we actually add padding, we just need to make sure they're realistic values, something like 5 pixels, for example, for this component. But what we still want to do is make it more intuitive for us. So we want all of our elements to have box siding, border box. And remember, all that does is it just makes it so that your padding and your borders don't throw off the dimensions of your component that you've defined. And to do this, inside of our index.sass, we're also going to do star and then box sizing border box. This star matcher is a selector that matches everything. So anything that can be matched will be matched, and it will apply box siding border box on all of them. And that is the changes that we want to make. And now we have pretty much our navigation component. We can now easily add any new nav links into it by generating new links and putting them inside of our nav links container. And then our logo is done for our homepage. And here now we see that this behaves exactly how we expect it to. This now is already starting to look much closer to our final application. So now that we have this, in the next video, let's actually start building out more of our application and filling in more of these links. I'll see you in the next video. Welcome back, everyone. In this video, we are going to start building out some of our reliance on the front end with some kind of database. So in this course, I'm not actually going to build a database from scratch. We're going to leverage a great existing tool made by Google called Firebase. And what Firebase is going to help us do is we are going to be able to build out our sign-in page using authentication so that we can store the users and refer to those users and sign in those users whenever anyone wants to access our application. Luckily for us with Firebase, we can also leverage sign-in with Google, which is Google Sign-In, which we'll talk about after we learn about Firebase first. So what is Firebase? Firebase is a Google platform that allows you to spin up a database. It actually is a pretty comprehensive suite of hosting tools and different things for your website, but the primary usage is that it helps us leverage some kind of database. That's the most important thing, so that we do not have to set our own up. So what I want you to do is I want you to go to firebase.google.com or click the Firebase link inside of your resources folder. Once you're inside of Firebase, I want you to click Go to Console up in the right corner. What this will do is this will take you to the list of all of your existing Firebase projects. I already have one because we've had this application course now out for almost 2.5 years by the time of this recording. So what you're going to do though is let's make a brand new one. I'll make a new one with you. I want you to click this Add Project. And here, I want you to name your project whatever you want. I'm just going to name mine Crwn-Clothing DB. So here, this will be my project name, But down here, you'll notice that there's this unique identifier for your project. So this pretty much just allows Firebase to say that once you instantiate up your instance of Firebase, this is your Firebase platform's unique ID. So whatever it generates, you can just keep it, or you can name it something else if you want. But here I'm just going to say Crwn-Clothing DB, and then I'm going to hit continue. Next step, they're going to ask if you want Google Analytics. I don't want Google Analytics because this actually makes it a little bit more complicated. I also don't have a Google Analytics account that I want to tie to this project, but you can do so if you want to with your Firebase. But honestly, for the purpose of this project and for this course, we're not going to touch it. So from here, we just create the project, and now let's just wait for our project to finish building. Okay, so our new project is ready, and what you're going to do is you're going to hit continue. This will now take you into your actual Crwn-Clothing database, or whatever you named your Firebase instance. And there's two main things that I want you to focus on inside of your project. One is authentication, and one is these two database options. We are going to use Firestore database because this is the newest instance. Real-time database is their old database. So don't worry about that, just ignore it. We're not going to use much storage or hosting. We might use some functions, but that'll be later. We won't use machine learning. These are all just a different suite of tools that comes with Firebase. But we really just want to leverage Firestore database and the authentication. So we have this instance now set up. But before we start using it, there's a couple things we need to do. We need to actually allow our React application to leverage Firebase and Firestore and authentication. And to do that, we need to install the Firebase library. So in order to install Firebase, let's go back to our terminal. Inside of our project, we are going to type yarn add Firebase. Now at the time of this recording, the version of Firebase that is going to install is 9.6.6. Google does like to change up Firebase every once in a while, but generally speaking, they're always backwards compatible, meaning that whatever you learn here is also going to be largely compatible in the newer versions. Maybe the UI that you've seen changes, or maybe the docs change a little bit, but largely speaking, the high-level concepts of Firebase is all going to be the exact same. And it's really important that I teach you these high-level concepts. It's also important that you learn these high-level concepts, because unfortunately, especially in React and with the front-end world, things constantly change. Libraries change. A couple years is a lifetime inside of the front-end world. So you need to really be able to understand these high-level concepts so that when the libraries change, you still largely know what's going to happen. You might just update the syntax a little bit, follow some new patterns and conventions that they believe will leverage and give you greater capability. But generally speaking, the most important thing to understand is these high-level concepts. So now that we have Firebase installed, what we're going to do is we're just going to go into our application and just set up a quick route for sign-in. So inside of routes, I'm going to make a new folder called sign-in. And inside of this folder, let's make a new file called signin.component.jsx. And this is just going to be a very simple component. So I'm going to call it sign-in. It's a functional component that just returns a div. And inside the div is just an H1 that says sign-in page, just so that we know that our routing is working. Remember, it's always important that in order to minimize your errors, just code a bit at a time. Start with what you know, make sure it validates and works, and then continue. So here, let's duplicate our route path, and the path should go to sign in. And the element that we want to render is going to be our sign-in component. So here, I'm just going to say import sign-in from routes sign-in component. And then instead of rendering shop, I want to render sign-in. So this, of course, is nested inside of our root level route. So it will be /sign-in, as we know, just like we saw with home and just like we see with shop. And once we have our sign-in, what we also need to add is a way to get there. So inside of your navigation component, I want you to duplicate this second link and inside say that it goes to sign in. Actually, let's use the dash. I kind of like this syntax a little better. So let's go back to our app.js and switch this route to sign-in like this. And then let's make sure that we say that it's a sign-in link. And now let's verify this works. So we've added a link that takes us to /signin, and we also included a route that points to the path sign-in and renders our sign-in element. So we're just rehashing everything we've done so far and learned so far about navigating in React DOM. So let's go back to our application in our browser, and we see that we now have a sign-in button inside of our nav link. If we click it, we see that we're also rendering our sign-in page. So everything is working as we expect. Sign-in is working, and now what we need to do is actually bring in Firebase, the library that we downloaded, into our application and write some code to leverage this library, but primarily leverage this library so we can actually access this instance that we have of Firebase that we've also set up. So in the next video, I'm going to talk about how we do that and also get a better understanding of a lot of these external tools and how these libraries that we're using actually connect with them and understanding the better practices on the front-end web. I'll see you in the next video. Hello everyone and welcome back. In the last video, we talked about Firebase. We set up a Firebase instance on the Firebase console, and we also brought in the Firebase library into our React application. In this video, before we actually get involved with writing more code, I just want to take a conceptual break and understand what is happening behind the scenes when we use Firebase, as well as how that actually interfaces with our front-end application. This is valuable because as front-end React developers, or even as full-stack React developers, it's very important for us to understand our piece on the stack when it comes to interacting with data. So let's begin with the concept of CRUD. Now, if you are familiar with backends, if you've done any work with servers or anything even remotely similar, you will know what CRUD stands for. But in case you don't, let's break down what CRUD stands for. So CRUD represents the different ways that we can operate on stored data. This stored data usually lives in a database. And generally speaking, you can only perform 4 actions, which is what CRUD stands for. The C stands for create. So you can create data, of course. The R stands for read. Read just means getting data. You don't want to modify the data, you just want to retrieve the data. So think about our front-end application. If we wanted to fetch some data from a backend, then we're asking to read that data. We're not asking to modify that data, we just want to read the data. Update is updating the data. So if we want to change some of the fields, if we want to change maybe some of the values on a piece of data, then we want to update it. And then of course, delete just means deleting that data. So these are pretty much the 4 instances of which you can do in order to operate on stored data. Let's imagine that we had our web application, Crwn-Clothing on the left here. On the right, you have your Firebase server, which is hosting your database. What you would do is make a request from Crwn-Clothing to fetch data. So here we're asking to read for some specific data from Firebase. Maybe this is a user profile. Maybe this is something related to a collection of clothing. Maybe this is even a very specific article of clothing. Maybe it's a receipt. You can imagine that the majority of the data in an application would not live on your front end. The reason for this is because if you think about a front end, you have different users that log in and log out of your front end. So as a result, they have specific data that's unique to them that they want. You can't persist this on the front end. You must have this live in some database. So for us, that's going to be Firebase. So when we want that data, we're going to fetch that data, and in turn, Firebase is then going to send back the requested data. This is going to be the same when you're trying to update some data, you're going to create some data, or you're going to delete some data. You're still going to send from Crwn-Clothing, your front end, that request to do that to the data to Firebase. Firebase will then perform the action and they'll return something back, either the updated data or the created data, or even a confirmation that the data has been successfully deleted. This is the whole basis. It's very simple. You send a request, you get back a response. This is the interaction between a front end and Firebase. But let's think about some things that make this business case more relevant. Firebase represents our database. Our database is going to store all of our data, whether it be our user data, our collection of clothing data, maybe invoices, maybe people's credit cards, maybe even all of the earnings. There's a lot of things that can live in a database for a company. So this means that a lot of this data is really sensitive, and we don't just want anybody to be able to create that data or read that data, update that data, and definitely not destroy that data. So what this means is that we need safeguards. We need some method in order for us to prevent the majority of people from doing things that we don't want them to. Or we want to make sure that specific pieces of data that are sensitive to somebody, such as a person's credit card information, should only be accessible by, most likely, only that person. So this is where authentication becomes important. So let's take a more direct example. Let's say that I'm using Crwn-Clothing.com. What I'm going to do is I'm going to request from Firebase my profile data. Maybe on this profile, it has a list of my orders, like my order history. Maybe it has my credit card information. It might even just have my email, my address, and my phone number, all of which are very sensitive data. As a result, Firebase, before it sends me that data, needs me to confirm that I can access this data. Because Firebase doesn't know. How is it going to know that I should be able to access this data? Chances are, in order to do that, I need to authenticate with Firebase. I need to confirm to them that I am who I say I am. And who I say I am is somebody who's allowed to access this profile data. So to do this, maybe I sign in with an email or password, or in some way, Firebase needs to be able to confirm that I am the person who should be able to access this sensitive data. And once I'm able to do that, then Firebase should give me back my profile data. This is going to be the exact same for another user. Let's say Andre accesses our website and he wants to access his own profile data. He's going to go through the exact same authentication flow. He's going to authenticate with Firebase that he should be the person that should access his own profile data. And once he does, Firebase will return that profile data. But if Andre tries to fetch my profile data, Yihua's profile data, unless he can authenticate as me, Firebase is going to say, hey, you know what? There's an error. You are not authorized to get this data. And this is where authentication becomes extremely important. And Firebase has allowed us to leverage both email and password authentication, but also it allows us to use Google Sign-In. So let's imagine and think about how Google Sign-In works. So here we have our website, we have Firebase, and we also have Google servers. On Google servers, it has a bunch of different users that it knows to be who they are based on the fact that they pretty much own your Gmail account, or at least they're aware that when I, Yihua, am trying to access, let's say, my own Gmail account, yihua@gmail.com, Google knows, oh, I know who that user is. If you've used any web applications in today's era, you'll pretty much see Google Sign-In or Facebook Sign-In, even GitHub Sign-In everywhere. It's very prevalent because they know that you are some user. They've authenticated you as the person that you say you are. And they know that the email is unique. So essentially, because they know that, they can share the fact that they know that you are who you say you are to different applications. So remember, that's really all authentication is that it's able to authenticate that you are who you say you are to an application. Google knows you are who you say you are because you have to sign into your Google account, meaning that your email and password should be something only you know. So if you sign into Google, Google's pretty sure that you're probably a person who should be accessing this account, at least most of the time. So Google then can lend that to other applications because Google has authenticated you. So really that's what Google is doing, is Google is helping you authenticate to other applications so that you don't have to make an account for those applications. So let's walk through a flow. Let's say for our Crwn-Clothing, I'm trying to access Crwn-Clothing. What I do is I use Crwn-Clothing's Google Sign-In. So we're going to implement this feature next, but we're just going to walk through a high-level flow. So I'm going to make a request to Google server saying, hey, I want to sign in for this user, yihua@gmail.com. I'm going to send over my credentials. I'm going to either sign in with my email and my password, or if I'm already signed in, I'm just going to tell Google, hey, I'm trying to sign in. What Google will do is say, oh, are those credentials correct? Yes, I can verify this person, so I'm going to generate an auth token. An auth token is just a unique hashed string. It's a string that's really hard to break apart, but essentially on that token is the confirmation that I am who I say I am, which is yihua@gmail.com. Google will then send that back to Crwn-Clothing. So now Crwn-Clothing has this auth token. Then what's going to happen is I'm going to send this auth token to Firebase, meaning the backend, or the server that Firebase is representing in order for it to verify whether or not I can access some of the data that I'm trying to access specifically. So yihua@gmail.com. Again, maybe it's my profile data, maybe it's my order history, whatever it is, Firebase needs to confirm that I am who I say I am. But with this auth token, it's not enough because Firebase doesn't know whether or not this auth token is valid. Remember, at this point, Firebase can't trust the source where it got the auth token. Somebody could have just copied it from somewhere and then sent it over. It might just be a random auth token. So Firebase needs to confirm, is this auth token a valid auth token? So what Firebase will do is it is going to directly ask Google, can you verify this auth token? Google takes it and it will check, oh, is this auth token one that I've issued? There, Google will be like, okay, if it's true, it's going to say, I have verified this token. If not, it's just going to send back an error. But let's say it's verified. Oh, this auth token is valid. I did issue this token. Google will then send back a verification token, which confirms that the auth token that we got was indeed a valid one. So now Firebase is like, oh, okay, that auth token that Crwn-Clothing gave me is indeed valid. Now, because Firebase has authorized this token, it is then now going to create an access token. This access token is going to define what the user should be able to access, the user being specific. So this access tells us what me, yihua@gmail.com, is able to access inside of the database. So then Firebase sends this back to Crwn-Clothing. And now me as the user with this access token, if I want to make different CRUD requests against Firebase, what I'm going to do is I'm going to send the request alongside the access token. Firebase is then going to verify the access token to determine what different things this access token has access to, meaning what is this access token authorized to do. If it is valid, then it will check the CRUD request and say, oh, okay, you are allowed to do and perform this request. So then what's going to happen is that Firebase is going to generate a CRUD response, meaning that it's like, okay, you want to create this data. If you're authorized to do it, I'm going to send you back the appropriate response. The same is true for read, meaning that I'm going to send you back the data that you want to read, update, or destroy. If those are valid, then I'm going to send back the appropriate response. If it's invalid, meaning that if you do not have access to perform that specific request that you are trying to make, that will also be in turn the appropriate response. And that response gets returned to Crwn-Clothing. And let's assume that it's valid and it's what we want. Let's say we want to read some data. Then our application will now take this data and in turn build the website with that data. And much of the communication from this point forward with our database is always going to need to access this access token, which is what we need to store on our front end. Because this access token allows us to skip having to verify every single step. This access token represents something to Firebase that we can indeed make requests against in the database. So this is a seemingly complicated flow because there's a lot of diagrams, but I promise you once we start building it, it'll be a lot more clear. Because once we start actually building it and implementing the little pieces on the front end, all of this will click in a more meaningful way. But if you're confused about the flow, just watch it again. Once you watch it a few times, if this is unclear, it definitely becomes a lot more clear because each step logically has to happen if you were to authorize a user. So now that we understand this, let's actually start implementing this inside of our code base. Welcome back, everyone. So let's pull down Firebase into our application. The first thing that I want you to think about is the fact that we are going to be interacting with this new API. The API in this particular case is going to be Firebase. Now, Firebase has a very particular way of doing things. So what we want to do is think about how we can abstract out this as best as we can. And Generally speaking, the easiest way you can do this is try and keep anything that you write when it comes to interfacing with some kind of backend API that might have some particular nuances to it inside of its own folder and inside of its own file in that folder. So in this particular case, what I might do is inside of source, I want to make a new folder and I'm going to call it utils. This is going to contain utility files. And the one that I want to make is a Firebase utility file. So I'm going to make a Firebase folder, and inside of Firebase, I'm going to make firebase.utils.js. So here, this is just JavaScript. We're most likely not going to return any JSX from this because this library is just for using Firebase. I'm going to link you the docs to Firebase as we do this so that you can follow along, but I'm not going to lie to you, Firebase documentation is kind of hard to read. It's very technical as per all of Google's documentation. I actually find Google to write a little bit of confusing documentation sometimes, very thorough, but sometimes a little bit hard to get started with. But essentially what we're going to do is inside of this utility folder, set up everything we need to get started. So in order for you to use Firebase, you actually need to import from Firebase and then / what it is that you want to pull in. So Firebase, as I mentioned, is a suite of tools. Firestore is one of the tools inside. So this suite, though, you bring down from the library as a thing called the app. So this kind of captures all of the things required to get Firebase running, including if it's internal services. So in order for you to get it, you need the initialize app function. This initialize app function creates an app instance for you based off of some type of config, which we'll talk about right now. This config is an object that allows us to attach this Firebase app instance to that instance that we have online. Because right now we have the library installed, but there's no way of us telling Firebase, oh, this instance that you're using should be referring to the one that you have created inside of Firebase console. Specifically this one right here. So how do we do this? Well, what you want to do is inside of the home page, you want to click this little part here that says web, because there's different ways that you can add your application to Firebase. So Firebase needs you to confirm how to do it. Now, what we want to register is a web app. So I'm just going to call this Crwn-Clothing web app because that's what we're building. It's our React web app. We don't want to do hosting yet. It doesn't even matter. But here now, just click register app. And what this will do now is it will generate for us a package. So these instructions, as you see, npm install Firebase, we've already done it. We have yarn installed Firebase into our application. What we really want though is this Firebase config. So I want you to copy this over. And even if you look this line, copy this over too, because we're going to do it because we already imported the initialize app. So here, when you paste this in, you end up passing this to the initialize app function that we get from Firebase app. What this config does is it identifies this SDK, which is essentially a developer kit that we're using, so the library itself. This library is just some JavaScript library that abstracts away some of the functionality that we need to use in order to interact with our instance of Firebase. So those CRUD actions I was telling you about, creating, reading, updating, destroying, authenticating, all of those things is going to happen using this Firebase app instance. So here I'm going to make this more clear by saying I'm calling this Firebase app. So initialize app takes the config. It's like, oh, this config tells me this is the specific Crwn-Clothing DB instance, which is the Firebase instance that we made a few videos ago. Literally, this instance that we're looking at right here in the console right here. This is the instance. This unique identifier, as I mentioned before, we see it actually right here, this project ID. Now, if you're wondering, typically speaking with API keys, aren't we never supposed to expose our API keys? Well, in Firebase, unfortunately or fortunately, this is not the same pattern. Firebase needs this API key, and this is not some super secret API key that you got to worry about. This is actually also explicitly stated inside of their documentation, so don't worry about this, but you need your own config. Your own config is going to be able to allow you to make Firebase actions, CRUD actions, to save, read, update, all those things to your own specific instance of Firebase. So now that we have Firebase set up, the next thing we need to do is we need to actually set up the authentication. Now, as I mentioned, Firebase kind of includes a bunch of different library packages for us when we installed Firebase. It wasn't just one library. It was a bunch of little micro libraries. One of them is anything related to authentication, and this is under Firebase/auth. So this is pretty much the auth service. And what we need from here is we need get auth, because just like initialize app, we got to create a auth instance as well. We also need sign in with redirect. Now, there's actually a couple. So there's sign in with redirect and there's sign in with pop-up. Let's take both because I want to talk about both. The other thing we need is also Google Auth Provider. So these are all namespace specifically from Firebase Auth. It's using these that we're able to create our Google sign-in. We can either sign in using a pop-up or we can sign in by allowing our application to redirect. And we'll walk through both. This is just very specific setup for Firebase. You can find all of this, again, inside of the docs that I'll link. So in order to use this Google authentication, we need to first initialize a provider using this Google Auth Provider class that we received. So here you want to call new Google Auth Provider, which in turn will give you back this provider instance. Then what we want to do is we want to call set custom parameters. So these custom parameters will take some kind of configuration object, and with it, we can tell different ways that we want this Google Auth Provider to behave. So generally speaking, the main one that we want is really just prompt, which will be select_account. So what this means is that every time somebody interacts with our provider, we want to always force them to select an account. I'll talk more about it once we've set it up and what this detail does. So really, these set custom parameters are primarily for Google authentication providers, which is specific to Google's own interface. Again, this is just some particular configuration that Google wants. Really, this whole file that we're setting up is just unique to the different types of configuration styles that Google in particular wants from us. So there's not a lot of logic flow here to really learn at a high level. You really just got to learn what they want for their tooling. And that tooling might change a little bit here and there. And honestly, that's really all there is to it. The other thing we need to do is we need to export our authentication, which as I mentioned, we need to create the instance. And then we also need to export out now this sign in with pop-up. So here I want to call it sign in with Google pop-up. And this is going to be equal to an anonymous function that's going to return, so remember, no squiggly brackets, we want to return sign in with pop-up. And what we want to pass to this is auth and the provider. So the provider instance that we created, as well as the auth instance that we generated, we want to pass both of these into sign in with pop-up. Now here you might be wondering, why is auth just a function invocation without the new keyword, whereas Google Auth Provider is one? So Google Auth Provider is essentially a class that we get from Firebase Authentication, and this is connected to Google Auth itself. Google Auth has many different implementations. This is just Firebase Authentication's own. So this is a class, and sometimes you want to generate multiple of these different providers because you might have different provider instances doing different things. For example, as we see with sign in with pop-up provider, you pass it a provider. Maybe for sign in with redirect, you pass it a different provider. These providers are kind of just instructions for this instance of provider, but you could have multiple different providers. Authentication, on the other hand, there's a singleton of, meaning that the way your application authenticates and the rules for authentication and the authentication that communicates with Firebase, this should always be the same one for every application. Why would you have different authentication services for one application? That doesn't make sense, right? Once you authenticate for this website as a whole, it should be held onto for the duration of the lifecycle of this application. You would not ever really need more than one authentication, whereas you might need multiple providers because you might have different buttons that trigger different forms of even Google sign-in with pop-up. Maybe some of them prompt you to select an account, some of them don't. You can imagine that there are different cases and use cases for these two. But essentially, now that we have this set up, what we want to do now is we want to leverage this. So in order for us to actually use this, what we need to do is we need to go back to our application and we need to go to Google Console. Now what you want to do is you want to go to this Authentication tab on the left here. And then in the top here, you want to go to Sign In Method. What we want to do is we want to click the Google because we want to provide the ability to now sign in with Google. We don't need to worry about any of these other settings for now. We'll talk about this domain one when it becomes important. For now, all you need to know is that localhost is authorized by default, meaning that this is a list of whatever domains that we allow our application to use Google Sign-In. Now, we're currently testing on localhost, so this is by default enabled. That's all we need. We don't need to touch that. Up here, though, we need to enable this sign-in. And then for the project support email, just choose the email that you want to be the one that forwards all the support emails for in terms of this authentication in this list. So here, this is my account, and then you just hit save. And that's all it takes. Now you should be able to access. It's enabled. So let's go back to our application. We've set up this file, so now we actually need to use it. So let's go into our sign-in component. What we're going to do is we're going to import in from our Firebase utils. So go to your utils folder, Firebase utils, and we want to bring in our sign in with Google pop-up method. What we're going to do is we are just going to create a log Google user, which is an asynchronous function. Because remember, whenever you make a call to some database, this is going to be asynchronous. So we want to get the value here by awaiting calling our sign in with Google pop-up. And then we just want to console.log the response. And then down here, we're going to make a button. And inside this button, it's going to say sign in with Google pop-up. And then we're going to set the onClick method so that it uses our log Google user method. So if we save this, and now we go back to our application, what we're going to do is we are now going to click this sign in with Google pop-up method. When we click this, notice that it opens up the Google pop-up prompt. I click the email that I've got here, and now we see we get back our user credential. And inside of these objects, what you'll see is that under the properties, you got the access token. Remember earlier in the previous lesson when I showed you the diagram of how our application communicates with Firebase, which communicates to Google, and finally the whole purpose is to get this access token using which we can then create CRUD requests. This is that access token. So just now, after we prompted the sign-in, it went through that flow that I justified to you. And finally, Firebase is giving us back the access token. So now we're able to make our CRUD requests. This is a lot of setup that we had to do for Firebase, both inside of our Firebase instance, but then also inside our Firebase utils file. I know we jumped around and we spent a really long time doing this video. This video is a really long lesson, but honestly, it's just to get through a lot of this setup. And there's a lot of different configurations and different things we have to learn about this. So thank you for sticking with me for this one. But now we essentially have our sign-in method pretty much set up. So in the next video, we're going to learn about how we can leverage this in order to actually start building in authentication. And we're also going to continue with Firebase. So join me in the next lesson where we'll move on from understanding what to do now with this authenticated user. Welcome back, everyone. In the last video, we learned about setting up our Google sign-in authentication into our application. However, there's one thing I want to make very clear. If you look inside of your Authentication tab, here you'll see your user that you signed in with. The one thing, though, is that this user list that you'll get whenever you do sign in with these different authentication services, whether it be Google Sign-In or any of these other sign-in methods that are available that you can add. We earlier added in Google, but you can do Facebook sign-in, GitHub sign-in, Twitter sign-in, email password sign-in. All of these different authentication provider services, they all add to your user list inside of the Authentication tab. But these are not necessarily users that are accessible within your Firestore database. So this is an important thing I want to make clear. The authentication service that you have here is a separate service from the Firestore database. Firestore is the actual database that we're going to be leveraging. And inside of Firebase, this is pretty much like a schemaless database. So schemaless just really means that it's pretty much a JSON object. You can store whatever fields with whatever values that you want. Of course, generally, you want this to be more consistent so that your data is consistent across users. Meaning that if you get user 1 versus user 1000, you can trust that the shape of the data is the same. Meaning that they have the same fields. Maybe they have the same first name field and the last name field with whatever the value of those users will be. But you want that consistency. Here, look inside and you'll notice that even though we've authenticated our user, we actually don't have any users inside of our Firestore. So what we're going to do now is we are going to make sure that whenever a user authenticates, we also create a record of them inside of Firestore. So now we're going to start actually storing that user's information inside of our database. So we're going to start working with Firestore database. Now, before we start working with this, there's a couple things we need to understand about Firestore. It's got kind of an interesting structure, and it takes a little bit of time to get used to the way to work with it, but we're going to walk through that in this video. So first, I got to show you a slideshow. So let's talk about Firebase's data model. Inside, Firestore is really comprising data of three things. There is the collection, there is the document, and then there's the data. So this visual is very good because it's kind of like looking about a folder. Inside of a folder, you might have multiple documents. On each document, the data related to that document is what's written on that document. So you can imagine that if we had a collection of users, we would make a separate folder with users on it so that we know that inside of that folder, it's all of our data related to every instance of user that is inside of our database. Each separate document represents an individual piece of data, so an independent user. Now, the actual information related to that user is going to be the data. So let's walk through this. Let's talk about the document model first. The document model is really the smallest unit inside of Firestore. So here, imagine we had a shoe because we are Crwn-Clothing, meaning that we sell clothing. So imagine that we had some unique ID for this specific shoe document. And it's Nike Air Max. It's just a unique string. This Nike Air Max inside will have data that tells you what the information regarding the shoe will be. So the name will be Air Max as a string. The brand is Nike. And then the image URL, imagine that points to some URL of the actual image. This is a data shape. This is a JSON object that kind of holds the information that is relevant to shoes. Now, if you look inside of this model, maybe sometimes, so far, some of these fields may be nested. So cost might actually be another JSON object. So far, what we saw with name, brand, and image URL, it's a single level, meaning that it just points to one value, in this case being strings. Whereas cost here is perhaps a JSON object that has two fields on it, a price, which might be a number, and then the currency that this price is in, so USD, which is a string. So this is something interesting that you want to know about documents is that they're pretty much JSON objects. But this is really just the majority of how our individual pieces of data is going to get stored. So if you were to look at the model, Nike Air Max here, that unique string with no spaces, that would be the name of this document or the ID of this document. Whereas down here, all of this information inside, well, that's the data. So I'm matching the gray to the data and then the blue to the document. So that's one thing that you want to know about. When you want to access the information related to a document, remember that what you're trying to get is the data for that document. Now let's talk about collections. So we know we're talking about shoes. So here, imagine that we had a shoes collection. Inside of that shoes collection, we might have our Nike Air Max example, which is just a document of a shoe living inside our shoes collection. But then we might also have Adidas NMD, which is another document. That's for another specific shoe. And you'll notice that the shape again looks very similar. They all have name, brand, image, URL, and cost, which is an object that points to price and currency. So you'll see here that the structure is the same, but the values are different. And that's because, again, shoes is the collection. Nike, Air Max, and Adidas NMD, those are unique strings that represent the ID of these individual separate documents. And then the values inside is the data respective for those documents. So any data that we're going to store in Firebase is going to generally fit inside this model of collections, documents, and then their respective data. So now that we have a rough high-level idea of these, let's actually start implementing and working with Firestore, our database, with these in mind. So I'll see you in the next video where we'll start doing that. Welcome back, everyone. So inside of your console, in order for us to start using Firestore, you need to go to the Firestore Database tab. And here you'll see some kind of introductory screen. If you click Create Database, and inside of here, just start with production mode. It's actually easier to work with production mode because all it changes are just the rules that allow you to determine who gets to set different documents. So just click production mode, hit next, and then by default, choose your location. I'm going to choose US Central because that's the one I'm closest to, but you can choose whichever region that you feel like is closest to where you're at. Honestly, it's not going to matter too much for the sample project anyways. So I'm going to choose NAM5 US Central, and I'm going to click Enable. Now what's going to happen is it's actually going to now generate the database for us. So once it's finished, you should see this view right here. Of course, as I mentioned, we have an empty database, so it doesn't even matter. And what you're going to want to do is you're going to want to click Rules here. Inside of Rules, these rules define who is allowed to modify what documents. Inside of here, we're going to really play with this a little bit later. Right now, we just want to keep it as general and open as possible because we're going to be the only people developing against it. So what I want you to do is I want you to switch this allowed read write if from false to true. And then you're going to hit publish. What this will now do is that this will allow us to make any modifications we want to any document inside of this database. It doesn't matter. We can read, we can write, we can do whatever we want. So that's what we want. And now that we have these settings, we can actually start implementing storing users inside of our cloud store. So let's do that. Let's go back to our application. And inside of our application, we want to go to our Firebase utils.js. Now, just like Firebase app and Firebase auth, Firestore, as I mentioned, is a different service. So we need to import some methods from Firebase/Firestore. And just like we did with getAuth, we need to instantiate our Firestore instance. So we need getFirestore. What we also need are three other methods. We need the doc method. And what this doc method allows us to do is retrieve documents inside of our Firestore database. But how do you get that data, or how do you set that data on these documents? Well, this is where you need the getDoc method and the setDoc method. So I know these seem like it's called getting the doc or setting the doc, but what they're really representing is you're getting the document's data or you're setting the document's data. Doc is what you need to actually get a document instance. But when you want to access the data on those documents, you need to use getDoc. And when you want to set the data, you need setDoc. So I know this verbiage seems a little confusing. This is just unfortunately how Firebase has decided to name these methods. But once you use them, you'll get more familiar. So now that we've imported our methods, let's actually instantiate what we need to instantiate. So first, as I mentioned, we know that we need to create the DB. So I'm just going to call this DB for database, which is equal to calling getFirestore. getFirestore. I accidentally auto-imported up here the type, but we don't need that. So once we've instantiated our Firestore, now we can use it in order to actually access our database. So this singleton instance allows us now to tell Firebase when we want to get a document or we want to set a document or anything like that related to our database. This is the database that we're going to pass because this actually directly points to our database inside of the console. So in order to use it, for example, what we're going to do is we're just going to create some method. I'm going to call it create user document. So I can even be more explicit. Let's call it create user document from auth. And what this method is it's an async function that receives some user authentication object, because that's really what we're getting back anyways from our Firebase authentication, our Google sign-in. Whatever we were console logging earlier here is what we're going to want to pass. We want to pass something specific, and we'll walk through what that is. But all we're thinking about right now is that we want some function that will take that data we're getting from the authentication service, and then we're going to store that inside of Firestore. So this is where things are going to get a little bit more confusing just because we have to follow along with how we use these methods that we've imported. So remember, what we need to do first is we need to see if there is an existing document reference. So when I say reference, this is a special type of object that Firestore uses when talking about actual instance of a document model. So just to be clear, I'm going to call this docref, user docref, and this is equal to doc. And doc takes 3 arguments. The first it takes is the database. So we're using our Firestore database instance. So we're going to pass that as our first argument. The second is going to be collections. So we know we're going to call it our users collections. And then third is going to be some identifier that tells it what it was. So do you remember when I showed you in our slideshow in the last video, and I showed you the identifier was Nike Air Max or Adidas NMD, capitalized and all together? If you remember, it looks something like this, Nike Air Max, like that. That identifier is a unique ID. So similarly, we need a unique ID for this to work. So what is our unique ID? Well, let's first look at our sign-in. We're going to console log the response, and let's look at it to see what we have access to. So let's go to our application. Let's open up our console, and let's just click sign in with Google. Here, let's sign in, and let's look closely at that object that we're console logging here. Inside of here, there's a couple things like the operation type and what provider it's from. We don't really care about any of this. Whereas this user object, this is that authentication object I was talking about that comes with the access token. What we really care about is the fact that on here we get a display name, we get an email, we know if it's verified, and then there's some other information such as a phone number, a photo URL, but most importantly, there is a UID. This is a unique ID identifier that we get with this object. So we might as well use this UID as our unique identifier. So right now, we're in the process of creating this user instance inside of Firestore. So we've never done that before. So what we can do is we can say, okay, what I want you to look for is off of this user auth object, this UID, and I want you to use that as the unique ID to get a document reference. What's interesting about Google Firestore is that even though right now, as we explicitly saw, we do not have a document reference inside of our database. We don't even have a users collection, but Google will still generate this object for you. So let me show you what I mean. Let's go inside of our sign-in component and let's import in the appropriate file from Firebase Utils. Actually, I'm already importing it up here. So I'm just gonna move this up here. And what I wanna do is I wanna call this method using responses user object. Remember, that was this specific object right here. The one right here, it's off of user. So I'm gonna take that, I'm gonna destructure it off the response because that's really all I want. And I'm gonna pass that in as the user auth. So inside of Firebase utils, I'm getting this as user auth. And then I'm essentially saying, hey, give me the document reference inside of this database under the users collection with this user auth's UID. As we know, we do not have anything inside of our collections. We don't even have collections. We just generated a database earlier. So what this will log, though, when you see this inside of here, let's refresh because we just added some code. I click sign in with Google pop-up. I click Yihua Zhang. So now what's happening is it's giving us that response back, and we're passing it into our new create method. And right here you see we actually got back some object. This object is actually the object that represents some document reference in the database. However, what we know is that we don't actually have a value, but here this ID is that UID we just used. And the path, well, this points to our collection of users, but then it also points to this UID. But we know that nothing exists here. There's actually no data we can get from this. So why did Google create this for us? The reason why Google did this is because this reference points to some now unique point inside of the database. There's nothing there for this ID, so Google's like, oh, okay, there's no harm. I'm not going to overwrite anything with this ID. So by giving us this reference, Google wants us to use this specific document reference object that they provided us in order to set data there, because it's already kind of pointing to some place inside of our database. You can imagine that there is now this users collection that Google hasn't made yet, but it knows that it's pointing here. And then inside of that users collection is that specific user ID. Now, they don't exist, but if we wanted to set the data, Google at least knows, oh, I'm going to set it inside of users for this specific ID. That's exactly what Google is going to do. So now that we have this, how do we actually figure out how to get and check some data? Well, the way we do that is where we use that method that I was telling you about, the getDoc. Remember, this will try and get the data related to a document. So to do this, we're going to say, okay, const user snapshot. The snapshot is kind of like the data. It's also a specific kind of object. We're going to use await because Google needs to do this asynchronously to get the document for our user doc ref. Here, now what's going to happen if we save this and we also, let's console log user snapshot as well. If we go back now, we refresh, we sign in with our Google pop-up. Now what's going to happen, as we know before, is we should see two things log. The first we'll see is our user doc reference. We've already seen that before. But now what we also see is this new document snapshot. This snapshot, again, points to the same identifier, but this is a special object now, because on this object are different ways that we can check whether or not this document exists. So I'm actually going to directly leverage a method called exists. If you save this now, and let's go through that flow again, let's refresh, let's clear our console, do our Google sign-in. I'm going to sign into Yihua. What we'll see is false, a Boolean. So using this object, there's actually a method on there called exists, which tells us whether or not inside of our database, does that reference and the data related to that reference even exist? Well, we know it doesn't. We know we have an empty collection. So that's how you can check whether or not, based on a document and the data you're looking for in that document, if any of it exists or not. It's utilizing this that we can create patterns to determine that if there is a relevant place in the database for this data, give it back to me. If not, create one for me. And that's the flow that we're going to follow. So I know there's a lot that we have to learn here about documents, document references, and then document snapshots. It's like, wow, what are all these new things? Well, the main idea is just that these are the tools that Google has determined to use Firestore in order to best actually store things inside of Firestore. So if it's a little confusing, don't worry. In the next few videos, we're going to work a lot with it in order to better understand it. So at least here we have a high level idea. In the next video, let's actually start utilizing this snapshot now and writing out the rest of our function to start storing this stuff inside of our database. So I'll see you in the next video. Welcome back, everyone. In this video, we are going to leverage the pieces of information that we've just learned. We have this user document reference, and from this user document reference, we got a snapshot. The snapshot allows us to check whether or not there's an instance of it that exists inside of our database, and it also allows us to access the data. So how do we do this? How are we going to set up our code? Well, let's write some pseudocode first. What I want to do is I want to first check if user data exists. If it does, then I don't want to do anything. I just want to return back this user document reference. If the data does not exist, though, so let's say if user data does not exist. So here, this is what happens if user data exists. If user data does not exist, what I want to do is I want to create / set the document with the data from user auth in my collection. And I want to set it using this user snapshot. Because remember, it's already pointing to a specific place in a collection for the data that we want. So to do this, I'm going to say first if, so I'm going to use the bang operator, which means that if the snapshot exists. So remember, it gives us a Boolean. So if it exists, then it'll return true. If it doesn't exist, it gives us false. And with the bang, I'm reversing it. So that means that if it doesn't exist, this will return true. If it does not exist, because if it does not exist, then I want to create and set the document. So to do that, I need to pull off the display name, and I want the email from our user auth object. If you remember, those are fields that is on this object alongside with our UID. And then what I also want to do is I want to make just a created at. So this is just going to be a new date object. This way we know when these users are signing in. Then, in order to set this document, we need a try catch block. If you don't know what try catch is, essentially this just means I want you to try something asynchronous. If whatever you try in here throws an error, then you're going to catch that error and you're going to do something with it within this block. So what we're going to try is we are going to try to set the document. So as we know, if getDoc gets us the document, then setDoc allows us to set the document. And similarly, what we're going to pass it is a user doc reference that we just got back using the doc. And then we're going to pass it the data we want to set it with. So here we want to set a display name, we want to set a email, and we want to set a created at date. And this is pretty much all we need. Beyond that, what about the error? Well, what I'm going to do is I'm just going to console log that there was an error creating the user, and I'm also going to log the error message that comes from the error. So this is all that's going to happen if our user snapshot does not exist. But what happens if the user data exists? So if it exists, then this is not even going to run because this is going to return true, right? User snapshot exists, which the bang will flip so it evaluates to false, meaning this whole setting step is going to skip. So we can just return user doc reference. And now, just to be sure, let's just save this code and see what happens. So let's just walk through this again. We check to see if the snapshot exists. If it does not exist, then we want to set it inside of our database. So we're just saying, yo, set the doc with this object. So what we're going to do here is we are just going to also in here const user doc reference, because now we know no matter what happens, we should get back a doc reference. And I want to await this because again, this is an asynchronous step. In fact, we don't even need to do any of this yet. We can actually see it directly in our collection if it works. So let's just test that. So let me refresh this. Let me trigger the pop-up. Let me sign into my Google account. And now again, we see that it's false, of course, because we just wrote the code for our collection for the first time. And now if we go into our database and we refresh, we see we now have a users collection, and there it is. There is our user created today. So this is really great because that's all we really need. We can now authenticate our users, allow them to come in, but also now we can just simply update our database with all of these authenticated users and their relevant data. So we have now created a way to create users. So this is really handy because using this system, we now have authentication as well as storage of these users inside of our application. Authentication and users is typically a very complicated feature to build because it involves servers, backends, and all that. But here we've achieved it using Firebase, and we just had to learn a little bit of Firebase along the way. So this is it. We're now creating user documents. We now have those documents and references. We can use them for signing in and signing out users. This is pretty good now. We can start utilizing this inside of our application. Before we do any of that though, let's just make sure that we also commit our changes. So what we want to do is we want to git add. Let's just git commit our message, which is that we have added our sign in component as well as Firebase utils and brought in Firebase libraries. And then we can push this up. And that's it. So now that we're at this stage, we have in some Firebase utility functions. We brought in Firebase. We have our sign up component starting out. Let's move on to the next video where we'll continue fleshing this out. Welcome back, everyone. In the last video, we learned about signing in with our Google pop-up. We also learned about how to store that Google user inside of our Firestore database. In this video, we are going to learn about other authentication methods that we get provided from Google, also through Firebase though, which is signing in with a redirect, and how now that we've set up all this code, it pretty much works for any authentication method. So the first thing I want to do is I want to go into this collection. You'll notice that I've already deleted my collection. And the reason for that is because I want to make sure to show you that once the same user signs in but with a different redirect method, it is still going to generate and create the same document. As well, I've also removed the user from my authentication. So you can do that yourself. You can also just watch me do it. Really, it's pretty simple. But now that I've deleted these, what I'm going to do is I want to go back into this application. And you'll notice that up here inside of Firebase utils, I also imported sign in with a redirect. So now we're going to use it. And it's very simple. In order to use it, instead of here, where we export this const sign in with Google, I want to do sign in with Google redirect. And it's going to be the same. It's just going to be an anonymous function that calls the sign in with redirect. And I'm going to pass it the auth, and I'm also going to pass it the provider. So here, one important thing I want you to notice. Notice how with these sign in with pop-up and sign in with redirects, these are general, and they take an auth, and they take a provider. I'm calling mine sign in with Google pop-up and sign in with Google redirect. The reason for this, as I mentioned earlier, is because there are different providers you can have. Whether you want to sign in with Facebook, whether you want to sign in with GitHub, these are all different providers that you can pull in. So here, if we look, there's probably a Facebook auth provider. And just like with Google provider, you can generate a new provider and pass that in, and now you have another sign-in method available. This is why these providers are instantiated as classes, as I mentioned before, whereas these auths are not. So this is an important thing to notice because here I'm essentially saying I know that this pop-up is going to be Google because the provider I'm generating for it is a Google provider. If we want to be more explicit, we could say Google provider like so, and we could modify it like so as well. This way, it's just more clear if we wanted our code to be like this. So let's just do this just so that we understand at the very least that there's multiple different providers available. But once we have this set up, I want to show you this redirect now. So I'm going to copy this sign in with Google redirect. I'm going to go into my sign in component, and I'm also going to import in sign in with Google redirect. And here, all I'm going to do is I'm just going to duplicate this button code. And here I'm going to say sign in with Google redirect. One thing though that we're going to have to change is this on click, and we're going to have to change it in more ways than one. But to show you why, what I'm going to do is I'm first going to just run const log Google redirect user. And let's get rid of this right here. Instead of sign in with Google pop-up, I want sign in with Google redirect. And I'm just going to console.log here, the user. And then I'm going to put this into the on click so you can see what's going to happen. So we're going to save this and we're going to go into our application. Here, what we're going to do now is click this sign in with Google redirect. What happens is that this will now take us into this separate page where we're asked to sign in with Google. Very similar to the pop-up, except it's a separate page. I'm going to click this user. What's going to happen is it's going to take us back to our website. But what you'll notice is that my user is not getting console logged. And if we go into this application, what we will see is the user is indeed now inside of my authentication. However, any code that subsequently followed actually signing in the user with the redirect is not actually triggering. Why is this happening? Well, if you think about it, what did happen just now was that our website redirected us entirely to a new separate domain. When we came back, our website does not know that there was some previous instant of state of this website that we were being paused for. The web doesn't work like that. When you navigate away from a URL, the website thinks, oh, okay, I'm just going to get rid of everything. I'm going to unmount the entire application. We're done now. Why would I hold on to it? I don't know if you're going to come back or not. So what happened is when we came back, we essentially reinitialized our entire application from the start, from scratch, meaning that any previously held functions that we were perhaps in the middle of doesn't matter anymore. There's no way to continue from there. For that reason, we need to use a different way in order to actually track this type of information. So what we're going to do, and I'll show you, is that first we're going to need to import a few things. We need to import useEffect from React. We also need to import a method from Firebase auth. And this method is called getRedirectResult, this one right here. And then inside of our utils, we'll also need to make sure that we bring in our auth, because that's what the getRedirectResult is going to get. Finally, what we need to do is I'm just going to, instead of doing this log Google redirect user, I'm just going to directly call the sign in with Google redirect. Because as we know, that function we had before was doing nothing for us after this method internally called the sign in with redirect method already. Once that's called, the application, once we navigate away, again, unmounts. So now what we're saying is that inside of this code, I want to run a useEffect. And I want to run this when this application mounts. So when the sign-in component mounts for the first time. Remember, when you pass a empty array, it means that run this function once when this component mounts for the first time. The function here being our callback. Inside, I want to call getRedirectResult. GetRedirectResult, I'm going to pass it an auth. And because this is an asynchronous method, getting the redirect result is asynchronous, I'm going to say const response is equal to await getRedirectResult. And then I'm going to console log the response. And now I want to save this code. So what's happening now is that essentially we're going to sign in with the Google redirect. It's then going to take us to that page where we're going to choose our Google user. When we come back, what's going to happen is our application is going to remount, meaning this sign-in component will remount because we're coming back to the sign-in page where the sign-in component is. On mount, this useEffect will run this callback once on the mounting. And then what's going to happen is that inside this callback, we're going to say, hey, get me the response for the redirect that just happened. How do you know what redirect happened? Well, it's based on the auth. And this is why this auth is a singleton, because this auth is helping us keep track of all these authentication states that are happening throughout the application. You can kind of see this as if some kind of authentication memory bank is tracking all of our authentication states for our website and for our Firebase instance, regardless of where the website is going. So this is why this is so useful. So now that we have our code, if we go back to our application, we see that on initial mount, this value we get back from that get redirect user is null. The reason, of course, is because our application refreshed. There was no redirect that happened. So we expect this to be null. This is good. But now if we click sign in with Google Redirect, and inside we choose our Google user, once we come back, our application remounts, sign-in component remounts, runs our initial effect. And here now we see we do indeed get back a response. And on it in the response, we have our user with our UID and all the relevant information we need in order to create that profile document now. So now that we have this, let's actually continue with what we had before, which is where we created this user doc reference. And here we can just say if response, meaning that it's not null and we get something back, because we saw that there's a chance when we mount, we haven't come from a redirect, maybe it's null. Then we can say, oh, now I want you to create this from response.user. So here now, we're doing the same thing we had before, which is saying that if response is not null and it is indeed an object, then I want you to generate the doc reference. So if we come back now and we refresh, we notice now if we sign in with Google Redirect and then we click our user, we sign in with our user, we come back here, everything mounts. Of course, we don't log anything, but if we go to our Firebase console, we open our database, we should see our user. So there we go. Everything here is working as expected. So this is just to show you a different way that you can utilize different sign-in methods. We have sign in with Google Redirect, sign in with pop-up, and also in the Firebase utils, the main thing I wanted you to know was that there are multiple ways that you can provide different providers. Google Auth is just one of them. And this is what I was saying earlier when I mentioned that there's a reason why this one is a class and these others are instances. We just saw the reason why. As we saw with this get redirect result, the auth is a singleton because it keeps track of the authentication state of the entire application. As the user signs in through different means and methods, we need some way to be certain of what it is that the user has done, especially in the framework of this browser, where whenever you navigate away from your website, you are breaking the instance of the website now. So this auth is the only way we can keep track of whether or not users are properly authenticating or not. And that's what's great about this service of Firebase. As long as you follow the patterns that it provides, it kind of circumvents a lot of these different issues that are present. But here now that we've set this up, I'm going to get rid of this because we don't really need it anymore. It was really just to show you this pattern. And I know there's a lot of complexity in this pattern. We learned about effects, setting things up, but hopefully the logic all made sense for you. But I'm just going to get rid of this because I just want to keep the sign in method. This is really just kind of a sidebar for us to learn more about Firebase's methods as well as the authentication. So now that we're back to this, let's continue with the next lesson. Welcome back, everyone. In this video, we are going to set up our email and password sign up. We also want to set up our email and password sign in, and we're going to style these so that we can finish off with our authentication page. So in order for us to work on this, we need to first enable a provider that allows us to provide email and password sign in to our application. Any authentication method that you add is needed as a new provider that you create inside of your authentication. So here, what I'm going to do is add a new provider, email and password. I'm going to enable this email password one that allows them to sign up using it. And also for email link passwordless sign-in, this one's a little bit extra. I don't really need this one. So I only want email password. Passwordless sign-in you can enable, but there's a lot more configuration required. Essentially what happens is when they enter in an email, they submit it, they get a link inside of an email that they'll receive for that email, which if they verify that they own, will take them back to the application and sign them in. But we don't really need that. We just want regular email password sign-in. So now that we have our email password, inside of our application, we need to start building out this form. So here's what I'm going to do. Inside of our components folder, I'm going to make a new folder and I'm going to call it sign up, because that's what this is. It's essentially our sign up form. We can even be more explicit in calling this sign up form. And then inside, I'm going to make the files required, sign up form.component.jsx. And then once we're inside, we're just going to create a very basic form, just so that we know it works. So it's going to be sign up form, which is equal to a functional component that returns back. And this is where we need to understand a little bit about HTML forms. If you're unfamiliar, we'll go through it pretty briefly, but enough that we understand what's going on. So what we need is we need to reflect what this form will have. So for our basic needs, let's say there's a div, and in the div is just an h1, or inside it'll say, sign up with your email and password. And then we need a form component. This HTML form component is essentially something that allows you to make all these text fields inside do what you need them to do as far as form is required. So this is where you can do things like, let's say with your form, you want certain fields to be required and you don't want the form to be submittable unless they fill out those fields. You can do that very easily using this form component because it'll essentially do all of that for you. So let's talk about what goes into them. So we know that for our form, we have 4 different inputs. So let's create an input and let's make a label. Inside of this label is going to be some text. And we know that these inputs, all 4 of them are required. So let's copy paste this 4 times and start filling them out. The first one is going to be the display name. The second one is going to be the email. So I'm just putting them in the label. The third one is going to be password. And the fourth one is going to be confirm password. Now, inside of these inputs, because they're required, what will happen is the form will validate that if these inputs are empty, then it's invalid. It's only valid as long as there's actual text inside them. And also, for display name, what are the types? So a type is an attribute that you can give to an input. Text is the most basic one. It just means that it takes some string, that's all it is. For email, though, we can actually use a type called email. This email type will make sure that the text inside validates in the format of an email, meaning that you've got some string and then you've got an @ symbol, you might have more string, you have a dot, and then finally some more string. So pretty much the format that you always see with an email. So that's what's great. We get this out the box. The other great thing too is that if a browser does not support email, it will fall back to using a type text. For password, we can also use a type password. And this will just hide all of the characters that are being typed in. And similarly for confirm password, it's also of type password. So we have our 4 input fields. What we also need is the ability to submit this form. So luckily for us, React has bound a event handler called onSubmit, which runs some callback whenever you submit the form. And to submit the form, we can actually add inside the form a button child with the type submit. So the form will know that when this button of type submit is clicked, then run this onSubmit callback. And this onSubmit callback only runs if all of these validations for these inputs are passing, meaning that these 4 fields that are required are filled in. Email is in the valid format that it's in. And I'm just going to say this is of type signup. And for now, let's just export default this signup form. So I just want to make sure before we actually add in all the functionality of doing all this that our form component works. So I want to import in the signup form from components, signup form component. And I'm just going to put this after this button here. So now let's save this, go into our application, and there we go. So I've got some auto-filled, auto-populating fields here inside of my Chrome browser, but This is our form. We see it all here. What we need to do now is bring in that functionality so that this form is actually valid. To do that, we need to track the actual input inside of these inputs into our form component. And if we remember from our Monsters-Rolodex project, we can do that using useState, which is very similar to our search bar. So I'm going to import useState from React. Now, one way you can do this is you can track all 4 of these different inputs using 4 different useState values. But personally, I find that a little cumbersome, especially because I know this is all grouped together anyways as something of a form field. So I can actually create an object, and I'm going to call this like form fields, for example. So in fact, this is actually going to be our default form fields. So this is the initialized value for these 4 values, which should all be empty strings. I'm just going to show you the shape though of this object. We're going to have a field called display name, which is an empty object. Email, which is an empty string. Sorry, not empty object, empty string. Email is also an empty string. Password, also an empty string. Confirm password, as you guessed it, also an empty string. So using this value now, what we can do is we can say that I want to use state, and I want that value to be called form fields. And again, the second value that we get back is a setter function. Now for use state, I'm going to pass it this default form fields value. So this object is essentially the value for form fields. It's not a string. It's this object of these 4 exact values. What I'm going to do is I'm going to destructure off these 4 values. The reason why is because we're going to use these values somewhere inside of our code. So I'm going to confirm password, and this is equal to form fields. So what's happening is this object is being passed in as the default state for use state. Form fields is now some kind of object. I'm destructuring off the 4 values that I want, and then I'm setting them as constants inside this component in case I need them. And then what I'm going to do next is I am now going to actually figure out what happens whenever these values change so that I can update my form fields. Here, I'm going to create a function called handleChange. And this is going to be a general function that takes that input event whenever the text changes. However, in order for us to make this function generic, there's a couple things we need to be able to do. So by generic, I mean that we essentially want to pass this into our input as the onChange handler for every single one of our inputs. We want it the same. In order for us to do this, we need to be able to identify which of these inputs is firing so that we know which of these form fields to update inside of our state. In order to do that, we actually need to append some more values. So on each input, we can give it a name, and the name will come through on the event. So for our display name, we want to name them the same as the name of the actual attribute that we're trying to update. So here, because we're just going to be able to destructure this off as name from the event, we're going to utilize this name to tell our set state which of these fields to update. So let's just update all of these different fields with the appropriate name. Email, of course, will be email. Password will be password. And then confirm password will be confirm password. So here, everything matches and lines up with these values. The next thing that we want to do is we actually want to get the appropriate value. The value that gets typed in should be the value that in turn we actually display in the input. So in order for us to do this, we need to pass in the value here. So for the value of this specific field, we're going to use the appropriate value that we've pulled off of our form fields. So the direction is pretty circular. When you pass a value, you're actually saying, hey, the value I want inside of this input should be the value I'm passing you. So if I pass the string ABC, then the value should be ABC. Let's just save this and we'll see. Here, let's refresh. You'll notice that here you actually see display name ABC. So that's what value represents. And the reason we do this is so that our changes are circular, meaning that What happens is that the value from the state is the value that's shown in the input. But when the user types those values in, well, our onChange trigger effectively pushes that form field into our state. And then again, our state will now actually update the visual here. So the visual aspect of what the user sees in the form field is not determined by the input, but it's actually determined by our value. This way, we can control what those fields are and what we're doing with them through our state itself. I know that sounds a little confusing, but once you put it in and you follow and track, you'll see what I'm talking about. So here, I want value to be display name. Of course, I want this next one for email to be email. And then I want value for password to be password. And then I want value for confirm password to be confirm password. So in order for us to now appropriately trigger, we can now say, hey, give me the value as well off the event, because these will now come in through the event object. And then all we need to do now is just say set form fields. And what we're going to set it is an object. Because we're only going to be updating one input, all I want to do is I want only to update the appropriate form field. So all the other fields that were previously on the state, I want them to be spread on. So this will spread all of the fields. And then we're just going to update the appropriate field by using these square brackets inside of our object notation. So this says, oh, take this value and apply it here from this variable of name. And the value will be the value. Oh, you know what? I also noticed a quick error here. We need to make sure that we're actually calling event.target. The target is actually going to give us the thing that is emitting the event. And the thing in this particular case is the input. So the target here will give us all of the things that are attached to this input. That's what's on the target, not just the event. So here we have our set form fields called, and let's also console log out form fields. So let's save this. Let's go back to our application. Let's refresh. And here we see this is our initial empty state, default state for our form fields. And as we start typing, we see that our object is updating appropriately. Let's do password. Here we see they're hidden, but inside of our password, we see that we are indeed actually storing it. And then for email, let's just say there at Gmail. There we go. Everything's working. So all of this code is working as expected. I definitely want to apologize for the length of this video. I know it's rather long, but as you can see, there was a lot of things that we needed to set up just to get the form working, as we need to inside of this component. The key thing here is that we learned a new pattern with useState. We learned about setting an object, but only when that object is always going to be tied together to some specific logic. The main reason for using this object was so that we could genericize this handle change. And primarily what we're trying to do is that we wanted to spread in this object and then modify one value on this object. And we knew this worked because all of these form fields are essentially duplicated versions of the same state. Their only difference is which of these inputs are being targeted inside of this object. So this pattern only works when you can genericize and find that common ground between the logic that you need for these states. And in this case with the form, these inputs are the best example of that. Now that we have learned how to set up this field, let's actually submit it and finish off the authentication here. Let's do that in the next video. Welcome back, everyone. In the last video, we learned about how to leverage this new pattern from useState, where we create some object that allows us to keep track of multiple fields inside of our form. Due to the fact that there was overlap between the name and the value that we had generated, we were able to create this easy, simple shorthand method of storing and setting this uniform object that we had in our form. In this video, what we're going to do is utilize this form field in order to actually authenticate our user with their email and password. So one thing I want you to notice is that here we are keeping the same values that we know we need for our create user document from auth method. This user auth, as we know, sets a display name and an email, and the created at is generated inside. But primarily what needs to be passed through is display name and email. For us here inside of our new sign-in, what we do need is very similar. We needed the display name, we needed the email, but now with password and confirm password, the thing to remember here is we don't actually want to store these inside of our database. This is considered sensitive information. Instead, what we want to do is we want to leverage Firebase's authentication, which will figure out whether or not the password matches with the user. But they obfuscate that from us so that even if somehow our Firebase gets hacked or our Firestore gets hacked, our passwords don't get leaked and it's not a security concern for us. So that's a great functionality as well of Firestore. Now, what we want to do is we want to leverage all these default form fields that we've set up and actually authenticate the user, which means we're going to need to leverage new utilities inside of our Firebase utils. So as we saw before, when we were using Firebase Auth, we introduced the sign in with redirect and sign in with pop-up methods. These methods took some specific provider that told us which external provider we were trying to sign in with. Maybe it was Facebook, maybe it was Google. Well, it was Google, in fact, for us, but maybe it could be GitHub or any of those other options. Here, when you look inside of your actual console and you look at the sign-in methods, when we added the provider, these are considered native providers, which means that we don't actually need to supply a provider. These come by default with Firebase Auth. So all we need then is not another provider instance, but we just need the method. Now, this method we're going to import is actually aptly named create user with email and password. And let me show you how to use it. It's pretty simple. First, what we want to do is we want to create another function. And I want to call it something explicit, like create auth user with email and password. Because as we know, what we're making is a authenticated user inside of our Firebase authentication tab. This is not necessarily a user document inside of our Firestore instance. So here I'm being more explicit about what this function will do. It's going to be an async function because we're going to be setting some values asynchronously inside of Firebase. And here, what I want you to notice is that I tend to create these methods inside of this utility file. And the reason why I do this is because it allows me to control the large majority of how my application interfaces with this external service. In this particular case, the external service is Firebase or Firestore or whichever other service inside of Firebase that I'm working with. The reason why I do this is because it allows me to create this separation layer between my front end as well as the services it relies on. Let's say, for example, Google Firebase decided to change some of these methods. Now what happens is that suddenly my application might start breaking without me noticing. However, if I've more clearly defined where my code is going to directly interact with the underlying service. So in this particular case, creating user documents from auth. Let's take this example. What happens if some of the way that we get these documents change? Let's say they change up the methodology that we receive documents, the way that we fetch the data, the way that we determine whether or not some of the data or maybe even the reference exists or not. Let's say all of this changes. Does that mean that we have to refactor everywhere inside of our application that is now utilizing Firebase's authentication and to create this document? No, because now we can just change it in this one place. In this one place, I can figure out how it is that Firebase wants me to authenticate in a new way now and just modify it in one place, even if I call this method in more than one place. The other thing too is that if we look at a method like create auth user, this might be relatively simple. We know that with this method, or at least I know with this method, all I need to pass it is auth, an email string, and a password string. And Firebase is going to figure out how to authenticate this user. But what if they change this? What if they need more values to be added? Maybe there's more additional options that they extend. Maybe there's even more steps that get involved here. When this changes, again, all I need to do is modify this one function. But what I've done is I've protected my front-end application from this external service that's subject to change. Now it becomes much easier because I define how it is that this service is going to interface with my front-end application. I've added this utilities as essentially a layer in between my front-end code and this additional library that I'm working with. So here, for example, I know that what I want is an email and I also want a password. If I don't receive either of these things, meaning that if I don't get an email or if I don't get a password, then I want to exit. I don't want to call this method. And what I want to return is the awaited value from this method. Because here, once this authenticates, I want to see what I get back. But the key thing here is that I know this method will never call if I don't get an email value and I don't get a password value. Now, in a much later lesson in the course, we are going to learn about much more rigid ability to protect our code using Typescript. But for now, I don't want you to think about that. It becomes too much to think about when we're already in the process of just learning React and a lot of the React ecosystem, as well as these front-end patterns. But I do want to highlight here that we are protectively focusing on how to defend our code. We can actually also do something similar inside of our create user auth document. Here we can say that if we don't get a user auth, we also want to return. So this is another way we can protect our code. But these are just different ways that we're saying if we do not receive any of these arguments, then just don't run the function. TypeScript kind of makes this significantly easier, but again, we'll explore that later, so keep your eyes peeled for that. But here at the very least, we now have this new method to create auth user with email and password. We pass it the auth, we pass it the email and the password, and then this will create an authenticated user and give us back some auth object. Inside of our signup form now, let's import in this method we just created. And let's pull this in from the appropriate place of our utils, Firebase utils. And now that you have this method, my challenge to you for this function right here is create it and figure out what's needed for this feature. This is actually going to be your first big challenge because we've learned a lot of the little bits that are required to make this work now. We've learned extensively how to work with Firebase enough that we have an idea of what the object we're going to get back if this is successful is going to be. And here, I just want you to think about these requirements. So first, let's just set up this method before I ask you to pause the video and give it a try yourself. I'm just going to call this handle submit. This is going to be a method that is going to leverage the form fields in order to actually create this method. So again, this is an async method because we're generating a user document inside of an external service. And it's an async method. And because it's going to trigger on this onSubmit event handler, we're going to get an event. So I'm going to teach you how to set up some of this basic stuff. The first thing we want to do is we want to prevent default. Essentially, we don't want any default behavior of the form. We are saying that all of what's going to happen in the form, we're going to handle. All we need you to do is just tell us when the form has been submitted. Once this event is prevented, there's a couple things you need to do. You need to confirm that the password matches because, again, they have to type the two passwords together. What we also need to do is we need to then actually see if we've authenticated that user with email and password. Then what we want to do is we want to create a user document from what this returns. So step by step, I want you to try and actually piece together this handle submit function yourself. We've done it before. We did it when we were using our sign-in component. It's going to be similar, except now you're just creating that authenticated user with email and password. So try it out, walk through it, use these fields of email, password, and don't forget to pass display name when you're actually trying to generate the document from what we get back from create auth user. But I just want you to play around and tinker with this actual function, test it yourself, and see if you can build out this feature. So once you've done that, join me in the next video when we'll do it together. Welcome back, everyone. In the last video, I issued you a challenge to try and create this handle submit method yourself. Hopefully it worked out and you now are able to sign up users using email and password. It's really cool if you did. If not, let's do this together. No worries at all. So here, what we know is that for signing up a user, the first step we need to confirm is whether or not their passwords match. So here, I want to say that if password does not equal confirm password, then what I want to do is I want to alert them that your passwords do not match. And then I just want to exit because I don't want to proceed any further. I've already told them they need to now update their passwords. There's actually another way that you can add additional checks to this password and confirm password by adding additional length checks inside of the input fields themselves. I'm going to link for you the input documentation for this HTML element. So if you wanted to add more functionality yourself, such as adding requirements of length and such, you can do that yourself. I'm not going to add any of that just because for me, this is enough for me to get the idea of what I'm trying to build with this form. And the other thing I want to do now is once I've made sure that passwords and confirm password match, I need to continue and actually attempt to create this user. So as we did before, we're going to try and catch, because when we try and call our Firebase server, we might fail. And if we fail, we want to be able to catch that error. Here inside of the try, what I'm going to do is I am going to make sure to call this method that we just created, which is create auth user with email and password. And here what I'm going to do is I'm going to pass it the email value and the password value. These are the two values that we've destructured off from our form fields. Then what I'm going to do is I'm going to make sure that I know what it is that this response is first before I start working with anything else. So in this particular case, let's say we get an error as well. Let's just catch the error and let's just console.error the error. We can also console log the error. Maybe that's a little bit more clear for us right now. And we can just say user created encountered an error, or user creation. Let's be more grammatically correct. User creation encountered an error, and we'll log the error. And this is enough for us to at least get started and see what's happening. So let's pass our handle submit into our onSubmit handler here. And now let's save this. And let's go back to our application. And let's actually try it out. So here I'm going to say that my display name is Mike, my email is mike@gmail, and my password is 1234 1234 1234 1234. So I know I'm logging this. Typically you don't want to do this, but I'm just logging it for our own benefit right now. And if I hit sign up, let's see what happens. We get back a user credential. And inside, we see we get a user object. And here we get an access token. We didn't pass a display name because we have not actually done this inside of our code. So this is a very key point that I want you to notice. The display name here is not coming back to us inside of this user auth. But how could it? We just created this user. So of course there's no display name. But the reason why this user object is the same is because Firebase is making sure that across all of its different ways that you can authenticate, you're expecting the same shape. Whether or not there's a value or not, that's entirely up to the authentication method itself. The reason why for Google there's a display name is because in Google, when you set up your user, you have to tell Google what your name is. In our particular case, we did not do that in the actual authentication method. We did it in our form, but we don't actually do it in our authentication method. And there's no real need to. In this particular case, what we're going to do though, is we're going to use this and store it inside of our database instead. So this is an important distinction, is that now display name is not coming from this user object. Display name is going to be coming from our sign up form instead. So how are we going to do this? So here, let's go back into our application. As we saw, we are getting back this user, which is good because we want that user. But what we're going to do with this user is we are now going to have to pass this value that we have, which is the email and password confirmation, into the actual final document that we're trying to generate. But let's look at this method right now. Our method infers from this user auth the display name, the email, and the created at. These we're just assuming comes off of that user object. because it did when we signed up before. Here, we're not going to be able to do that anymore. So in order for us to extend this functionality, we may sometimes get this value, we may sometimes not. So what I'm going to do is I'm just going to say that, okay, in the cases where there's not, let's say we get some additional information. And this additional information, I'm just going to say is an object. And what I'll do is I will spread this object in at the end after all of these fields have been filled from any previous variable setting that we've done. So if display name exists on user auth, then it will get spread through. And we're not going to pass any additional information, meaning that this will probably by default be just an empty object, for example. But let's say in our current example, display name, there's no value here. It was null as we saw. So what's going to happen is display name is going to get set to null. But then because what we're going to do is we are going to add the additional information ourselves, then what'll happen is that this is instead going to be passed in like this, where we will have a string ourselves. So it'll be Mike, for example. And then this is going to overwrite that null value so that we do actually have a final display name inside of our user document. And now what we can do is we can just say that after we get back this user auth object, I want to now call in that method that generates this create user auth. So I'm going to say, what is the method name again? Create user document from auth. And down here, after we get back, I'm going to await create document from auth. I'm going to pass it the user auth, but I'm also going to pass it this object with the display name value that we have expected them to fill out inside of their form. And then after this, if it's succeeded, we'll figure out what to do to confirm to them that they've successfully signed up. But for now, this is enough for our form field. The only other thing we need to do is make sure that we clear out the sign up field. But before we do that, let's just make sure this is working. Let's take this one step at a time. So here I have all the same code in. And now I'm going to refresh. And let's just keep typing mike@gmail.com, 1234, 1234, 1234, 1234. And if we hit sign up now, oh, we see we get an error. We see that we get the error, Firebase error auth email already in use. So this is actually very helpful because earlier when we logged out the sign up for the first time, it actually already created a user for us for this email. And Firebase won't allow you to make the same email for multiple users. So this is really great for us because now what we can do is we can capture this error and we can alert to the user even more specificity on why the error failed. So here, what we can do is we can actually leverage the error code. And this particular error code was the auth email already in use error code. So we can say if error code is equal to this, then what we can do is we can console, or actually let's alert to them instead that they failed because they have the same email. Cannot create user email already in use. And now if we save this and we can do else, console log this error. And now if we clear out the console and we sign up again, we see that we get the proper alert. So this is great. We've added more functionality in now. And there's more ways that we can make this look prettier, but we'll talk about that after. For now, what we want to do is we want to properly create this user though. So what we can do is we can delete this user from our authentication. And if we go back now and we try this sign up again, what will happen is now if we come back in here, let's refresh. We didn't get the error. We see that we have this user, and inside of our Firestore database, we see that we have our new user. Great, so everything is working as expected. The only last thing we need to do is after we successfully actually fire off this successful creation, we want to clear out these fields. And that we can just do by creating another method called resetFormFields, which is just going to be a function that calls setFormFields with our default form fields, which are the empty states. And then let's just append this to the end of after we've successfully created the user document from the auth. And now if we save this, in order to properly do this, we'll have to delete the user again. So here, let me just go in here. Let me delete both these users. So I'm going to delete both the document as well as the authentication because we're going to have to go through this step again. In fact, I could have just created another user. I don't even know why I'm doing this. This is really just a bit of hindsight in my end. But let's refresh. And let's just make sure that everything works. Mike at gmail.com. 1234, 1234, 1234, 1234. Hit the sign up. We see that our field successfully cleared out, which means that we probably successfully created our user. So if we refresh, we see our user, and inside of our database, we also see that we've generated the user successfully. So everything here is working. So our code is working as we expect. We've now properly integrated in sign up using this email password. So now that we have this, let's finish styling up our sign up. And then what we can do is we can figure out whether or not we can successfully sign in with this newly authenticated email password user. So I'll see you in the next video. Welcome back, everyone. In the last video, we finished off the functionality within our sign-up form. And in this video now, we need to think about how to actually style this component, but also at a high level, whether or not there is any componentization that we can do. So one of the things and patterns that I want you to think about when working with different components and different features is the most important thing is to build in the functionality first. You don't really need the styling as much as you need to make sure that the actual functionality of the component works. Once you have the functionality in, then you can start thinking about styling and all of those things, knowing that the hardest portion of your code works. So now that we have the functionality in, let's think about these different HTML elements that we have and how they might fit in a larger application. So when we look at our final application here, we see that we've got in some very basic form fields. But when looking at the actual final format, we know that here what we've done is really just work on the sign up page. What we do need is also a sign in page, which means that we're actually sharing these different form inputs. So what we want to do then is we want to genericize these inputs because as we see, we're also using it in 4 different places within the same component anyways. So this gives us a good chance to think about moving this into its own component. So to start this, let's go into our components folder and let's make a new folder. I'm going to call this form input. And inside of form input, I'm also going to make this form input.component.jsx. And because we know we're going to need to style it, I'm going to make a form input.styles.sass. So here, what I want to do is inside of the component, let's think about just copying this over for now, and then we'll talk about styling the component. So I want to do a const form input equals a functional component that just returns what we have in here so far. So as we see, we don't have a handle change and we don't have a value. So what we can do is inside of the props, we can pass through a display name value because that's also going to go into this label. So let's actually be very explicit in calling that label because we know that's what this will be. So other than a label, what else is there? There's a handle change. So let's call this a change handler. And then for the value here, we can just explicitly say value. And because we know that this value and this value overlap, there's also this name, And we can even put name to overlap. There's this required text, which makes it something that the input takes in as well. What we can do is actually we can spread through the values and use this like a normal input. So other than the fact that we have this change handler, we can even call it onChange. In fact, I can even be more explicit in the sense that I know that this component is going to be used like a regular input, except it has some functionality where we have perhaps a wrapping higher level parent component, which should get rid of this warning as we see. But also all of these properties here, the type, the required, the onChange, the name, the value, I am just going to use them directly on this component in place of a regular input component. The only thing that's new that doesn't go into this is going to be label. Everything else though, I just want to spread this in as other props. And because I'm aggregating them here, now I can just spread them through like so as these other prop values to go on this input. And this now should be able to be used to replace what we currently have. Let's just make sure. I want to take this component. I want to import this in here. So I'm going to import in form input. I've misspelled import. I want to import in form input from form input component file. And then what we'll do is, as I mentioned, we know that we need this display name. So all these inputs, let's first just replace them with our form input component. And then I'm going to put a label. And this label is going to point to this label value. So go ahead and do that for all these other form inputs. For here, I want to do label goes to email, as we see here, like so. I'm going to get rid of this one. This one will be password. So let's capitalize password. And then instead of here, again, label will be confirm password. So if we save this, at the very least, we should see that everything here still works. In fact, just because we put it in its own div now, for each one of these groupings, we actually see that it's even shifting into its own form. So here, if I just type these through, as we can see, everything still works. Awesome. So now that we have this, let's start actually styling this. So there's, again, a couple things that I'm going to show you in terms of the actual Sass I've already provided, and it's a pretty extensive Sass file. So what you need in order to make the Sass file work, though, we can walk through. So first, we have a div with a class name. And this class name, I want to say group, because it's essentially grouping the form input together. And then, as far as this label goes, this label, you can give something of a dynamic class name, because if you look at the functionality of this, what happens is that it shrinks up or it doesn't. So let's talk about some functionality here. This class name value typically is a string, but you can render string in JavaScript, which means that you can actually say that for this class name, I want to render some string interpolated string where the value inside is going to be dependent on this other props value. So in other props, if the value dot length is there, meaning that if the user has typed something into this input, that means that I want the label to shrink. When that happens, meaning that this length is greater than 0, so you can either be explicit about it, or you can just say as long as it exists, because 0 in this particular context actually evaluates as a falsy value. So this ternary operator is going to see this as false when length is 0. When it's greater, it's going to see it as true. So we're saying if the length value is truthy, then I want you to append this shrink class. Otherwise, just don't do anything. Or you can even just say append an empty string. And then outside of that, we also know this is a form input label, which is another class that we just want to add to this so that we know what this label is. And now, inside of the input, I also want this to have a specific, let's say, class name, and I want to call this class the form input itself. The other thing we know is that if there's no label, then don't render a label. And here what we can do is we can just wrap this inside of these squiggly braces, and we can just say that if label exists, then render this label. So now if we save this, and inside of your form input styles.sass file, just paste in the Sass file that I've provided for you in your resources folder. So now that we have in our styling, let's go back to our form input component and let's import in that styles file. So let's save this and now go back to our application. And here we see we have our styling. What we'll notice though is that this display name is not moving up. It does move up once we start typing, but we do also want it to move up when we actually start selecting. So how do we do that? Well, I've actually included the styles for you inside of here, and it's specifically this selector, this CSS selector. Essentially what this code says is that for this group element, which is our top level div, inside there's a form input. If you focus on the input, meaning that if it's selected, I want you to find the next sibling or a generally subsequent sibling with this class and then attach that shrink label mixin, which is what creates the label shrinking effect. But here we notice that our input is actually below the actual label, which means that the subsequent selector is not going to work because the selector is looking for a general sibling component with this form input label class after the input. So in order to fix that, we just need to move this input above the label. And now if we go back, we'll see that once we select display name, it works. And we also notice that it's also working with this text that's been auto-populated. So there we go. We now have our form input component that's now reusable. And we've also learned a little bit about different ways that we can compose and actually structure our components so that it's a little bit more intuitive when it comes to how we set up this input. What you can also do, if you want to be more explicit, is actually pass an object that has all of these values as some kind of, you can call it input options. You can do that as well. Both are actually viable options. It's really up to you how you want to do it. But personally, because I'm the only person using this application, I'm going to do it this way. I can show you quickly what the other way entails. All it would be is that here for this form input, label, of course, being label, here you can create something called input options as an object. And this would just be equal to this. And instead of these equal signs, we can just do this, except for type text. This one should be kept. Oops. Actually, like so. We just also have to add commas to these values here. And instead of interpolating it, we can just directly put these values like so. And of course, this being an object, we have to double wrap these and then required equals true or :true. And now let me just comment these out. I just want to quickly show you this format. If I comment these out now, you'll notice that this input options here is being passed as an object. So now what you can do is you can go into your form input component, and instead of spreading all these other props, you can just get this input options object. You can do it like this. And now if you save, we'll go back. We should see just the one display name, but we notice that everything works as normal. What's the advantage of doing this format versus the other props method? You do have a bit more of a clear separation between what is associated as your input portion versus the actual label portion. So the label portion could even be label options if we had nothing more than just the label. But in this particular case, it allows us to very clearly define, oh, there's a difference between the props that we're getting related to our label and then all the props related to our input. So this is also a very viable way that you can do this kind of separation. Personally, it's up to you. Again, when you're working with different teams, you can make different decisions on which one of these you want to move forward with. I personally just prefer this way. And let's just move this back into what we had before. There we go. Okay. So now that we've genericized our form input, we need to style the rest of our sign up form itself, and we can also work on the sign in form. So that's what we'll do in the next video. Welcome back, everyone. In this video, let's finish styling our sign up form. So here I want to give this div a class name, and the class name is going to be sign up container. As for this H1 that contains the sign up with your email and password, I'm going to make this into a span because technically speaking, our title, which I'm going to use an H2 instead of an H1, just so that in terms of the HTML, it's a little bit more clear to web scrapers that this isn't something as high ranking of a title as an H1. So I'm going to use an H2. Here, I'm going to say something like, don't have an account, like so, because this is a pretty common format for a sign up. And then what I'm going to do is I'm going to make a sign up form style sheet. So I'm going to say sign up form.styles.sass. And inside, I am going to say that the styles will target our sign up form container. And I'm going to give it display flex, flex direction, column. I'm going to set the width to 380 pixels. And then I'm just going to target the H2. And for the H2, I'm just going to say that I want to give it a margin on the top and also no margins on the side. So just margin top, bottom, no left, right. And then here inside of our sign up form component, I just need to make sure to also import in that style sheet. And now let's save this. We go back to our application. And there we go. We see that we have what we need inside of this form. Next, what we need to do is we need to now create this button component. So here we see that we have this button component. Let's recreate this button. So let's actually think about what this button entails. We notice that this button has some custom styling, but we also know that there is this sign in with Google button. So this button and this button look the same other than the fact that there's a couple stylistic differences in how they perform. So there might be some consideration here for us to already think about making a general button component that can adapt to the styling required for where it's used. Let's check around and see if there's any other buttons anywhere. Here we see that we're still using a regular black button. And inside, we notice that this button is a Pay Now button, but this one is actually not as required for us. Inside of the application, we also notice that there is this same button that we had before, but it's inverted. So if we check, we know that we have our black button, but inside of here, we also notice we have a default white button that when you hover, turns black. So it looks like there are three types of buttons. There's this default black button, there's the inverted button, and then there is this sign in with Google button. So now that we have these three different buttons, let's start coding out the button component itself. So the first thing that we want to do is we want to make a general button component. So inside of components, let's make a new button component. So we'll make a button folder and we'll do button.component.jsx. Now, for those of you wondering with this button component, shouldn't we name it something else since there's already a button HTML element? Well, for us, our button is actually always going to be capitalized because as we know, we can't write different components that start with a lowercase letter. So our button is just a capitalized button. And that's enough for us to know that that is indeed our button. So here I can say const button is equal to a functional component that will return a button that has some specific styling. So it's still a button at the end of the day. The only thing is just that we know we need some class name that we can target for this button to apply our styling to it. And what we're going to apply to this is, let's call it button container. And then inside of our button, we want to use this button the way that you would use any button, meaning that whatever inside text or H1s or P tags or span tags you put in the button, we want to do the same inside of our button. And that will just, of course, be the children. So we'll just render the children inside of this button component. Let's export this out by default. And let's do a little thinking here. We know that we have 3 types of buttons. So here, what I'm going to say is that we know inside there's 3 buttons. We have our inverted button, we have our default button, and then we have our Google sign-in button. So how do we leverage this button type in order to show styling for 3 different kinds of buttons? Well, what we can do is we know that we're really just modifying this one button styling. So really, perhaps we can control the styling by a class. So we can have default styling for a button, inverted styling, as well as Google sign-in styling. And how we can do that is we can create some kind of variable. Let's call it our button types, for example. And here we know that what we're telling it to apply is classes. So we can even do button type classes as the name of this object. And inside, we know that, for example, if we get past some value like button type, if the value is the string of Google, then we want to render the class name Google sign-in. And if we got inverted, then we'll show inverted. And what this does is this allows us to use a more readable and legible kind of input for button type, but render whatever it is internally that we need in order to properly display this button type. So through this one value that we're getting as a prop, we can now control how we want to render this button. It's just that right now we're only doing it by class name. So let's just destructure, or not destructure, but let's string interpolate button type classes, like so. And in fact, in order for interpolation, this needs to be JavaScript, and I need to change my regular quotes over to backticks. But I'm going to say button type classes, and then I'm going to call button type off of button type classes. So button type here is expected to be a string. And remember, with our button, we pass it all those other values that we were seeing inside of our signup form. We had a type of submit. So here, in order for that to go through, we can do our ... other props. And then we'll just spread this in after the class name. So now let's save this. So now that we have this class name set up, how do we actually get the styling? Well, as you guessed it, I've already done the styling for you. So create a button.styles.sass file. And then inside, paste in the button style sheet that I provided for you. So once you've pasted it in, you can see inside we have our button container, which is our class name that adds all of these different stylings and hover effects. But you'll notice that I have the Google sign-in class name styling and the inverted styling that will overwrite some of the styling that applies by default. So now we just need to make sure that we import this in. And then inside of our signup form, let's import in the button itself. And then all we need to do now is come down to our button and paste this in. And now if we save this and we go back to our application, we see we have our button. In fact, now just to confirm, let me add a button type, which is equal to, let's say, Google. If we come back, we see it becomes a Google button. And then If we change this to inverted, we see we have an inverted button. So there we go. We have our button component. I'm going to switch it back to the default, and it's the default. Awesome. So we've styled our sign up component as well as our button. So now that we have all this set up, let's actually work on our sign up page, and then we can finish up this overall page for sign in and sign up. Now there's two things left that we need to do before moving on. The first is that we need to actually commit our code. So let's go back to our terminal. Let's add all the things that we did. So here I want to say that I created the sign up component, the form input component, as well as the button component. And then let's push this up. And the second thing that I want you to do is I actually want you to attempt to create this sign in component. Here, all the sign in component does is it takes an email and a password and it tries to verify. Otherwise, you can sign in with Google. It looks very similar to our sign up component, but with the sign in portion, you may have to look inside of the Firestore docs a little bit to figure out the method. But I want you to at least try and figure out how to replicate pretty much what we have here, but inside of sign in, and just trigger a callback for sign in. You don't necessarily need to actually call the method, but at the very least, I want you to try and recreate what we did for sign up, but here, create it for sign in, because we already have all the components. We already know all the logic. So this is a good chance just to practice everything that we've learned for building the most complex component that we've built so far. So good luck, and I'll see you in the next video. Welcome back, everyone. In this video, we are going to start building out our separate sign-in form. But the first thing is first, we might need to shuffle around a couple things, which is also a great habit that you will build as you're building out features. The key thing that we set up earlier was we set up this sign-in page. But what we'll notice is that what we're going to host inside of this sign-in component is going to be both the sign-up form, but also the sign-in form. So calling this sign-in isn't necessarily accurate anymore. And you'll notice this as you develop your features, that sometimes you'll need to rename folders, rename files, rethink about how you've architected a lot of these different structures that you've already set up, in order to make it more accurate to reflect what you need. So what I'm going to do is I'm actually going to change this sign-in over to authentication, which makes more sense, which reflects what it actually is, which is that we're particularly authenticating our users. Now that we've updated this folder structure, we also need to correctly fix the places where we were importing this sign-in before. So where we had it before was inside of our app.js. We were importing in sign-in from sign-in.sign-in component. So let's rename this to what it actually will be, which is our authentication. And here I am also going to update our app.js. I'm going to update the component to our new authentication component, and I'm also going to fix the deep linking over to the correct route. And also for path, I want to change this to auth, because sign-in is no longer accurately reflecting what the path represents. So we've updated our route. We also need to update our navigation. So inside of our navigation component, we need to switch this from sign-in to auth so it takes us to the correct place. So let's make sure that everything's working now. Let's go back to our application. We click our sign-in. It takes us to auth. It renders the correct component. So here everything works. The next thing we need to do now is we need to start setting up the appropriate component structure. So here, what we're going to do is we are going to go up to our components. And what I want to do is I actually know that the sign-up form is pretty similar to what we're going to need for our sign-in form. So I'm going to copy the whole folder and just paste it in. And then what I'm going to do is I'm going to rename this folder as well as the files. I'm going to call this sign-in form. And then what I'm going to do is I'm going to rename these different files to sign-in form, and similarly do the same for the styling. Next, what I'm going to do is I'm going to update the appropriate places. So here, I want to make sure that I'm importing in the correct sign-in form styles. And also, For the form name, I'm going to rename this to sign in form. And now let's save this. So let's think about the differences between our sign in form and our sign up form. We know we don't need their display name, and we also don't need their confirm password. We just need the email and password. So similarly, we know that for these form fields, we also will not be destructuring off display name or confirm password anymore. As for the handle submit, because we're not doing any password confirmation, we don't need that code. And here, this whole try block is probably not going to be correct. We'll have to figure out something brand new for this code, as well as the error. So we're essentially just removing everything we know that we won't need. But the handle change is going to stay the same, because similarly, these input fields are going to need to reflect changes, which we're going to capture inside of our use state. So everything here can stay. Inside of our actual form, though, we know that we need to change this text. So we can say something like already have an account. And then we'll just say sign in with your email and password. And inside of the form itself, we don't need this form input for display name. We need the email, we need the password, but we no longer need confirm password. And finally, for the button type, we just need sign in. So here, let's save this. And what we want to do is we just want to bring this into our actual authentication component, just so that we can make sure that everything is working, as in everything is plugged in properly. So I'm going to update this to sign in form. And then what we want to do is we want to place the sign-in form onto our page. So here, we've just replaced that button that was our login to Google. And here, now we see inside, we have our sign-in page. So everything is working. Let's add now the actual functionality to sign in as well as our Google sign-in button. So we already have our actual method. I just want to copy this over from our authentication into our sign-in form. So inside of the sign-in form, I'm just going to create this method. And what I want to call it is sign in with Google. And here we notice that we need this import. So this import is going to be coming from Firebase utils. So let's copy that over. And earlier we had taken this user doc reference to console log it, but we don't need that anymore. So we can just get rid of it. We just need to know that we're creating a user doc auth. So we're going to copy this sign in with Google method. And what I'm going to do is I'm actually going to create another button. And this button is going to be our Google sign in. But remember, we only need one submit button. With Google sign in, we don't actually need the submit button. We just need it to trigger our sign in with Google method. And here, if we save this, we go back, we see that we have our Google sign in. And when we click it, it does indeed trigger our Google sign in. So awesome. Everything here is working so far. So let's go back. What we also want to do is we want to set this button type over to being a Google button. So here we can just pass it the string Google, and we can save this. And we see that now we have our Google button. But now we need to style this a little bit. So I'm going to make a new div, and inside of this div is going to be our to button. And I'm going to apply a little bit of styling to this div inside. And what I also want to do is I want to give it a class name. So I'm going to call this buttons container. And inside of our sign-in form styles, I'm just going to modify this buttons container so that it has display flex. And then I'm also going to justify the content so that it is space between. And now if I save this, there we go. It looks much closer to what we had before and what we were looking for. Now, as for the actual functionality of submitting this email and password, what I want to do is inside of our sign-in component, I want to create this method. So remember, What we had before was that we need to try something where we are able to take email and password and sign them in. So what we got to do is go back to our Firebase utils. And inside of Firebase auth, if there's a create user with email and password, turns out there's actually a sign in user with email and password. Sign in user, sign in with email and password. There it is. Sign in with email and password. So similarly, we want to create another interface layer through a helper function. And we'll just say that this is sign in auth user with email and password. So similarly, just like we did with our create auth user, if we don't get an email or password, we don't want to run our function. But when we do, instead of running create user with email password, we want to run sign in with email and password. Similarly, as you expect, you pass the auth, you pass the email, you pass the password. So let's save this, copy this method, go back to our sign-in form, paste it inside, and now inside of our try, we can just const get back our response, and then we'll just call await on this method, passing in email and password. And then let's console log the response. So if we save this, we come back, we open up our console, and here, let's say I knew that the email I had was mike@gmail.com, password is 12341234. If I hit sign in, I see that I get my user object, and inside with my user, I get my access token. Here, everything works as expected. The UID, which is this one, ZMJDAF, inside of our Cloud Firestore is the correct one, ZMJDAF. There we go. We have authenticated our user using email and password, just like that. So simple. Much of this is pretty much just a recreation of our sign up component, except with a couple nuances and tweaks. And also we just needed to integrate our Google sign-in button. But everything here is just putting together all those little bits that we already learned. So in the next video, what we want to do is we want to style this page so that it looks a little bit more polished, and also clean up any last remaining bits and pieces that we have before we're ready to move on from our authentication. So with that, I'll see you in the next video. Welcome back, everyone. In this video, we are going to finish up what we need for our sign-in form component, and we're also going to finish styling our authentication page. To begin with, what we want to do is we want to be able to indicate to our users if some kind of error happens. In order to do that, let's console.log the error so that we can see what happens. So let's go back to our application. And here, instead of using an email, let's just see what kinds of errors we can get when we try and sign in with nothing. If we sign in with no required filling fields, we see that we get this required message, which is great because that means that our form input with required is working. So I'm just going to pass an email, and let's say I pass an incorrect password, just an incorrect random password. Here we see that we do get some error. Firebase error, auth wrong password. So this one is a great one that we can use, similar to what we had before. We can say that if error.code is equal to auth wrong password, and what we want to do is we want to alert to the user that there is an incorrect password. So we can say incorrect password for email. Let's save this. Let's go back here. Let's try this again. And there we see it, incorrect password for email. Similarly, what if we have some kind of email that doesn't exist? Here, if we sign in, we see that we get auth user not found. So here what we could do is we could do an else if statement and do a similar error code equals this one. But what instead I want to do is I want to make a switch statement. So what this switch statement allows me to do is it allows me to run code depending on what gets matched inside of error.code. And what I can say is that if the case, in this particular case of error code, is equal to auth-wrong password, like so, then what I wanted to do is I wanted to alert incorrect password for email. And then I want a break. And I'll explain what the break is after. So first, let's just comment this code out. And let's do the same thing for this other auth. So I'm going to make another case for auth user not found. Similarly, alert. In this particular case, no user associated with this email. And we'll break again. And then by default, we'll just console log the error, assuming that we don't know what it is. So in this particular case, what is it that we see inside of our switch statement? So let's break this down. What switch does is switch is the equivalent to almost saying if, and then with this code is equal to this. If it's equal to this, run this. Else, check if it's equal to this. If it is, run this. And otherwise, if none of it matches, if none of these strings match the error code, then by default, just run this code. The break essentially says that once you found a match, don't check the next subsequent cases. You can imagine that if we had like 5 different cases down here and we didn't have this break, what happens is that essentially without these breaks, error code is going to, let's say, match auth.wrongpassword. Let's say it matches. It's going to run the alert, but then it's going to try and keep matching these cases, even though we know that the error code has already found a match. So with a break, it allows us to prevent that from happening. Now, one thing I do want to mention is that some of you might be wondering, where can we find all of these error codes? Unfortunately, there's no real compiled place or list right now that Firebase for authentication in our current version that showcases what all of these error codes will be and what they are. If you do find it eventually, please send it to me because I've been looking for a long time too, and it's actually a common thing in this community using Firebase that Google has not yet provided this full list of these error codes as well as what they are. But that doesn't stop us from at least addressing these major and currently seen primary error codes that we know are most important for sign-in. So now that we have our alerts, there's actually another thing that I want you to see. If I scroll down here and I look at this button, our Google button, if we come back here, we know that when I hit the Google sign-in, what happens is I should just open our Google pop-up. But let's take a look at what happens. I hit Google sign-in. I do indeed see that we have our Google pop-up. But what I also see is that for some reason, our alert fired. No user associated with this email, which we know is our error that we see for an unassociated email. But why is it that when I hit the Google sign-in, this form also tried to submit? The reason for this is because by default, buttons are of type submit inside of forms. For us to prevent this from happening, we have to just say that the type of this button is just a button. And now, if we save this and we come back, we clear this, we hit our Google sign-in, we see that we didn't end up noticing that we have an error, and also our alert did not fire. So these are pretty much the only last few tweaks that we need to make for this code in order for it to work. So let's also just, for now, keep the response because after this lesson on authentication, there's a couple other things we want to do with the user object. But let's just tidy up the visuals of our authentication. So let's go to our authentication component. And what I want to do is I want to get rid of this import because I definitely don't need it anymore. But I also want to create some styling so that I can make sure that the authentication page looks how it's supposed to. So let's make a authentication.styles.sass. And looking at the component itself, what I want to do is I want to give this a class name. And I'm going to call it the authentication container. And here, I also don't need this sign-in page anymore. The H1 is done with. And this class name of authentication container is what I want to style. So if inside, I'm just going to do a display flex direction in this particular case, or not flex direction. I'm going to say justify content is space between. I'm also going to set a width, and I'm going to give it 900 pixels because I know each one inside is 380 pixels as we set. And as for the margin, I want a top bottom margin of 30 pixels, but then I want auto margins on the side so that it's centered no matter how big your screen gets. And then finally, I want to make sure that I import in this new style sheet that we've created. So here, let's go back. And there we go. We see that we have our sign-in page. Everything is pretty much working now. And that's it. We finished styling the sign-in page. In the next video, what we're going to do is we are going to learn what to do with this user that we have just signed in. And we have to think about how leveraging this user allows us to perform certain functionality. So we're going to think about the purpose of the user, but we're also going to think about how in React we're going to store and use this user. So join me in the next lesson where we're going to talk about React context. I'll see you in the next video. Welcome back, everyone. In the past few videos, we've learned about how to authenticate and also get the user object from Firebase. We've learned how to sync it up with our front-end application by creating these sign-in and sign-up forms. And primarily now that we have the user and we have a way to authenticate them, let's discuss how to actually leverage that user object that we're getting back inside of our application and think on a higher level about what to do with said user. Now, before we talk about that, let's go back to our terminal and let's just commit our code. So I'm going to say that what we've done and what we have to commit up is that we created authentication page component alongside our sign-in form. So let's push that up and then let's discuss what we need and why we need to store this user. So in order for us to better understand what it is that we want to do with this user object we get from our sign-in, let's think a little bit about our components inside of React. Imagine that this is your component tree. Up at the top, you have your application. Down lower in one level, we know that we have our auth page, and our auth page is a child of our top level app component. We know this because auth is nested in a route nested inside of our entire application component. Similarly, auth has two routes, both sign in and sign up. Now imagine, for example, we had two other routes that were also children of the app, but they were siblings of auth. Imagine on the left, we had some kind of settings page. On the settings page, imagine we had a user page, and within the user, maybe we have some profile page. Similarly, on the right side, imagine we had this orders page, which kept track of your orders history, but also the returns that that user might have made. So here you can imagine that for these routes on the left and the right, the settings and the orders, that both of these need access to this user object that you get from your sign-in and your sign-up. So here, the key thing to remember is that based on what we've built so far, we know that when we get that auth user object, we either get it in the sign-in or we get it in the sign-up. These are the two places that we directly get from Firebase the actual user auth object. From here, though, we can imagine how on this left settings side, that profile needs that user object. Because how else are you going to know what the actual profile of this user is? Maybe on the profile page is how you update display name or you change the email. But the key thing here is that this profile needs access to the data that we got from sign in and sign up. Similarly, you can imagine how on the right side, maybe there's orders and returns and history. And in order for you to know what users' returns or history you have access to, you specifically also need the actual user object. So here you can see that what's the history of the orders for which user? Well, we only know that if we pass to our backend that gives us the order history, the user itself. We can see the same thing might be true for returns. So how would we actually be able to surface up this user data that lives in the sign-in? Well, what we would have to do is we would have to figure out which of these components is the top level common parent denominator. So if you look at this, at what point is there going to be some node that can access data and then distribute it out to the corresponding profile, returns, and history? Well, that would be the app component, because the app component is the highest level parent that can then in turn actually pass these props down to the corresponding correct children. Sign-in can't pass it directly to profile or returns or history. The reason for this is because, as we've seen with components, we can pass props down into children. In turn, we can find certain ways where we pass callbacks from a parent down to a child so that we can get the data up to the parent. Both ways are pretty cumbersome and pretty tied together, but it can be done. So here you can imagine that by using a similar pattern, we can pass the sign-in user data up one level before going back up to the app. Then, in order to give it to the profile, we'll have to go over to that settings page, and then from the settings component, pass it to its corresponding user child. And then finally, from user, we can finally pass it to the profile. Similarly, on the right side from app, again, at the top level, we pass it over to our orders, and then from orders, we pass it to returns, and similarly from the orders, we pass it to the history. So here we could see this as a pattern where we'd be able to sign in and get the user data at the sign in and sign up, pass it all the way up to the app, but then pass it to the profile and pass it to the returns through all of the corresponding parents and children all the way down to those components that need them. But here, I hope you notice a problem. All of these orange nodes do not need the user data. All they serve to do is act as a traffic nodule almost. It's just a path that we have to pass user data through in order to get to the profile. And the way we pass it is we pass it through props. This is actually something known as prop drilling, because in order for you to drill the relevant data down a stream of children to the correct node component that actually needs it, you have to write all these props for all these intermediary components that don't even need that data in the first place. For example, app doesn't need user data. Neither does any of the settings nor the user component. Only the profile component on the left needs it. So here, it just makes no sense. You can see how profile returns and history are the only ones that actually need this data. So how do we actually make this work? Let's just focus on the sign-in component. The sign-in component we know is the entry point that gets that user data. How do we get this user data to the correct two nodes? Imagine that we just had these two red nodes that needs this. Wouldn't it be great if there was some way where we could actually create some kind of storage place where we could access it anywhere we want? We wouldn't have to drill through props or anything like that. So let's say we signed in with our user, and what we wanted to do is just store this user data from the sign-in into this kind of external storage place. And then once the user data is there, it can just directly pass it over to the corresponding nodes that needs it. No need for any of this prop drilling. Well, this is actually exactly what React Context allows us to do. It allows us to store our data somewhere so that we don't have to go through this cumbersome process of passing all of the relevant data we get down from some kind of child all the way up to some common ancestor, and then from that ancestor prop drill down to all of the relevant and necessary child components or grandchild components or grand-grandchild components that actually need this. Instead, what we can do is just take that sign-in, pass that data up to some external storage placement, and then anyone that needs it can access it from their corresponding place in the actual tree directly from this storage. This is context. So this is what we're going to learn in the next lesson. We're going to learn how to leverage this context in order to both store the user data and also access it later. So let's do that in the next video. Welcome back, everyone. So let's talk about what it is that we need to do with this user object in a very narrow focused feature that we want to build. Let's say that inside of our navigation component, what we want to do is that when a user is signed in, instead of saying sign in for the link, we want to instead show a sign out link instead, so that when the user clicks it, we sign them out of their account. How do we do that? Well, in order to do that, we need to be able to register and figure out whether or not a user is currently signed in or not. And the way we do that is we know that we get back the appropriate user auth as a response whenever we sign in successfully or whenever a user signs up. So how do we store this inside of this context that I've talked about? So let me show you how it is to create a context in the first place. It's very similar to a component that wraps around all of your other components that need access to this context. Context you can kind of see as a storage place, except it's a component that exclusively stores things. So let's build something with context. Inside of your source folder, I like to make a separate folder for my contexts. So I'm going to say contexts like so. And inside, I want to make a user.context.jsx. Remember, it's .jsx because we are writing out a component. So in order to use context, we have to first create a context using the createContext method that we get from React. Then what we're going to do in order to create this context is first we need to actually export out the context itself. So you can see the context as being two pieces. One is the actual storage thing itself, and this is the literal context. So for us, because it's a user context, I'm going to call it user context. And this is equal to calling createContext, which will build out a context for us. And what we want to pass to it is the default value. Not necessarily the initial value, but kind of like the default value. We'll talk more about this. So actually, before we even start filling it out, let's just discuss the other pieces of it. So this I want you to see as the actual value you want to access. And then there is also going to be a provider. So we want to export both of these, both the context and the provider. So a provider is the actual component. So this user provider is going to be this literal functional component. And what we do is we receive children. And what we need to do is we need to return user context dot provider. So on every context that gets built for us, there is a dot provider. And the dot provider is the component that will wrap around any other components that need access to the values inside. In here, we are just going to render the children. So essentially what happens is that, let's say you have app, for example, app being our app component. We're going to wrap this in the user provider component. And then inside of app of course will now be the children. So we want to take this children and then put it around our user context provider. This is really just some kind of alias component that allows us to use this user context.provider and wrap the children. So what else do we need to pass to this provider? Well, this provider is where it's going to receive the value, which is going to hold the actual contextual values. So this is where it might get a little confusing, but follow along with me now. What we know is that we want to store a user object, so current user, for example. And what we can do, because it's a component, is leverage all of our hooks that allow us to store things. So we want to store a user state. Let's just use the use state hook. And here I'm going to say that current user gets both the actual value, but also the setter function. And I want to be able to initialize this value as null. Next, what I want to do is I want to actually generate the value that I'm going to pass in here. So this is going to be an object that passes the two values that are important, which is both the current user as well as the set current user. So both the setter function and the actual value. So what you can think about with this provider is that this provider is essentially allowing any of its child components to access the values inside of its use state. So we're just doing use state as we normally do. We have a value for that use state and we have the setter for that use state. But I want to be able to call this setter and get the value anywhere inside of the component tree that is nested within this actual provider value. So then all we do is we pass this value into here. And now we go back to this context. And remember, we're trying to instantiate the initial point of this. So I know that this value you can see as if Well, you're like, Yihua, didn't we pass an initial null value into current user? We did. But this is for the state. This is not necessarily for the context. The context needs an initial value as well. And we just want to build the base empty state of what this is. So current user being a actual object, usually the empty state of an object should be null, because you want a null check to define whether or not you have a user existing object or no object. An empty object is still going to evaluate as true. So we know that there's no context when the current user value is null. And then what's the default value of a setter function? Well, this is actually just a function that does nothing. So it's an empty function that returns null. It's the most basic type of blank function you can think of. But this is all we need. Essentially what's happening is we are going to create this user provider, and we want to wrap it around the portion of our code that matters. So I'm going to go into index.js, and I'm going to wrap the entire app component inside of this. So let's just first shuffle these around so that they're in the right order. And we're going to import in our user provider from our contexts folder. So context, user context. And then all we need to do is wrap our app inside of our user provider. So now any component inside of this user provider, nested deep within the app, can access the context value inside of the provider itself. So the user provider is solely meant to tell us, oh, inside of my component tree, which components have access to my context. It's going to be any component inside of the provider. Anything outside will not be able to access the context. So here inside of app, we know that we want our sign-in form to be able to access this context, because whenever the user signs in, we want to actually take this user object and we want to store it inside the context. So to do this, we need to use two things. First, we need to use the use context hook, and then we need to bring in the actual context itself. So we're going to go into our context folder, and we're going to import in the user context object. This user context object is going to give us back whatever value is passed in for the value. And our value is the current user of useState, as well as the setter function. So this value we've instantiated as an object, so we'll get this exact object back with whatever the current user value inside of the user provider's useState is currently set at. So here, in order to utilize this, what we need to do is come down here, and we'll say const is equal to use context, passing in the user context. So as we know, we get back an object, and for our sign-in form, we just want to set the value. So I'm going to say set current user, and I'm going to run set current user whenever this user value comes back. Then what I want to do is that I want to access it inside of my navigation component. So in my navigation component, I'm going to do the same thing. I'm going to import in the use context from React, and then I'm going to import in the user context value from the context user context. But this time, what I want from the user context is the current user value, not the setter. So I'm going to call use context on the user context the same way that we saw when we were pulling the setter function inside of our sign-in form. But this time, I want the actual value of current user. So now if I console log current user and I save this and I go back to my application here, what I'm going to do is I'm going to pass in and sign in. So as we know, what should happen is that our sign-in form signs in, gets the response, destructures the user, stores it into our context. But then what should happen is that it should log from our navigation component. So here what's happening. Why is it that this component ran? Remember, the fact that we logged it means that our functional component was re-rendered. The reason why is because use context as a hook tells this component, oh, whenever a value inside of this context updates, re-render me. So what's happening here is that because we're leveraging this current user value, we are saying, oh, I want you to run my functional component again and re-render me because this value inside of the user context has updated. And the reason why this triggers is because of useState being called with the setter function. So as we remember, a component re-renders whenever its state updates or whenever its props changes. Here you can imagine that this useState value setter function was called. This current user value updates. That means that any component that is listening for current user should in turn update, meaning that it should re-render, which our current user does. Because if the current user value updates, we most likely will want to update our JSX because there's a chance we're using it as part of our UI. So this is how context works. It seems complicated, but really all it is that this context is just a glorified component that is really just leveraging useState. And all we're doing is exposing the value as well as the setter of this useState value externally. Whatever values that you want a component to be able to expose, you can also expose through a context, which we will see later throughout the course. But really, this is all that's happening here, is that we created some parent level component at the very top of our app that gives us access to some component inside's useState value. Then inside of our respective places, we're either getting and using the setter, or we're getting and using the actual value. This is useContext. So in the next video, what we're going to do is we're going to talk about some of the nuances with useContext in our model of understanding re-renders with components. So I'll see you in the next video. Welcome back, everyone. In this video, I want to discuss a little bit more about these re-rendering cycles and how it reinforces what we kind of already know about React and re-rendering. But it's still good to really understand this mental model. So let's walk through this. Here inside of our navigation component, we know that we're leveraging this current user that we get from useContext. But in order for me to show you a couple things, I'm going to change up how some of these components are calling different things. And you just have to follow me here. I'm going to stop console logging current user in our navigation. What I'm going to do instead is inside of our signup form, I'm first going to just console.log out the word hit. And what I'm also going to do is show you inside of this component. So when we refresh and run our application for the first time, when our signup component mounts, we see hit from signup. This is perfectly expected. What I also want to do is I want to turn on paint flashing. So this is from the rendering tab. If you remember, inside of the 3 dots down in more tools when you select rendering. This will show up, and then I want to click paint flashing. The reason why I want to do this is because I want to show you right now our signup component, despite being nested inside of our top level context component. Remember, user provider is wrapping app. Inside of app is sign in, sign up, navigation. Everything is a child of app. But what you'll notice is that despite the fact that when we sign in, we know we're setting user inside of that top level provider. What you see though is that hit does not rerun. This is just that initial call when we mounted for the first time. So clearly, this component is not getting called at all. But what happens if we actually hook into this signup form? So I'm going to keep the console log hit actually. And what I'm going to do is I'm going to bring in the useContext hook. And I'm also going to bring in the userContext object. And what I want to do is I just want to hook into it. So I'm going to say const val is equal to useContext, userContext. Now what happens? Well, because now I've hooked into the context, as long as user context values change, this component is going to rerun. So what we should see is that when we refresh, everything mounts for the first time, of course. But we see that initial hit value that comes from our signup form. And what will also happen is that when I sign in to my user and the provider updates, notice that hit gets called again. The reason for this is because the signup form is hooked into the context, using the useContext hook. Even though we didn't do anything with any of those values, React doesn't care. The fact that you're hooked in means that this component needs to rerun. This function, at the very least, that represents our signup component. However, notice that none of the actual portions of the DOM updated, despite the fact that React reran the code. It did not actually re-render anything on the DOM. And the reason for this, of course, is because nothing changed on the DOM. So this is where that virtual DOM and the actual reconciliation steps that we walked through way back in the beginning of this course prove itself again. So this is one important thing I want you to know. If you have multiple components that are all listening to a context, even though they don't use the actual values, for example, just as we see here, we're just initializing the value. We don't actually do anything with it. The fact that you're hooked into the context will cause React to rerun your function. Now, it doesn't mean that it will re-render anything to the DOM, because it only will if your JSX values actually update based on this value. However, what you still need to think about is the fact that all of the code up until that return statement is still getting called. That is a very important thing to know. The fact that this code is getting called could be a performance problem if you have hundreds of components that are all hooked into a context. So this is just something to really consider and think about. But now that at least we understand that the way that React decides to re-render things is still within the exact same knowledge that we had about components and how they re-render things, really not much has changed. You can kind of see useContext as just a glorified hook into another component that will re-render its subsequent hooked components whenever this component updates in some way. And the only way that this component updates is if we trigger it to update using useState, useEffect, whatever that we designate. And we'll talk more about this in the next upcoming videos. But I just want to clarify this particular point about components hooking into context and getting recalled, or not necessarily re-rendered, but at least the function's getting rerun. So now that we understand this, let's get rid of this code that we have here inside of signup form. We're going to keep this code right here because we will need to update signup form. But that's my challenge to you. I want you to utilize useContext and userContext for signup form to also set the user when we successfully authenticate with email and password. So do that, and then I'll see you in the next video. Welcome back, everyone. In this video, we are continuing to store this user object that we get back from authenticating our user throughout our application inside of the user context. So here we are inside of our signup form, where we will be indeed storing the user object that we get back from create auth user with email and password. One thing I want you to notice though is that inside of this component, we are actually also taking this user auth object and building out a user document from this auth. So some of you might wonder, why are we storing this user auth object instead of the actual document object that we have in our Firestore database? In this particular case, you're actually correct. We will be doing that later. But right now, what I'm practicing is really just storing this one user so that we get familiar with context before we actually start extrapolating out into the actual document. Because in order to do so, we have to create a new method for our sign-in form so that when we get this object, we also make sure that we, from this object, fetch the user doc from the authentication. So before we do any of that, we just want to make sure that we do that in our signup first. So one important thing is that we have already pulled in our user context and our use context. What we're going to do is we are going to pull off that same set current user. So I want to pull this off of use context from user context. This is pretty much just a repeat of what we've already done inside of our sign-in form anyways. And here I'm just going to call set current user. So now whenever a user signs up for the first time, they're also going to have their user set inside of our user context. Now what we want to do in order to test this is also build out what we're going to do with this current user. So here with current user, the primary thing we want to code out is that we want to be able to display a sign out link instead of a sign in link when a user is actually signed in. So here I'm going to say when there is a current user, then what I want you to render is a different link. So here I'm just going to use a span, and the span is going to have the class name of navlink. This way it inherits all the styling of all of our links. And I'm just going to say that this is sign out. If the current user does not exist, then what we'll do is we will render our sign in link. Here I see that I have made a mistake like so. My brackets are off. There we go. Okay. So as I was saying, if current user, then we show a sign out. But if there is no current user, then we show the sign in. So let's go back to our application. We see that we haven't signed in a user. So we have our sign in. But once we sign in with this sign in, then we see the sign out button. So let's refresh. Earlier, as we know, we also linked our creation account to this sign up. And when a user signs up, we will also store that user inside of our context. So let's test that as well. Here, I want to make a new user called Mike, and I'm going to use mike2@gmail.com. Password is 12341234, just as we had before. And once I hit sign up, this sign in should also change to sign out. So I sign up. There we go. I see that we are properly working. Context is storing this user, so everything is working as expected. Now what we want to do is allow this sign out to actually sign a user out. So in order to do that, we need to go back to our Firebase utils file. Here what we need to do is import in the sign out method. This sign out method, we want to create yet another interface layer function. So I'm going to say this is sign out user. And this is a function that calls sign out. And what sign out takes is, as you guessed it, the actual auth singleton, which is what informs the Firebase sign out method which user to find on the auth. Because remember, the auth is also keeping track of what users are signed in right now. So here we just copy our sign out user method. And what we're going to do is go back to our navigation component and let's import this method in so that we can use it. So I want to go import sign out user from the utils file, Firebase utils. And then all we need to do now is that whenever you click sign out, we'll just say on click sign out user. So what should happen here with sign out user? Sign out user will sign this user out. The problem though is that when this user signs out, we don't actually know whether or not the user is signed out based on our context, because our context has not hooked up to it yet. So what we should do is actually create yet another method. We'll call it a sign out handler. And here, this is just a function. This function is what we're going to pass into the onClick instead of the sign out user. Because what needs to happen is, let's make this an async function. What we want to do is we want to await what sign out user does. Sign out user returns back sign out. So this we can also make an async function, because what we want to return is the promise of whatever sign out returns back to us. In this particular case, we don't know yet. So let's see. So I want to await, and I want to set this value as response. I want to await sign out user. So sign out user is a function that's just returning us back whatever sign out gives us back. And because this method is most likely asynchronous, we get it as a promise. So we just want to get that value, and then let's just console log it. So now I want to save this. I want to go back. I want to open up my console. And here I see that we have our sign out. So we know that our user is still authenticated. If I click sign out, what we get back is undefined. So what we can do then, knowing that if we have successfully called our signout user, we've probably succeeded. Then we don't need the value, but we can simply call setCurrentUser to null. And now, if I save this and I go back, let's refresh. We have no initial value. I'm going to say mike@gmail.com, 1234, 1234. I'm going to sign in. We see that we have successfully stored our user. And now if I click sign out, what we notice is that I've signed out the user and I've also reset the context. So here we are leveraging this context in order to store our user, but also track the authentication state of our user. So hopefully you can see how easy it is to leverage this context in order for us to keep track of some value that we get from an API and then use it internally in our application. So here though, we know how context works, but we can actually optimize our code for Firebase a little bit. Because what we're doing here, as you'll notice, is that we're relying on code that's spread out throughout multiple parts of our application. The sign-in form, the sign-up form, as well as the navigation component in order to track this user authentication state. Luckily for us, we can actually consolidate all of this in one place. And this is using a new method that we get back from Firebase, which allows us to actually observe whenever authentication changes. So when a new user signs in or whenever user signs out, we can actually track all of that in one place. And I'll show you how that works in the next video. So I'll see you in the next video.
Hey everybody, I want to take a quick break here. Go grab a coffee, grab a tea, just take a break from all the learning that you just did. And I want to talk to you quickly about imposter syndrome. It's this idea that you're not good enough, that things are too complicated for you to ever achieve what you want to achieve. You look at other people, at other industry experts, and you say, I will never get there. But it's just a symptom of learning. This idea of you not being good enough simply means that, well, you're just not there yet. Things take time. If you want to learn a valuable skill, well, it's hard work. That's why it's valuable. Remember how you felt on the first day of going to school, first day on a job. It's the same experience. But over time, with repetition, with practice, you get comfortable, you get experience, and you slowly start to lose that imposter syndrome. Now, this idea of an imposter syndrome is great. It means you're doing something worthwhile. So don't use it as a negative. Use it as an encouragement that you're doing something good, that you're learning and you're stretching your limits. So with this break, I want to propose that we do a quick exercise. I want you to stop the lectures. Again, grab a coffee, grab a tea, and head on over to our Discord. Now, in our Discord server, if you've used it up until now, that's great. If you haven't, head on over to this server, and I want you to do something that I think it's super important to learning. And that is using what you've learned up until now to actually teach someone or help someone. So you can go all the way to, let's say, the coding and courses section and pick a topic that you want to help somebody in. So let's say you go to the Python channel. And in here, you'll have other students that are asking Python related questions. Now you can scroll through here and see if you're able to help someone. Even though you may not have the experience or the knowledge yet, this idea of practicing and explaining what you've just learned to other people, even if you're not 100% certain, actually is beneficial to your learning. Because if you're never teaching, if you're never explaining and vocalizing and showing what you've learned, you'll always be a beginner. This idea of teaching what you learn is a very important concept. So moving forward, as you go through the lectures, anytime you feel like taking a break, hop on over to Discord and help somebody. Our motto here is that we're always kind. We don't judge anybody. We're all just beginners here. We're all learning. So don't be afraid to answer things because you got to remember, nobody's perfect except for Yoda. Yoda is pretty perfect. All right. I'll see you in the next one. Bye-bye.
Welcome back, everyone. In the last video, as I mentioned, we have utilized our new user context in order to store our user wherever it either signs in or signs out. We know that in our sign up form, our sign in form, and our navigation form is currently where the majority of that code is living. But we can start to see that this might be a little difficult to keep track of. In fact, we actually missed another place where we need to store this user inside of our user context whenever a user signs in with Google Popup. Here we know that we're authenticating the user once our sign in with Google Popup succeeds, so we actually need to also set current user here as well. But the larger pattern that's emerging is that we're noticing that we're spreading out all of this different code in multiple places. So what we want to do is we want to be able to now move this code into one centralized place. And luckily for us, Firebase actually gives us an easy way to do that. We can actually start using what's known as an observable listener. And an observable listener is a way for us to hook into some kind of stream of events. Whether these events are sign-in events or sign-out events, we're actually able to trigger something based on these changes. I'm going to dive a little deeper into that technical concept a little later, but for now, let's utilize it because I think it's the best way to actually understand something like that by using it in practice first. So the method that we want to get is onAuthStateChanged. This will return us back a listener. And in order for us to use it, again, we're going to create another helper function. And what I'm going to show you is that I want to call this onAuthStateChanged listener. I'm going to call it a listener because that's what it is. It's an observer listener. And again, for now, don't worry about what the observer means. I'll talk about it later. But what this observer does is it returns you back whatever you get back from onAuthStateChanged. In order for onAuthStateChanged to work, it takes two parameters. The first one, as you guessed it, is going to be our auth singleton. The second one, though, is going to be some callback that you want to call every time this auth state changes. So because we're defining it as our own method, I'm going to pass this method directly in like so. So essentially, I'm just saying, whenever you instantiate this function, you have to give me a callback because this callback is what I'm going to give to onAuthStateChanged. So let's copy our onAuthStateChanged listener. And in fact, we can even be more explicit by saying, if you don't give me a callback, I'm not even going to work. But for now, let's not worry about that. Let's just see what it does. Let's go one step at a time. So I'm going to take this onAuthStateChanged listener, and I'm going to go into our user context. The reason why I want to do this in user context is because the majority of the code that has to do with fetching and keeping track of what the user value is should probably be kept in the place where we're also storing it. So here, in order to utilize it, I want to mount it on component mount. So I'm going to use useEffect, and I'm going to use this pattern we've already seen, where I'm going to instantiate some function, but give it an empty dependency array. Meaning that I only want to run this function once when the component mounts. And what I'm going to run is going to be this new method that we got from our Firebase utils. So let's talk a little bit about this onAuthStateChanged listener. OnAuthStateChanged listener, as we know, receives some kind of callback function. What it does is it passes this callback function as the second value of onAuthStateChanged. What onAuthStateChanged does, as I mentioned, is that it will call this callback whenever the authentication state of our auth singleton changes. So when a user signs in, that's considered an auth change, because the user has authenticated. When a user signs out, that's another change. So both times our callback is going to get invoked whenever a user authenticates in and whenever an authenticates out, so sign out. This, though, is an open listener. This means that the moment you set it, this thing is always waiting to see whether or not auth states are changing. And the moment it does, it will run a callback. So this thing is a permanently open listener. You can imagine this as if somebody is standing there and trying to listen for changes to this auth state. And then whenever it does, it will run this function. The problem with this is that you actually need to get rid of it, i.e. tell it to stop listening whenever this component unmounts. Because if you don't, then this is something of a memory leak. Because if this component unmounts, we don't need this listener anymore. So this method actually gives us a handy way to do so. It returns us back a function that will unsubscribe, i.e. stop listening. So the reason why we get it back from our function is because, as you can imagine, we are really just returning back from our function whatever we get back from on-off state change. And this is really the function that gives us back that unsubscribe function. So here we just say, hey, give me the unsubscribe. And as we know with useEffect, with this callback, it will run whatever you return from this callback when it unmounts. So we want to say, hey, unsubscribe whenever you unmount. And here what I'm saying is that, okay, what I want to do is for now, I just want to see what am I even getting back. So I'm just going to console log user. So what's going to happen is when our application initializes, we're going to mount our user provider. Our user provider is going to instantiate this first callback on mount. And what it's going to do is it's going to call on state change listener. It's going to give it this callback, and this callback is just saying, hey, whenever the auth state changes, I want you to log the user for me. But going back to our application, you might actually notice something interesting. Right now, our application state seems to say that we're signed out. But let's refresh. When I refresh, what do I see right here in that user context? Our callback is actually telling us, hey, you do have a user actually. And the reason why this is happening is because the authentication singleton that we have from our Firebase utils, the one that we've been using all this time that we instantiated from this getAuth. This object, it turns out, is actually keeping track of whether or not the user has signed in or signed out using the different sign in and sign out methods that we have been calling. And it actually persists this between refreshes. So that's why inside of our application, despite the fact that I refreshed, I didn't actually sign in or sign up. And yet somehow Firebase knows that my user is still authenticated in. This is because Firebase is actually listening to our current connection to this instance of Crwn-Clothing, where earlier I must have signed in somehow. The only way that we can actually change this is if I manually sign out. So that's what I'm going to do. I'm just going to also import this sign out call, and I'm just going to call it because right now I'm currently signed into my user. So what I want to do is just the moment that this user provider mounts, I just want you to sign out. I'm just saying sign out no matter what. So here what happens, you'll notice that we sign out first, but you see these null calls. This null call is actually, again, our callback getting fired because an auth state change has happened. And in our particular case, what we did was we signed out our user. So here, now if I get rid of this sign out user, technically our auth singleton is not keeping track of a signed in user now. And this makes sense because we just signed them out. So if I refresh, look at that. There I see, null. This means that no user is signed in. So this is another great thing. The moment that this listener mounts, it will check the authentication state automatically when you initialize the listener. So the moment you initialize the listener, you will run this callback once. Any future runs of this callback is going to be tied directly to the actual auth state changing. So again, how does the auth state change? Well, we can log in with our user. If I log in with my user here, I should see this auth state trigger. And in order to prove it to you, I'm going to remove the places that may cause it actually to console log. So here what I'm going to do is I'm actually going to get rid of this set current user in sign in with Google. Because essentially what I'm going to show you is a pattern that allows us to do this more easily. So I'm going to save this. So right now, sign in, all it does is it calls our authentication method, sign in with email and password. So here, watch what happens. I click sign in. Notice that my context and my callback got called from my listener. The reason for this, of course, is because the listener is listening. The moment we successfully signed in, the listener is like, oh, I registered that a different user has signed in now. My auth state has changed. Therefore, I'm going to run our callback, which is just console logging this user instance. And now we have a centralized place for all of these changes. So what I'm going to do is I'm actually going to modify all of our code in order to now just allow this one place to keep track of these references. So join me in the next video where we will centralize this concept. Welcome back, everyone. In the last video, we learned about this new onAuth state change listener, which runs our callback whenever the auth state changes. So now what we want to do is we want to continue centralizing all the code related to authentication into just this one listener now. So in the last video, we modified our sign-in form so that our sign in with email and password no longer leverages that call to set current user. So here we can actually get rid of this set current user since we don't need it anymore. And similarly, we can also remove any imports that we're making to it inside of the sign-in form component. We know that in our sign up form, we do something similar. So we can also get rid of this because once again, when a user signs up, we are no longer leveraging our context here in order to actually make the update inside of the user context. So one nice advantage we get is that we have now stopped hooking into our user context from both the sign up form and the sign in form. So now whenever this context value updates, we don't need to rerun these functions needlessly. So automatically we get a little bit of a performance boost. Continuing on, we know that inside of our navigation, we are still also setting the user whenever a user signs out. So we actually don't need to do this anymore because again, the moment a user signs out, our auth state change listener is going to catch it. So all we really need is just to call sign out user whenever this link is clicked. So we can actually get rid of this sign out handler as well as this setter function. We do still need the actual current user though, because based on this value, we determine if we show the sign out link or the sign in link. So here, what we're saying is that, hey, whenever you sign out, I essentially want to still show the sign in link and respectively the reverse. And we actually still continue to get this benefit as long as we know what we're getting from this user. So we know that the user that gets passed through is either going to be an authenticated user object or it's going to be null. We get null when the user signs out. So we know that for us, what we want to store inside user context is either going to be null or it's going to be the user object. So essentially here inside of our use effect, we can just call our setter and set it to whatever that auth changed value is, because both these values will be the correct one for us. If a user signed out, we want to store null. If a user signed in, we want to store the object. So here, if we save this and we go back to our application, we'll see that right now our user is indeed signed in. So let me just also console log out the user just so that we can see and be very clear. So again, my map is going to reinitialize. We see that we have our user object because we're authenticated. And now if I sign out, I see that we get null. If I sign in again, we see that we have our user object and we see our navbar correctly reflects this change. So now we've pretty much centralized our sign out and sign in into this listener callback. Now we can actually take this isolation a step further. Inside of our sign in form, within our sign in with Google method, we are actually taking this user object that we get back from the authentication and we create a user document from this auth object. We can now move this into the user context. So I'm just going to cut this function and no longer need to destructure off the user. I'm going to go into my user context. And what I'm going to say is that I only want to create this user document if a user comes through. So here I want to say if user, then create user document from auth. So we want to import this from our Firebase utils. Otherwise, just set the current user. So this here is a method you might be wondering. Well, we're centralizing our auth, but maybe it's a user that's brand new when they sign in with Google, but maybe it's a user that already exists. Well, luckily for us, inside of our create user document auth object, we know that we get the snapshot, and the snapshot will dig into that place in the database given the UID we get from the auth, and it will determine whether or not, based on this object, if it exists or it doesn't exist. So if it doesn't exist, then we create a new instance in our database. If it does exist, then we skip this step altogether. Either way, we get back a valid user docref. So luckily for us, because of this pattern that we wrote, we actually now have this all working. So let's save this, go back to our application, and let's refresh. And now what I want to do is I want to first go into my CrownDB. I'm actually going to delete the user that I have from my Google sign-in, because here is actually the best way for me to prove that everything still works. So I'm going to delete that user. And inside of my authentication, I'm also going to delete this user. So that now when I go back to my application and I do my sign in with Google method, and here inside, I'm also going to use my user. We're going to go through that flow. We're going to authenticate my user. And what I should see, if I refresh this, is I see my user. And also, more importantly, inside of Firestore, I see the user that just got created right here for my Gmail sign-in. So as you can see, everything is still working. But luckily for us now, we have actually centralized the majority of the code that has to do with the authentication into one easy to track place inside of the context that is supposed to manage it in the first place. So this is a great thing that we've managed to do, because now anytime we need to think about authentication, most of the actual logic placement all lives within this user provider now. The only place where we kind of can't do that is with sign up. We still need to create the user doc from here. And the reason why we need this is because we need this display name. There are other ways that we can actually move this so that we can continue to leverage the actual listener for this as well. But this is one place where, you know what, it's not that bad for us to do. We need to leverage some fields sometimes from this actual sign up form itself that we need in order for our database to have the up-to-date value. So it's not the worst thing to do, but at the very least, the majority of our code is now centralized in the user context. So in the last few lessons, we've learned how to utilize this new context in order for us to store some data that our entire application needs to keep track of. In this particular case, it was the user. What we've also learned to leverage is this user context pattern in order to centralize code that's related to the user and authentication. So just by learning context, we've actually managed to find a good way to centralize and clean up our architecture of our React application. This user context governs the domain of everything related to users and authentication and the storage of those users. So now that we've done this, let's move on to the next video. Welcome back, everyone. In this video, I want to dive a little deeper into this observer pattern that we're now seeing from this on-auth state changed. So let's talk about it in the sense of thinking in streams. When you think about a stream, you can think about a sequence of asynchronous events, such as a click. When a user clicks onto a button or on the website, if you are listening for that click, you actually don't know when that user makes any of those clicks, because a user might click, they might wait 5 seconds and then click again. They might wait 1 second. They might make 1 hour. The concept of an asynchronous stream is just one where it's a sequence of most likely the same kind of event, but just with an indefinite amount of time between them. So here you can visualize it as if there is a start of a stream. So let's talk about this click stream. And then the user clicks. 3 seconds pass by, they click again. 10 minutes pass by, they click. And then suddenly, let's say they click 3 times in a row really quickly. Still subsequent clicks though, but just with very short intervals of time between it. And then maybe they click one more time after 30 seconds, and so on and so forth and so on and so forth. The idea with this stream is really just that it's a sequence of events, meaning that there is an order to them in time. As I mentioned before, the key thing here being that there is a variable amount of time between these events, and that is really the main thing about streams. The part of why this is interesting as a pattern is because we are able to react to each of these events inside of this stream. So you want to see this stream as a observable. There are libraries such as RxJS that essentially encapsulate this concept. But the main thing for you to focus on is that this is just some kind of asynchronous stream of events. The part where you interact with it is where you use a listener. And a listener is really just a class or some kind of object that has 3 key methods on it. The first is the next method. Next is called every time a new event in the stream happens. And what will happen is that that event will get passed to this next function. And then for us, we're really just saying, hey, here's a callback that is expecting to receive that event. And then what we do with it is up to our code. Next is really just pointing to our callback, which is really what that callback was when we passed to onAuth state changed. This is exactly the next callback. There is also a error callback. And this error callback just says, oh, do something whenever we throw an error. And then finally, there is a complete callback. So for streams might actually close, meaning that at some point we might say, hey, I know I'm done sending out events from this stream. So let me just tell everybody that there's no more events coming. If the stream is open, we can anticipate more stuff to come. If it's closed, it's most likely complete. So how this works is that we need to, in some way, subscribe from our listener to the stream. And this subscription is really just saying, hey, let me start listening to what happens in the stream. And you can listen at any point when the stream is going. Because remember, this stream is happening in time. So it's possible that maybe we are listening at the start of the stream, meaning no events have triggered yet. So in this case, what's going to happen? The first event fires, it goes to our next function. So our next function gets called. Similarly, the next one fires, we call the next function again. The next event fires, we call the next function again, and so on and so forth for the remainder of the upcoming events. The one thing to note here is that the moment that this stream, let's say it's done though, it will complete, which we will learn. So our listener will find that out from the stream because the stream will actually say, hey, I'm done. And the moment it says it's done, it's going to fire the complete method of every listener that's listening to this stream. So here, complete runs, and maybe based on whatever callback we have there, it will do something to clean up or whatever it needs to do in order to know that, oh, I'm done using this stream. But as I mentioned before, we might actually subscribe when a couple events have already happened. Let's imagine that in our stream, 2 events have already happened, maybe 30 seconds ago. By the time we subscribe, we will not get those 2 events because they're in the past. It's already over. What we can do now is just start listening for the new events. So when the 3rd event happens in the stream, then we'll catch it because we've subscribed already. And similarly, we'll call next. And then any future event that happens, we will also call next on and be aware of them. So this is one important thing to know about subscription models. The other thing is that similarly as before, when it completes, the complete callback gets called. So as far as this model is concerned, it's really just understanding the nuances of the timing of these streams. But generally speaking, the actual logic is very simple. You get some event, you fire next. Once it's done, once the stream is complete, you fire complete. Oftentimes we don't fire it either. This is just a pattern that emerges. So essentially, as long as you're subscribing with some object that has these three methods, next, error, and complete, and they all three point to different callbacks, the actual observer stream will be the one that actually will call these methods to whatever is subscribed to them. So imagine that we had a complete stream, for example. In this particular case, you might subscribe to an already completed stream. If that happens, you will not get any of these events because once again, all of these events have already done and the stream itself is already completed. So now, let's talk about this error method. How does this happen? In a stream of events, let's imagine one event has fired so far. We subscribe, and now we start listening for subsequent events after the first one. Remember, as I mentioned, that first event's fired, we have no knowledge of it. When we subscribe, let's say a new event happens, event 2. Again, we call next, and then we call next again. But then suddenly, let's say something breaks in the stream. For some reason, we get some kind of error. You can imagine with API calls, asynchronous events, there are chances that maybe there's a network delay, maybe there's a server error, something happens in this process. When that happens, we get informed by the stream that there is an error. Then our listener is in turn going to call the error method. So this is very similar to, you can think about it as if you have a promise. With a promise, when you get an error, it'll reject. This error callback that we have is pretty much the same thing. So this is what's really good about this stream model, because essentially now you're able to react consistently in this way from these streams. The last thing I want to mention is that a stream can have any number of listeners. Any number of different listeners can have different reactions to what happens in the stream, but each of them just need to subscribe to the stream. So whenever we were working with our on-auth state changed, all we were saying is that, hey, I want to start listening to on-auth state change the moment we invoked the function and we passed it the callback. Similarly, with that on-auth state change, we can also pass it an error callback and a complete callback as arguments 3 and 4. We're just really using the first two arguments, if you remember, inside of our code base. If you want to think about us opening up the listener with this method, the moment we call this method, we're saying, hey, create a listener for me using this callback. So what's happening here is that this on-auth state changed invocation is actually behind the scenes creating a listener for us. You can imagine it like that. And on here, it's going to take the next value and set it as our callback. We can actually call it with more parameters, as I was mentioning. Here you can see that in that list, we were looking at the auth, the next or observer, and this is the callback trigger on change, as I mentioned. There is an error param we can pass as number 3 and a completed callback as number 4. So here you can imagine that we could have passed an error callback if we wanted to, and then a completed callback. So this is pretty much just that same model. It's just that behind the scenes, this on-auth state change is just building out this actual listener model for us. So this is really all there is to know about this observer pattern. It's honestly rather simple once you wrap your mind around this concept of an asynchronous stream. But once you really just understand how it works, as far as you're concerned, all you know is that you need to give it a callback. And as I mentioned before, we need to also clean up this listener. So that's why it returns us back a unsubscribe. So essentially what happens is that on this unsubscribe method, it will clean up this actual method. And oftentimes with this unsubscribe, also it will call, if you were to pass it a complete callback, it will also call that, which is why when you hover over it, you see that the param completed, callback trigger when observer is removed. And that often also happens in the cleanup phase. Now that we've finished up with everything we need when it comes to isolating our authentication, what I want you to do before moving on is just commit your code, push it up, and then join me in the next video. I'll see you there. Welcome back, everyone. In this video, we are going to start working on actually bringing some products into our application and also being able to take those products and start adding them into our cart. We haven't built the cart, we haven't built the shop, we don't even have products. But throughout the next series of videos is where we will start tackling that with all of the information and knowledge that we've learned so far, and then flexing them so that we can actually start fleshing out and building some really useful and interesting features. To begin with, let's go back to our application. Here, before we begin with putting any products inside of our database, it's easier if we just mock this data inside of our actual code base directly. So what I'm actually going to do is I'm going to make a new file in the source folder called shopdata.json. And inside, what I want you to do is copy the shopdata.json file from your resources folder and paste it in here. It's really just an array that contains some hats, and it's a pretty simple structure. There's an ID, there's a name, there's an image URL, and then there's a price. These are really what we're going to use to populate out a baseline for our actual shop page. And then from there, we can start actually moving them and reconfiguring them. But what I want to do first is just build in the key functionality before we start worrying about anything more complicated. To begin with, what I'm going to do is first set up an actual shop page. So here inside of routes, I want to make a shop folder. And inside, I'm going to do shop.component.jsx. This shop component is going to replace the current shop temporary component that we've been using. So as far as the shop component goes, what is it really that it's going to be? Well, if you think about it, for now at the very least, I just want to list out all of the different products that are available. So I'm going to say const shop is equal to a functional component. And what I need to do is I need to import in the actual shop data. So I'm just going to directly import it first. I'm going to say import shop data like this, shop_data from, and then let's go up to our actual JSON file, like so. So good thing for us is that with React, it's automatically going to import the entire JSON file and then store it in this data. So here you'll see that it just gives us the array. Now, when I have this shop data, remember, we're just going to try and optimize later. I want to make a div, and inside of this div, for now, all I'm going to do is just say shopdata.map, give me the product, and all I want you to do is just return back a div with an h1, and inside of that h1, I just want to use the actual title value, or the name value, sorry. So let's do ID and name. Let's destructure this off of the product. So let's show the name. And the reason we want the ID, of course, is because we need to provide a key for our map. And then I'm going to export the shop as the default export. And then inside of our app.js, I am going to replace this const shop by importing in shop from the routes/shop/shop component. So now, as you can tell, it's the same name, so it's still rendering. We can save this. Let's go back to our application, and let's go to our shop route. And here we see that our data is rendering in. Awesome. So we have all of our data in here. Now what we want to do is we want to start thinking a little bit more about what it is that we want to do with this shop data. So when we think about an application, chances are the shop data is not going to be hard-coded into the application, but we're doing it for now just to make sure everything works. We're just mocking that data. Eventually, that shop data is probably going to live in our Firebase Firestore. So what we need to do is we need some way of being able to fetch those products down from our outside third-party API, and then we want to be able to access it in these different components that need them. Now, doesn't that sound a little familiar to us? This concept of storing this data somewhere. So what we can do is we can start setting up the actual storage using React context, rather than starting to actually set up the call for the data. Just as we did with the user context, we actually set up the actual storage first before we started actually setting up the separate call for that data. So we want to do the same thing. So my challenge to you is to actually build out a similar setup of context using the products. So you can call it product context or products plural context. And then just set it up and make sure that all you're doing is you're using useState in a similar way, but what you're setting is this default shop data. So try that out yourself, and then let's do it together in the next video. Welcome back, everyone. In the last video, I asked you about creating a new context in order to store all of our relevant data. In this video, we're going to do this together. So to start, let's go into our context folder and let's make a new file called products.context.jsx. When starting out with a context, remember, you always need to import the createContext method from React. Once we start actually fleshing this out, we'll start figuring out what else we need. We also need to import in those products. So we can call it products. You can actually call this whatever you want because it's really just a variable that you're setting. And we need to go and get it from the shopdata.json. Then what we're going to do is we are going to initialize our context. So let's not even think about what it is that will contain yet. Let's just build out the scaffold. So I'm going to say product context, which is equal to create context, and inside is just going to be an empty object for now. Finally, what we need to export is also a provider. Remember that for any context, we need both the context value as well as the provider itself. And the provider is going to be a component that returns product context.provider. And what do we pass inside? Well, we need the children, and then we need to render the children between our product context provider. So now that we have this, what we're missing is the value. And this is where we need to start filling it in. So what is it that we want to store? Well, we know that we want to store an array of products. So here, products, we can initialize as an empty array to signify what we want. Next, what we need is we also want some function that allows us to potentially set those products. But for now, we don't need it necessarily yet because we haven't really figured out where we're going to fetch and then set them in. We can always add this a little later. Inside of our actual component now, we can say const products and set products is what we need from useState. And in order to use state, we need to actually import this in from React as a hook. So we have useState, and for our default value, let's just pass it products, because for now, we're just importing them since they're hard-coded. Again, when we start fetching them from our database, we can update this code accordingly. Right now, we're just trying to get everything to work. And then what we're going to export out of the value is just the products as an object. So we can just pass this value in for value. And now let's just save this and bring this into the appropriate place, which is in our index.js. So let's take our products provider, go into index.js, and then import the provider, making sure to update our text with the correct route to the correct file. And then let's think about the actual order here. So we know we want to insert products provider and wrapper app. But what about the other provider, user provider? And what about browser router? Generally speaking, you want to think about whether or not whatever you're wrapping needs actual access to whatever it is that you're providing. So in our particular case with a products provider, does the browser router ever need our products? No, the browser router isn't even our library. So essentially, we know for sure we want to be inside the browser router. But what about user provider? Well, let's think about it like this. What is more useful? For the user provider to have access to the products provider, or for the products provider to have access to the user provider? Generally speaking, this really depends on your own code. It also depends on what it is that you're building and what features you need to build regarding this kind of separation. But if you think about it, chances are when you're fetching products, if you have an international application, you're probably going to be filtering down what products that user can access by geolocation. Now, whether or not that geolocation handling to deliver certain products to a user requesting them is done on the front end or the back end, well, that kind of varies depending on your project's architecture, and this varies from company to company anyways. But this is just more so to give you an idea or an example of why the order might matter. So for us, if we take that example, well, we know that the products should be able to then access the user. So if that's the case, then we would want to wrap the user provider around the products provider. So then this way, the products are able to reach up into the user provider and get the value. Whereas the user provider can't necessarily go into its children in order to fetch that data. So that's something to remember. So now that we have our products provider set up, let's actually start using it in order to access what we need. So I want to copy over product context, and I want to go back to my shop component. And now instead of relying on the shop data like so, I want to replace my code so that I'm able to use the context that we've just created. So here, what I want to do is I want to import in use context. And then what I'm going to do is I'm going to import in the context as well. So I want to import in products context. And then we're just going to say, give me the products from use context, passing in the products context. So one quick thing is that my product context, I want to make this plural, products context. So let me just make that change. And then let me go back here and update it similarly. And then finally, if we just replace products like so, now this should continue working as we had it before. So I'm going to save this, go back to my application, and there we go. We see that our products are still present. So next, what we're going to do is we want to start styling out our products. So what I'm going to do is I'm going to create a product card in order to actually style this more appropriately. And that's what we'll do in the next video. So join me in the next video where we'll take a swing at that. Welcome back, everyone. So in this video, we want to actually start styling out our products. So what I'm going to do is I'm going to go into my components and I'm going to create a new folder called product card. So inside a product card, we need to create the usual files. We need to make a product card.component.jsx, and we also need to make a product card styles. So product card.styles.sass. Inside of our product card component, what do we need? Well, first we need to import in that style sheet that we've created. So let's do that. And as far as the product card itself is concerned, let's think about what we need to do. So we know that we need a product card component, which is just going to be a functional component for now. Then I'm just going to export out by default the product card. So as we normally do, we're just scaffolding out this component. Now, what we want to do is just take a quick look at the actual finished product. We have some kind of container. We have this button inside, so we're going to need the button component. Then we have the name, we have the price, and we have an image. So let's start building that out here. First, I'm going to make a div that's going to contain all of these elements that I'm talking about. So that top level parent HTML component. And I'm going to say that this is the product card container. It's going to contain all of our product card stuff. Then inside is going to be an image. And this image is going to need a source, which we'll figure out later. Inside at the bottom there, we have some kind of footer. So I'm going to call this div the footer, and I'm going to give it the class name of footer. Then inside, we're going to need to list both the name as well as the cost. So for the span, I'm going to call this the name. And then I'm also going to create a duplicate where the class name is going to be the cost or the price, whichever one sounds more intuitive to you. I'm going to use price. After this, we need to use our button. So let's import in our button component. So I want to say, I want to import the button from the button folder. And then I'm just going to apply this button. So this button now If we remember, this button is white first, then black, unlike our typical button, which is black to white. So this is the invert. So I'm going to say that the button type is equal to the string inverted. And as for the content inside, it's just going to say add to cart. And I'm going to save this. And this is pretty much it. Now, what do we need to do? We need to actually fill in these remaining values. What is the image? What is the name? What is the price? So here, what I'm going to do is I'm going to assume that for this product card, you have to pass us the product. And product in this case is going to be the actual product data that we had. So we called it shop data right here. So we know we have ID, name, image, URL, and price. So we want to assume those are the same values we're going to get inside of our product card. So here, what I'm going to do is once I get the product, I want to destructure off what I need. So I know that I need the name, I need the price, and I need the image URL. And this we're going to destructure off of our product object. Then inside of name, I'm going to call the name. Inside of price, I'm going to call the price. As for the image, I'm just going to set the source equal to the image URL. Images also need an alt text, and this alt text is primarily for screen readers. So what we can do is for the screen reader value, we can just describe what this object is. So we can say that this is the name, because our names for our products are generally pretty descriptive. And that's it. We're going to save this, and now we want to use our product card inside of the shop component. So here I'm going to import in product card from the appropriate file. So we need to go up through our pages, into our components folder, into our product card, and then get the product card component. And then what we'll do is we will replace this entire div with the product card. And we're going to say the key is still the ID, but now we need the whole product. So actually we can't even do this. We just want the entire product because that's what our component is expecting. So I'm going to say product ID instead of just the ID destructured. And then I'm going to pass down the product as a whole into this product card. So now if we save this and we come to our application, what do we see if we refresh? Well, actually it looks like we have an error. So let's debug what this error is. Here we see that product card, nothing was returned from render. So this means that inside of our product card, we're not actually returning the correct thing. So this is my mistake. Inside of this component, we need to make sure to return back this value. So now if we come back and let's refresh, here we see that we have our product cards. So this is pretty much in. It's just that we don't have our styling set up. So as you guessed it, inside of product card.styles, I want you to paste in the product card styles file that I provided for you in your resources folder. Now, once you've pasted this in, if you look inside, what you'll see is that we have some really big cards. Now, the reason these are big is because it's adaptable based on the environment that uses them. So where is it that we use our product cards? Well, we're actually using them inside of our shop component. So inside of our shop component, our products are contained in a div, and this div is going to be what actually determines their styling. So let me just show you. I'm going to give a class name to this div, which is products container. And then what we're going to do is create a shop.styles.sass file. And let's make sure to import that styles file so we don't forget about it. And then what we'll do is we'll target this products container that we just created. I'm going to use display grid here because I want to show these in a grid format. I want the columns to be in 4 equal sizes. So here you'll see that repeat for 1FR just means repeat 4 times 1FR. 1FR just means one evenly distributed and equidistant size. So if you have 100 pixels and you have 4 of 1FR, then that means that you're dividing that 100 by 4, giving you 25. So this means that we're saying that it's equal. And then I want gaps between. So the column gap, I want it to be 10 pixels. So this is the gap between the columns. And then the row gap, I want as 50 pixels. So now if I save this and I come back, here we see we have our component. That's it. A lot of this was just some pre-styling, but again, I don't want to waste too much time on styling. There's a lot of little details with styling that takes up a lot of time that is not worth it when it comes to learning React. But in case you are curious about learning some of how CSS Grid works, I'm going to include a link to general documents around CSS Grid that is really helpful. The best way to learn CSS Grid is really just to tinker around with it. And I've given you kind of an environment so you can tweak some of these values, try out some of these values from the docs, and just see what the differences lie. So now that we have our product cards, what we want to do next is actually start seeing if we can add this to our cart. So that's what we're going to do in the next video. Welcome back, everyone. In this video, we are going to learn how to leverage our products that we've inserted into our shop page in order to build out our cart. Our cart is primarily comprised of two things. We have our cart icon with a number inside that tells us the quantity, and we also have the cart dropdown, which contains different items inside of it. As we add items, we'll notice that the numbers will increase, as well as the total quantity if we add the same item. In order to build this, we need to take this product and actually transform it potentially into a format that this cart is able to take so that it can accurately account for the quantity. There's numerous ways to do that, but we'll talk about it in a little bit later. First, let's just initialize and set up our cart icon, and we can start with building out the dropdown as well. So inside of your project, I want you to go to your assets folder and add in the shopping bag SVG icon that I've included for you in your resources folder. So here you'll see what the SVG looks like. So what we want to do now is actually create a new cart icon component that is going to contain both the count of the cart items as well as the SVG itself. So let's make a new folder called cart icon, and let's add the relevant files. We need a cart icon.styles.sass, and we need a cart icon.component.jsx. Inside of the cart icon component, we need to import in our styles file, of course, and then we need to initialize the cart icon functional component, and then we just need to export default this cart icon. Next, what we also need is we need to import in the SVG. So as we did with our logo, we say React component as, and then whatever we want to call it. I'm going to call it shopping icon, and we want to import it directly from the file location. Once I have this shopping icon, now let's think about what our cart icon itself should return. We want to return back a div that contains both the SVG of the shopping icon and also a span that holds the actual number, which is the count of items we have so far. So let's initialize it as 10 for now. And what we also want to do is we want to make sure that the styling of this works so that the number overlaps with the shopping icon. In order to do that, we need to provide some class names that make these elements targetable by our CSS. So here I'm going to call this the cart icon container. I'm going to call this shopping icon with the class name of shopping icon. And as for the span, let's call it with a class name of item count. So now let's save this. And then inside of cart icon styles, I want you to paste in the icon styles file that I've also included in your resources folder. Now, once you've pasted this in, what we're going to do is we're going to add this into our navigation component. So here inside of navigation bar, what we want to do is we want to import in our new cart icon component. So let's just figure out where this could go. Let's say before the context. Let's import in the cart icon from our correct placement. Go up to the components folder. Inside of components, we'll go to cart icon and then cart icon component. So as far as the cart icon itself is concerned, we want to place this inside of the actual options container because it sits right beside all of the options that we have. So here, this is actually one of those cases where you kind of want to think about the structure of what you have. We can place it right after our last sign-in link, like so. And then if we save this, we go to our application. What do we see when we refresh? There we go. There is our icon. So right now there's no interaction with it, but it's placed in the right place. One other thing that is different in our application and the final output is that there is this additional padding around the entire application. So let's also add that in. To do that, what we're going to do is go into our top level style sheet, which is our index.sass. And then inside of body, I'm going to add padding 20 pixels, 40 pixels. So what this is saying is I want 20 pixels on the top and the bottom, and I want 40 pixels on the left and the right side. So now, there we go. We get a little bit of padding, so it looks a little bit better. After this, what we need now is to actually build the dropdown. So similarly, what I want to do is I want to go into my components and I want to create a new folder called cart dropdown. And inside of cart dropdown, I'm going to make both the relevant files, so the cart dropdown.styles.sass, as well as the cart dropdown.component.jsx. Inside, again, let's import our style sheet. Let's initialize the cart dropdown component, just the base scaffolding, and then let's export as default the cart dropdown. As for what we want to return, for now, let's just create this div. And inside of this cart dropdown, really all we need is, before we think about what's actually inside, let's just do a basic div. And let's give it a class name of cart dropdown container. We'll have some area here where we'll just make a temporary div just so that we hold a place. And let's just say that what this will contain is our cart items, for example. And then after that, we want a button that will allow the user to go to the checkout page, which is what we have inside of our final application. So we're just recreating this structure here. So this means that we need to import in the button component. So let's import in button from button.component. And here, we'll just place the button. And inside, we'll just say go to checkout, like so. So let's save this. And now inside, as you guessed it, with cart dropdown.styles, I've also included your final third style sheet for this video in your resources folder. So just take the cart dropdown style sheet, paste it in. Now, once we've pasted this in, what we need to do now is we need to move this into the correct place so that when we actually interact with it, we can see it. So the place that this needs to go is also into the navigation component, because it's essentially going to live relative to the navigation bar. So here, I'm also going to import in our cart dropdown from the components, and then the cart dropdown component. And where I want to place this is I want to place this outside of this actual options container. So all of these nav links, these are not important to me, but I still want this to be within the actual navigation. So here, I'm just going to add it right after. And now if I save this, and I go back to the application, if I refresh, we should see it appear right here. So that's good. This is what we're looking for. So we want to now add the functionality where we can toggle the actual showing of this cart. This is where I want you to make yet another context, because that context is going to contain the information regarding the items into the cart, as well as whether or not it's open or not. So that is another challenge I want to issue to you. I want you to create some way for us to be able to store the state of whether or not this cart drawer dropdown is open or not. And I want you to trigger it on click. So give that a try. Figure out how to create that context using the knowledge that we have so far, and then bind the ability to turn it on and off or hide and show this using that logic. So do that, and then join me in the next video where we'll do it together. Welcome back, everyone. In the last video, I challenged you to find a way to hide this cart dropdown based on clicking the cart icon. The way we're going to do it is using another context. And here we're going to go into contexts and make a new file, cart.context.jsx. Inside, we need to import the create context as well as use state, because we know we need to store some kind of true-false state of whether or not the cart is open or not. As for the actual cart context, let's create a create context. And inside, we want to make isCartOpen as the name. So by default, this will be false. And then, of course, we'll do a set isCartOpen, which is going to point to a function. Then what we want to do is we want to create the provider. So I'll say cart provider is equal to this function that we know will take the children, because we've already done this pattern a couple times now. And what we're returning is the cart context.provider. And then inside, we render the children. So here, what we have next is the actual use state. So we'll say isCartOpen and set isCartOpen is equal to calling useState of false. As for the value, we'll set this to isCartOpen and the set isCartOpen setter function that we get from useState, and we pass this in as the value. So now we've got our provider. What we need to do is we need to wrap our application. So let's go to index.js and let's import in the correct provider. So let's think about our cart context. Where most likely should our cart context live? Is there a chance that our cart context is going to need the user and the products? There is a very likely chance that we might use the user in order to query a database for a user's cart if we want to persist it in a third-party database. That way, if a user logs in and they have some cart session that they didn't finish with, we could pull it from that. So combine that with the fact that maybe the products we want to be able to access somehow in the cart provider. We're not certain yet how, but it's a very high possibility because they're probably going to share some details between these products. It's most likely that we want to put the cart provider inside of the products provider and the user provider, but still wrapping the app. So here, now that we have our cart provider and we have the methods on our cart context, we want to start using them inside the navigation component. So we already have our use context. Let's just also bring in the cart context. And here, let's just make sure to update the relative path. And now let's bring in from the context is cart open. Whoop, not the cart provider, sorry, the cart context. And we'll say is cart open. So let's copy that down. And what we want to do is we want to conditionally render the cart dropdown based on the truthiness of this value. So here what we can do is we can wrap isCart dropdown with isCart open and use this, what's known as the short circuit operator. So double ampersand, essentially what happens is, as you know, it tries to evaluate the truthiness of this statement. So in order for a double ampersand to evaluate as true, both the left side and the right side must both evaluate to a truthy value. Truthiness here with isCart open, of course, is true or false because it's a Boolean. But on this side, cart dropdown is going to be a component, meaning that it is a truthy value. Components are all truthy values because they are functions. So here, essentially what this short circuit operator says, that if this total thing evaluates to true, then what I'm going to return to you is going to be the last thing you gave me. So our cart dropdown. So what happens is that it's going to evaluate this statement, see that there's a cart dropdown, and if this total statement is true, meaning that is cart open to be true, return the cart dropdown. If this is false, then it won't return anything. This will just exit. So now we've added in the logic to conditionally show our cart. What we need to do now, though, is inside of the cart icon, we need to figure out the actual triggering of setting the value to truth and false. So let's go into our cart icon component and let's import in our use context hook. And we also need to import in the actual context itself. So I want to import in the cart context from, let's go up to our correct corresponding contexts folder and the cart context. And then what we're going to do is we are going to say that const set is cart open equal to use context and the cart context. But is this all we need? Well, let's think about it. Here inside of this icon, what we want to happen is when you click it, if the cart is not open, then open it. If it is open, then close it. So essentially what we want to do is we want to inverse this is cart open option. So here, what I actually want to do is I actually want to create a new function called toggle. I'm going to call it toggle is cart open. And what this function does is it calls the set is cart open method, but it sets it with the opposite value. So the inverse value of what currently is cart open is. And this is how you create what's known as a toggle. So here now we can add to our onClick our toggle is cart open. So if I save this now, and let's go back to our application, what do I see when I click this? There we go. We've added in this toggling ability and we can now hide and show the actual cart. So that's really good. We've got a lot of functionality in. It's looking a lot closer now to the final application. Now what we need to do is actually do the most challenging portion, which is building in the actual items that we need to add into this section. But before we start doing that, what we want to do is we want to commit our code. So let's go back to our terminal. And what we'll do is we'll git add all of our changes. We'll git commit and we'll say we're adding cart context and our shopping icon, as well as cart dropdown. So here, let's push this up. And now let's build in this cart item functionality. I'll see you in the next video. Welcome back, everyone. In this video, we are going to talk about adding our products into our cart. So let's take a look at the final format and think about the current data that we have. So inside, we know that we need to show the image, the name, the price, and then this quantity. So really, a cart item looks kind of like an encapsulation of our product data, except there is an additional quantity parameter. So how do we transform our data from this over into this accurately as we add more items into the cart? Well, that's actually going to be the meat of the logic we need to figure out. That whenever we add some item into our cart, we have to check if it already exists as a cart item, and if it does, then we increase the quantity. But if it doesn't, then we create a new cart item. So that's going to be the logic that we need to tackle. And really, we should do that before we start styling out the cart item. So let's figure that out. First, what I want to do is I want to make a new folder for the cart item, so at least we have something to work with. So here inside, I want to make the cart item.styles.sass. And maybe we don't fill it out, but we just make the file. And I also want to mark a cart item.component.jsx. So inside, let's think about what we need. For this cart item, we most likely will, let's just first generate the base of the actual file. We want to import in our style sheet. We want to create the actual cart item component. And then we want to export as default the cart item. So now that we're inside the cart item, let's just return for now a div that will hold out the actual total of the HTML. And then let's put an h2, which will have just the name so that we at least know what item we're looking at. And this name is going to come from, let's just say, the cart item that we pass in here. And then we destructure off the name so far. So all I'm saying is that I know that what I'm going to pass in is going to be some kind of version of the product that we already store, those product JSON objects. But here we need also some way to keep track of quantity. So this is where I'm just going to say that I'm going to assume that what gets passed in will also include the quantity. And I'm going to make a span that will show the quantity like so. So here, all I need to do now is actually put this into the cart itself, the cart dropdown, which is where this will live. So first, let's import in our cart item. And then what we're going to do is we are going to say, okay, how are we going to get these items into our cart dropdown? Well, let's think about this a little bit first. What is it exactly that we need to add? We need to map over some kind of array. We know that. And for every item that we map through, we want to pass this to the cart item, like so. So here, this array that we're mapping through is going to be kind of similar. But the only thing is that the way that we get this array, it's not completely like the products. It's going to be some variation of the products, as we mentioned, but with the quantity on it. So to do that, let's think about leveraging our cart context. Our cart context already stores things related to our cart. So what we could store is the actual cart items that are inside of our cart as they're added. So let's think about what the data shape of cart items should be. We know that right now we already have products. So our products essentially are objects that have the shape where there's an ID, there's a name, there's a price, and there's an image URL. All of these are same characteristics that we want on a cart item. The only difference is that we also want a quantity. So what we're going to store inside of this cart items array is pretty much something that looks like the product, except we also have an additional quantity. So let's actually start fleshing this out. What we want to do is we want to also figure out whenever you add something to this cart items, what are we going to do to it? Well, we know that in order for us to control the quantity, we probably don't want them to set directly this cart items array the way that we've been doing so with a separate setter function. Instead, maybe we want to define our own method that we happen to expose, something like an add item to cart, where we explicitly control what it is that this add item to cart function is going to do. So first, let me initialize the cart items and then the set cart items useState hook. And by default, we're going to use an empty array. What I'm also going to do is I'm going to now try and define this add item to cart method. This add item to cart method is going to be a function that triggers whenever a user clicks on this add to cart. So that means that what we're going to receive from the product card is going to be the product to add. So that's the key thing to remember. We're going to receive a product. Based off this product, we need to decide, okay, do I need to make a new cart item if this cart is empty of any of this product that they're trying to add? Or do I find the existing cart item for this product and then just increase the quantity by 1? That's the logic that we need to add into this. So what we can say is that we know that what we're going to set this cart items value to is the newest up-to-date array. So here, I'm going to create some kind of helper function that's going to help me find inside of my existing array any cart items that exist that match the ID of this product. And then if I can find it, I'm going to increment the quantity. Otherwise, I'm going to make a new cart item. So here, let me write out at least some pseudocode. So I want to say const add cart item, like this. What we're going to receive is the cart items array, because this is what we're going to look through to try and find a matching product. And of course, I'm also going to pass through the product to add, because that's essentially what they're trying to add through. So here, I need to do two things. The first is find if cart items contains product to add. That's the first step. Then what we do is if found, increment quantity. And then finally, return new array with modified cart items / new cart item. So that's kind of what we need to figure out for this function, because what we're going to do is that this add cart item is going to be what we set our new cart to. So we're going to call set cart items, calling add cart item, passing through what we have for cart items here, as well as this product to add. So my challenge to you is actually to try and see if you can figure out how to code this. Remember, what we should get back is a new array of cart items, except this product to add has either been added as a new cart item or as an existing cart item with an increased quantity. So I know it's kind of challenging, but really think about it and really try and figure out if you can do this. And in the next video, we'll do it together. Welcome back, everyone. In this video, let's improve upon this add cart item functionality that allows us to take in an array of cart items, which, as we discussed, is just a product with an additional quantity field, as well as some product object that we're trying to add into this cart items array. So as I mentioned, what we need to do is find the cart item to see if there is one that matches inside based on the product that we're trying to add. And if it exists, then we increase the quantity. Otherwise, we just return back an array with the modified cart items or a new cart item. So because we haven't really tinkered around with cart items, let's just imagine from the empty case. We have a completely empty cart. We're adding a product for the first time. What we want to end up with is a cart with the object that has all of the fields from our product to add, but also an additional quantity field that is equal to 1. Because what we're saying is that, hey, I'm essentially creating a new cart item, all of the same fields as product to add, except there's a quantity of 1 so far. So that's what we want to end up with. So let's talk about this. What we want to do is we want to say, okay, if this cart doesn't have an existing cart item with the same ID as product to add, then we know for sure it is a new product. But we want all the existing cart items as well that are in here. It just means that we have a new cart item to make. So what we'll do is we'll create a new array and we'll spread through all of the existing cart items that we have. But what we're going to add as an additional is we are going to say, okay, I know for sure I need a new product to add, except we're also going to add this quantity of 1. That's it. This is all we're saying. So whether or not cart items has anything in it or it has other stuff, we're already saying that by the time we make it to this line, we know for sure that all of these cart items don't match the product to add. So I want to make a new cart item, which is just all the fields of product to add, but with an additional quantity field of 1. So this handles the case where it's a new product. But what about finding an existing product? How do we do that? So here what I'm going to say is that const existing cart item is equal to us searching through the cart items array using the .find method, which is very similar to .map. What you do at .find is you pass it some callback, and in this callback, it receives each element inside of the array. So we're going to get each cart item. Then what happens is that we're expected to return a Boolean value. And if this Boolean value is true, then this method will exit, giving you back the cart item that returned the true Boolean based on the callback. So what we want to say is that only return us back true and return us back the cart item if this specific cart item has an ID value that's equal to the product to ads ID value. So here, that's how we're able to track whether or not the cart item matches one that we're trying to add, because they'll be the exact same product. The only thing is that we just add the additional quantity, but the ID values are going to be the same. So that's what we're going off of. Now, if this existing cart item has been found, then what we're going to do is we want to return from this method, meaning that we don't want to make it here. We want to modify the existing cart items, but we still want to return back a new array because we don't want to mutate our code. Remember, with our code, we don't do mutations. We always return a new array with new objects, or only a new object if the field is different, meaning the quantity is incremented. So then only then do we return a new item. Otherwise, we keep the old one. So here what we're going to say is that we return cart items.map. So we're mapping through the cart items. And what we're going to do is take the cart item and we're going to say, okay, in this particular case, again, we need to match. Does the cart item.id, is it equal to the product to ads ID? If it is, then what we do, so meaning that there's a match, is we want to return a new cart item object. So let's spread through all of the values on this cart item, except the quantity value is going to be the cart item quantity plus 1. If this is not the case, then just return back the original cart item. So let's walk through this logic because this part is a little bit convoluted. So we're saying, okay, let's say we found a match in our cart items. If we do, then we want to return a new array of cart items. And here we're just saying, hey, is this cart item the same one that we're trying to add? If it is, return a new cart item. This means that we're doing a brand new object, but we're spreading through all of the old properties of that cart item, except now the quantity, we're just adding 1 to that quantity. If this doesn't match, meaning that it's a cart item that is not related to our product to add, then just return the cart item. We don't really care to improve it. That is what this function does. So this function now will allow us to essentially add new products in and keep track of the quantity appropriately. And because we're calling it whenever we call this add item to cart method with the product that we're trying to add into our cart items, this will then give us back the appropriate array that we want to update for our cart items. And now I just want to add this to our value because that's what we want to expose in the context. And we're also going to expose cart items as well. So now with this in mind, we can go back to our cart dropdown and we can use this context. So I'm going to import in the use context hook from React. And I'm also going to import in the actual cart context. So I'm going to import cart context from cart context. And then what I'm going to do is I'm going to pull off this value now. So before we were just mapping over an empty array. Now we want to map over our cart context. So our cart items equals use context, passing in cart context. And here now, I want to map over cart items. I also want to make sure that we add the key. So item.id also is allowing React to properly map these key values. Now that we have our cart, what we need to do is make sure that we also are able to add these products. So let's go to our shop page. Not actually our shop page. We need to go into our product card component. Inside of product card, whenever we click this button is where we add that product to our cart. So let's once again import in use context from React. And we also need to import in the correct components. So here, let's import in our context, not component, but the actual cart context. There we go. So now that I have cart context, I want to use it. And the way to use it is we need to get the add item to cart method. So I'm going to say use context, passing in the cart context, add item to cart. And then whenever this button gets clicked, I'm going to call add item to cart as a function, except I'm passing the product through. So let's actually make this a function defined up inside of our function definition, like so. And I'm going to call this one add product to cart. And then I'm just going to pass this through here. Now you might be wondering, why do we define this function up here instead of inside of the definition? I'm going to explain this to you a little later when we start talking about optimizations. One benefit is readability. It's easy to look through this part rather than inside of all this nested JSX code. But the other is it's easier to optimize. And I'll talk about that again much later. But for now, let's test that everything here works. So let's go back to our application. Here, we seem to have everything hooked up. And let's start adding. There we see our blue beanie is being added. Our brown cowboy hat is being added. And our red beanie is being added. There we go. Everything is working as expected. So awesome. Our code is working as we want. And really the key thing here that was challenging was really thinking about a way to keep track and update this cart inside of our context. Because the really challenging thing is this function and thinking about this function, where we know that we want to manufacture a new array of cart items that are based off products. The only thing is that if an existing one is found for the product that we're trying to add in, then we just want to increase the quantity. Otherwise, we just want to keep it the same. This is the biggest challenging part and requires the most thought when it comes to composing this feature. So if this is challenging, I suggest you actually get rid of this code and try it again yourself. Because only by practicing and really thinking about how this is done are you going to get a better grasp of why this all works. So now that we have our cart and our cart items, let's start styling our cart items in the next video. Welcome back, everyone. So in this video, we are going to finish off our cart dropdown. A lot of the complexity of the actual cart maintenance has been achieved through our cart context. Now though, let's finish off the actual cart items. So as you can guess, I've already, of course, styled out the cart item for you. So what you need to do though, is you need to fill in with the appropriate HTML structure. So here, what we need to do is we need to think about what gets added into the cart. We know there's name, we know there's quantity, but we also know there's an image. And we also need to know what the quantity is multiplied by the price of the item. So at this top level, I'm just going to say that this div is of the class name cart item container. So this is our parent. Then inside, I'm going to have an image. And this image is going to be of the image URL coming from the cart item. So all of those fields that we had before, the name, the image URL, the price, the quantity, I want all of these. And the source is going to be the image URL. So this is very similar to our product card. And the alt text is also going to be the name. So here inside, I also now need a separate div that will contain all of our item details. So here, when you think about this structure, where inside you have this quantity, when you look at the actual component, notice that this image and this section are two separate sections, but these details are kind of grouped together. That's why I want to wrap these in another div. And this div I'm going to call the item details. And then inside, I'm going to have a span. And this span will show the name. And the class name for this will just be name. Similarly, this span is already written, which will be the price. and it will contain the quantity multiplied by dollar price. And this is it. This is the entire component. Now, inside of your cart item styles, just copy paste in the cart item style sheet that I've provided in your resources folder. Now, once you've saved this, now go into your application, and you should see that right here, we have everything that we wanted to see from what we had finally. So here, if I add more, there is another item. So our cart is looking pretty good. It's pretty much exactly what we have inside of our final application. There is one feature we are missing left, and that is the count inside of the cart icon. I want you to try and figure out, using all the things we learned, how to build in that count. So pause the video and try it out yourself. You're essentially accumulating all of the quantities, storing it somewhere inside of the cart context, and then utilizing it. So try it out yourself, and then when you're ready, unpause the video and let's do it together. So let's build into our application the count ability. So here, let's go into our cart context. Inside of our cart context, we already have all the cart items that has the quantity on them. What we want to be able to do is that whenever cart items changes, we want to be able to show a new cart count. So I'm going to make a new property called cart count that by default starts at 0. Then what I want to do is I want to make a new cart count and set cart count state using useState, which by default causes 0. Then what I want to do is I'm going to use the useEffect hook, because essentially what we're doing is we are recounting the total quantity every time the cart items changes. There's more ways to do this. This is just one particular way. You can also expose a function that will always reduce the cart items. But this way, I think, is just a way that we can think about using useEffect and highlight some of these changes that we can make like so. So remember, with useEffect, we pass it a callback, and this callback runs every time something in your dependency array changes. So for us, I want to change the cart items. Every time this cart items array changes in any way, we need to recalculate the cart count. So here I'm going to say new cart count is equal to cart items dot reduce. So I'm reducing over the cart items, and reduce is going to take 2 arguments. The first argument here is the callback. The second argument is the starting value. So what goes into the callback? The callback is going to be the current total, and then the second value is going to be the current cart item. So here, what happens is that essentially we are going to say, okay, I want to take the total and I want to add the cart item dot quantity. So now whenever these values accumulate as it traverses through the cart items, we'll finally end up with a new total, which we will then set as the new cart count. So I'm going to say set cart count equal to new cart count. And now I can just add this cart count to my values. And then inside of the cart icon component, I just need to pull it in. And instead of rendering 0, I just render cart count like so. And if we go back, now let's add some items. And there we see we are accurately now keeping track of our cart count. So as you can see, we pretty much now got everything that looks similar to our main Crwn-Clothing application. Now what I want to challenge you to do is I want you to be able to try and figure out how to build this go to checkout button that takes you to this checkout step. And then inside of here, there is all of these different checkout items. You don't necessarily have to build out this visual component, but what I challenge you to do is try and figure out how to increment the item from this arrow, decrement the item from this arrow, as well as remove an item entirely with that X button. This will really flex every single thing you've learned up until this point with the code. You don't have to do the styling. The main thing is figuring out the composition of the functions, the composition of the functionality, as well as how to build these additional features into your context and your components and link it all together. This is a great challenge, and also to comprise the total value as well. This entire page is actually a great way for you to figure out how to make all of these things that we've learned into one unique feature. So my challenge to you is to try that out. And before you proceed, I also want you to commit your code, because we've just added some new functionality. So I want you to git add and then leave a commit message that says what you did. So here we just added in our add to cart feature. And then push it up. And now try and build that checkout page. Once you're finished, come join me and we'll do it together in the next video. In this video, we are going to build out our checkout page. So here, to set up a checkout page, let's look at what we need. We know that we need a new route that will point to a checkout component. And then inside of this component, we need access to our cart items. So we need to connect this checkout page and our cart context. Then we need to display the items inside of our cart, and we want to be able to modify their quantities. We also want to be able to remove these items and, in course, also reflect an accurate total. So let's build out this connection and the components and then start thinking about how to create the actual functionality. So back inside of our application, I am going to build a new folder in the routes, and I'm going to call this checkout. As for the checkout component itself, I'm going to make the checkout.styles.sass. And also, I want to make checkout.component.jsx. Here, as we do before, we want to import in our styles page. So let's bring that in. Declare checkout is equal to a functional component that for now just returns a div. And inside of that div, I just want to make an H1 that says I am the checkout page. I'm going to export this by default. And then what I'm going to do is go back into our app.js, import in the appropriate file, and then I'm going to create a new route for checkout, and like so. And then, of course, we need to make some kind of connection between what we have to this page. And as we know, inside of our cart dropdown, we have this button that takes us to the checkout. So how do we circumvent this button so that when you click the button, it navigates us to the checkout route? Well, there's actually a hook that we get from React Router DOM. And this one is called use navigate from React Router DOM. Use navigate is a hook that allows us to get a navigate function. Like so. When you call it, this navigate function will allow us to actually go to checkout. So here, if I say const go to checkout handler, this is just a function that calls navigate to /checkout, like so. And now, if I just attach this to the onClick, like so, and then we go back to our application, and now if we open our cart and we click go to checkout, we see our checkout page. So now what I want to do is I want to get these cart items into my checkout page. So how do we do that? So in order for us to list out our cart items, let's think about what we need to do inside of our checkout component. The first thing is we probably want to import in the cart context as well as the use context hook so that we can access the values. So I'm going to first import in use context from React, and then I want to import in the cart context. So let's go up again to our context, cart context. And then I'm going to destructure off cart items, which is equal to use context passing in cart context. As for the cart items, let's just make a div that will contain them, and we will just map through them. And we get the cart item. And for the cart item, let's just return an h2 that has the cart item name. Actually, no, let's display the quantity as well, because that's what we need to be modifying. So let's be more explicit. Let's return back a div, and inside of the div will contain the h2 that contains both the name as well as the actual quantity. So we need to destructure these values off from the cart item. So let's do const ID, name, and quantity from our cart item. And then for the div, we need to give the key of the ID. So just a very simple, basic HTML structure that will show us that we are indeed getting the correct cart item. Now back inside of our application, we see that we have our cart items. We have our title, we have our quantity, and now what we need to do is figure out if we can create some functionality that will allow us to set the left and right values. So what I'm going to do is I'm going to first come back into our cart dropdown and into our checkout component. From our checkout component, I want to just create some left button, and let's just call it something obvious, like decrement. And let's also add another one called increment. So what I want to do is when I click increment, I want to actually increase the quantity. So how do we do this? Well, what we know is that we have the cart item currently. With the cart item, I want to be able to increase the quantity of this cart item. Otherwise, I want to decrease it. So as we know, we already have that functionality built in, which is our add item to cart. This add item to cart, though, the way that it works is that it looks inside and it takes a product to add. But what are we doing with this product to add? We check to see if this ID matches the cart item ID. If it does, then we just increase the quantity on that cart item. Otherwise, we spread it through. But the thing to keep in mind is that we will never reach this part of the code because we are always going to make sure that this existing cart exists. Of course it does, because it's already in the cart item. It's cyclical. So for this reason, all we need to do then is just take our add item to cart and just attach it as an on-click here, like so. And then what we pass to this add item to cart is just our cart item. If we save this, and now we come back, we see that it's a little bit unclear. Let me just add this in a way where we can see it from each other. I'm just going to add a break element, which will give us some space between the different spans. And now if I click increment, there we go. We see it increasing. Exactly as it should. So now what we have to do is do the decrement. So my challenge to you, if you haven't already tried it out, is figure out how to create this decrement counter. It's going to be similar to increment, but a couple things you want to consider is that when you decrement, you want to decrease this number. And if you hit 0, you want to remove the item from the cart. So try that out and let's do it together. Welcome back, everyone. In this video, we are trying to build in the decrement. So for decrement, let's go into our cart context. As we know, if this is where we did our add item, we're probably going to do a similar remove item here as well. So what I want to do is I want to make another method called remove item from cart. And this is going to be a function that we need to figure out. So remove item from cart is probably going to be very similar to how we set up our add item to cart. So here, let's just duplicate our method, call it remove item to cart. And what we're going to receive is the product to remove. We know that we're most likely going to want to get this product because with this product, will we actually delete the cart item? So here, instead of even calling a product to remove, we know that most likely it's going to be a cart item in the first place. So we can even be more explicit. Instead of calling a product to remove, we could call it cart item to remove. So now what we need to do is we know we are updating our cart items, but instead of calling this add cart item method, we probably want to create another helper. So let's think about what we want this to do. So I'm going to call it remove cart item, like so. We know that we want to get the original cart items array because we're going to use this array to create a new array where we've either increased the quantity of one of these cart items or we've removed an item entirely if the previous quantity was at 1. The next thing that we know we need is the cart item to remove. And now what we need beyond this is, let's think about the functionality. Inside of our cart items, we know that we're removing a cart item that already exists. So we need to find the cart item to remove. We need to find the one that already exists inside of our array. And then what we need to do is we need to check if quantity is equal to 1. If it is, remove that item from the cart. That much is the logic that we've described. If it isn't, then what we do is return back cart items with matching cart item with reduced quantity. That much also makes sense. So let's figure out what we need to do here. Well, first we need to find the existing cart item. So what we can do is we can actually take this method over that does exactly this, except instead of using the product to add, we're going to use our new cart item to remove. They're both going to be the same shape and have the same ID. Next, what we need to do is we need to now check if the quantity of this item is equal to 1. Now, if it is equal to 1, then what we need to do is we need to remove this from a new set of cart items. So to do that, let's use the filter method. As we know, filter gives us back a new array where the array is going to have removed whatever matches. So here I'm going to say that if existing cart item dot quantity is equal to 1, then just return back cart items dot filter. And what we're going to do is get a cart item and just say if the cart item dot ID does not equal cart item to remove dot ID. So if this seems a little bit unintuitive, the reason why is because we're saying, hey, I want you to filter out anything here that equals false. So what this means is that if this statement evaluates true, then keep the value. So we're saying if the cart item ID does not equal the one we're trying to remove, keep the value. That makes perfect sense. We only want to remove the value where the cart item ID is equal to the one we try to remove. So that's how filter kind of works in reverse here, or at least it seems a little unintuitive the way that we've written it. But now, once we have removed out when quantity is 1, then all that's left to do is pretty much just duplicate what we had here. And all we can do is really just copy this over. And all we need to do differently is instead of incrementing quantity, we decrement the quantity. And of course, we use cart item to remove instead of product to add. So if you look at it, we're just mapping through all of our cart items and we're saying, hey, if your ID matches the one we're trying to remove, give us a new object with the same cart item properties, except the quantity has been reduced by 1. Some of you might be wondering, why is it that we're always creating a new object? Remember that with React, the only way that a React component, which in our case is going to be either this new checkout item that we haven't made, or even the cart items that we have made, what do they receive? They receive an individual cart item as the actual prop value that they have. Let's look at it. Let's look at this component. We receive a cart item as the object, and off this object do we render the UI. If we get back the same object with the value mutated, React doesn't register that this cart item is different, so it's not going to re-render the component. Whereas because we are generating a new object, when React receives that object, React is going to say, oh, this prop is different. Then I can re-render the UI and in turn reflect the new reduced quantity or the new increased quantity. This all has to do with React's rendering. So now all we need to do is, again, just replace our method here inside of remove item to cart, and then pass this through as an argument. We can now include this inside of our appropriate checkout component. And let's just also abstract this off. And then we can simply add an onClick here where we call our remove item with the cart item. Let's save this. Let's come back here. And because we've re-rendered, we need to re-add items to our cart. Let's come back. Let's go to the checkout. Let's make sure it works. We decrement. Look, it's working. We also see it reflected inside of our cart because everything is tied together. And now if I decrement one more time, I remove the item entirely. I continue decrementing. I've removed all the items. There we go. We've added in our functionality. So now what I want to do is I want to style out this component so that it looks closer to our actual final checkout page. So how do we do this? Well, let's figure this out in the next video. Welcome back, everyone. In this video, we want to create the actual checkout component and the checkout items inside. So when talking about our checkout component, let's take a look at what the final component should look like. Really what we're doing is we're creating some specific kind of row that will show what the value of each column of these checkout items will be. So coming back here, let's start setting that up. We know we have our top level div, and following typical fashion of these top level containers, we're going to call this our checkout container. Inside, we know we need a div that will hold the header itself. So the header being those different values that we are adding at the row level. So I want to call this our class name of checkout header. Inside of this header, I want to have these different divs that represent the different blocks. So if you think about these are kind of like each of these individual duplicated sections. I'm going to call these, let's say something like header block. It's pretty clear what these are. And then what I'm going to do is I'm going to duplicate this 5 times because we have 5 different blocks. 1, 2, 3, 4, 5. Now inside of the first one, we need a span that will say product. Then what we need for each subsequent one is going to be what they are. We have a description. We have, well, let's put description first. So we have description, and then the next one, we have quantity. And then after that, we have our price. And then finally, we have remove for our X button, which we haven't made yet. So here, I'm going to get rid of all this other stuff. And underneath what we're doing is really we are showing the different items. So I can either put this in a div, or I'm actually just going to get rid of this div now. I don't need it anymore. And what I also want to do is display a total. So here I'm just going to put a span, and inside of the span, I'm just going to say total is equal to 0 for now. We'll figure out how to add the total later. And I'm going to give this a class name of total. So what we need to do now is really just add in the style sheet that will allow this code to work. So once again, inside of checkout styles, just paste in your style sheet from your resources folder. And now once we've pasted this in, let's go back to our application and let's see how we're looking. So far, we've got our header. Of course, our total isn't in the right place, but we'll figure this out later. So the next thing that we need to do is we need to set up the actual checkout items. So really the checkout items are what's going to replace this temporary item that we've created here. So let's go back into our components and let's make a new checkout item. Whoops, I misspelled that. Checkout item. And then let's set up our files. Checkout item.styles.scss and then checkout item.component.jsx. Now for the actual checkout item, what we need to do is we need to import in our style sheet. And then, of course, finish scaffolding out our checkout item component. And then export default checkout item. Now, inside, what do we know we get for the checkout item? What we're going to get is essentially a cart item. And off the cart item, we need all of the fields. So let's destructure off the name, the image URL, the price, and the quantity. And then what we're going to do is return back a div that will contain all of these appropriate values. So I want to give this class name of checkout item container, and then a div that will contain the image. So here I'm going to make another class name, image container, because I want to declare the boundaries of what this image is going to have. And here I'm going to say source goes to the image URL. And then the alt text, as we've done so far, is just going to be the name. And then after this, I want to make a couple spans. So I'm going to make 3 spans here. And then I'm going to also make a div, because in the div is where I want to put the remove button. Now, for your remove button, you want to use a special character. And this character can actually be signified in HTML as ampersand hashtag 1005 semicolon. This in turn will now create for us that X button, but in a specific type of format and in quite a large size. As for these remaining spans, I want to make class name of name, class name of quantity. Here, this will be a class name of price. And then we need to respectively insert in the correct values. So here I'm going to put a name, I'm going to put the quantity, and then I'm going to put the price. And then it's just a matter of bringing this into our checkout component and replacing all of this once we import it in. Checkout item component. And then let's render our item, where the key is going to be our cart item.id, and cart item is going to be cart item. And then we don't need this destructuring anymore. And as a result, we can just explicitly one-line return these values. Now the last thing that we also need is the checkout item styles. So go into your resources folder, grab the style sheet, and then paste it in here as well. Now, once you've pasted this in, let's come back to our application. And here we go. We see that we have our components. Although this icon looks like to be incorrect. So let's actually take a double check into what that checkout item component has. It has ampersand hashtag 10005. I was missing an extra 0. And now if we come back here, there we go. This now looks correct. So our total is also looking a little weird here. So let's go into our checkout component And here we see the class name has a capital T. That's another mistake of mine. And now, there we go, accurate total. So now what we need to do is we need to attach the quantity arrows as well as build out this remove button. So the quantity button, that one is pretty easy. We can do that in the next video. But before you move on, I want to challenge you now to try and build out this remove feature. When you hit this, this should in turn remove this item from the cart. So this should be pretty intuitive because we've kind of done it already when we talked about our quantity equals 1 condition for our remove item from cart. So try and think about that and build that feature to remove the cart item. And then I'll see you in the next video. Welcome back, everyone. So let's build out our final actually clearing out the item from this cart. So to do that, what we're going to do is go into our cart context.js. And inside of here, I am going to add yet another function called clear item from cart. And this is going to be a function that is just going to be very similar to our remove item from cart. And here I'm going to call it clear item from cart. Of course, it's going to be including the cart item to remove. And similarly, we're going to call it clear cart item. So let's talk about how to do this. Let's make a third helper function called clear cart item that is going to receive the cart items, because as we know, we need to probably utilize this cart item to give us back the new cart. And then there is the cart item to remove. In fact, we can even be a little bit more explicit. We can call this cart item to clear, because we already did cart item to remove here. This way, at the very least, it's a lot more visually clear for whoever is reading our code. So what we now need to do is think about what we did before. Here, if the quantity matched to 1 for some existing cart item, then we filtered it. So really, this is all we need, this portion of the code. Because all we're doing is we're saying, hey, if the cart item you're trying to clear out from the carts is equal to the cart item that's already there, then just filter it out completely. So this alone is actually all the code we really need. Let's test this out. So let me just make this a one-line return once again. And then down here, we're calling it. We can just add this to our value. And let's import this into our checkout item component. And inside of our checkout item, we need to attach it to this. So in order for us to do that, we need to import in use context from React. And we also need to import in our cart context. And then inside here, I want to pull in clear item from cart equals use context cart context. And then if I just add this as a on click, you know what? Let's do our typical pattern where we create a separate handler and we'll call it our clear item handler, which is equal to a callback that will call this, passing in the cart item like so. Then here we can now do on click, which is equal to clear item handler. And now, if we go back to our code, again, we need to include in some items, go back to the checkout. And now if we hit this, there we go. We got rid of all the quantity of that gray brim hat. And as we can see, we've reflected it everywhere possible. So what we need to do left is also attach on the increment and decrement that we previously kept inside of our checkout component. So here we can actually just cut this because we're going to need it anyways. come over back to our checkout item component and add this on right here. And then what we need to do beside the quantity for these spans is also include the arrows. So what I'm going to do is I'm actually going to add 2 divs into this span. And what I'll do is that for each div, I want to give it a class name of arrow. So let's duplicate this on both sides. And then what I'm going to do is I am going to actually add a left and right arrow inside of this. So the way that this works is that you're going to use another similar symbol. This time it's going to be ampersand hashtag 10094 semicolon. This one is for the leftward facing arrow. And then for the rightward facing arrow, you're going to use 95. As for this quantity, we're going to want to make sure to wrap this in a span because we're going to need to style this quantity now so that it accurately shows what we need to show. So here I'm going to give it a class name of value. And what I'm also going to do is now just add the onClick for our arrows. So I'm going to say onClick is equal to, let's create our handlers const add item handler. And this will just be a callback that calls add item to cart, passing in our cart item. And we'll do the same for the remove item. There we go. Now, if you're wondering why are we creating these outside handlers rather than just putting these anonymous functions directly into these onClick areas, this actually has 2 purposes. The first one is that if these methods ever change, we have a very clear idea of where these definitions are rather than being inside of our JSX. They're in a place where we know we instantiate and initialize all of our helper functions and anything like that. It's just for code clarity, so it's easier to update these if need be. The other reason is because by doing this, we're actually going to be able to optimize this code later. But I'm going to talk about that later when we get to the optimization step. For now, we're still in just the building functionality step of this code. So let's add these onto the appropriate places. And, the top one is actually going to be the remove item handler. And then the bottom one is going to be the add item handler. So now if we save this, let's just double check in our checkout item styles in here, inside of our quantity and all of these other values, we are indeed adding in the appropriate styles. But let's think a little bit about whether or not we need to update our styles, especially on quantity. So in the quantity, we added in this additional arrow div that contains the left and the right arrow. We want to make sure that whenever somebody hovers over them, we do a cursor pointer. And as for the value in the middle, the reason why we added the value is just so that we can say, oh, give me a left and right margin of 10 pixels. So now if we save this code and we come back, we see that we have a little bit of wonkiness here. So what we need to do here is we need to modify this quantity to have display flex. So that now, there we go. We have everything looking like how we need it to. And we can increment this quantity and we see it reflect appropriately in our cart. And that's it. Everything is working as we expect. Now, before we move on, one last thing to do is to figure out how to correctly display the total. We need to be able to iterate through all of our cart items and figure out what the price is versus the quantity of all of those cart items. So that's my challenge to you. Figure that out, and let's do this last thing together in the next video. Welcome back, everyone. So let's set the total inside of our cart provider. So first, let's make a new value of total, which by default is 0. And this is going to be very similar to the count. Essentially, it's almost the same thing, except what we're doing is we're really just changing the value of the total price by accumulating it rather than the quantity. It's arguably pretty much the exact same code as the actual count. So what we're going to do is we can duplicate this use effect. Some of you may be wondering, why don't we just put both effects into the same effect? Typically, one of the best practices when using use effect is to make sure that it just governs one singular responsibility. You can have multiple use effects running. It's kind of like how you want your functions to be single responsibility. You want the same thing for your use effects so that it's not so convoluted and difficult to read. Here inside of this use effect, what we're going to do is we're going to say new cart total is equal to reducing over our cart items. And we're just going to add the total value equal to the cart item quantity multiplied by the cart item price. And this is pretty much it. Once you have that, you can just set the new cart total by calling set cart total. And then we can just pass this cart total as the value. So actually, instead of total up here, I need to also update this to cart total, so that's a lot more clear as to what this value represents. And then we can just attach this over onto the value. And inside of our checkout component, we can just pull off the cart total and then render it right here, like so. And we can just put a little $sign so that we're much more clear about the fact that this is in US dollars or Canadian dollars or whatever currency you want it to be in. So let's save this. Let's go back. We have $0. Let's add some items. Come back. Go to checkout. Scroll down. There's our total. If we add 2 more gray brims, this total should increase by $50, which it does, to $224. If we get rid of this, it should reduce by $70 to $154, which it also does. So everything is working with our total. So there we go. We have pretty much the majority of the complex features that we need built in based on our cart. It's already looking really good. So now what we need to do is we've primarily done this for a bunch of our hats, but what about all of our other actual data? In fact, this is all still hard-coded into our system. What we want to do is we want to figure out how to improve this structure by adding more items into our overall project, but also figuring out how to fetch them from a backend. So we're going to move on to the next section, which is where we need to work with fetching data from a backend in order to populate our website. But before we do that, let's first commit our code. So go back to your terminal. And then what you're going to do is just add your changes. And what we're going to say is created checkout page along with checkout items and checkout cart functionality. And then just push this up. And now join me in the next video where we're going to start working more with product data. I'll see you in the next video. Welcome back, everyone. In this video, we are going to discuss getting our products up onto Firestore. What we see here is just a limited array that we have hard-coded into our front-end application. We have a larger array that more accurately reflects these 5 different directory categories that are available for products. But more importantly, the reason why you want your products not to live on the front end is because when you think about most applications, especially e-commerce applications, the data is actually spread across hundreds of thousands, if not millions of different products. It makes zero sense for us to store that on the front end because that becomes inconceivably large and arduous to work with. Also, if anything needs to change, what happens if you have to change it in the front end? That makes very limited sense to do that. You most likely want to change it in a database somewhere. Oftentimes, these products might also be split across multiple countries. Some countries might receive some products, other countries might not. By having a centralized source where you can control the data, it becomes much easier of a strategy of how you distribute that data and those products. So for us, we need to figure out how to mimic at least interacting with such a resource of a backend, such as a data API endpoint for our products. Luckily for us, we can figure out how to store that into our Crwn-Clothing DB, and that's what we're going to focus on right now. To begin with, though, there's a couple things that I want to discuss with you. When you look inside of my database right now in Firestore, I've currently got these categories just to show you what the final result that we're moving towards is. So don't worry if yours doesn't have it. Of course it wouldn't because we haven't actually uploaded anything there. But the main reason I want to highlight this to you is because I want to show you the general structure of Firestore. If you've ever worked with NoSQL databases such as MongoDB, this Firestore database is actually pretty much the same thing. And when I talk about that, what I really mean is that there's primarily two different types of databases. There is SQL databases and NoSQL databases. A SQL database you can kind of see as if the structure of what the data being housed inside of an individual collection. So if you think of a collection for us as categories, looking at each of these 5 different document items I have, what do they look like when you consider their shape? Here we see that hats contains items and titles. Items is an array that contains objects that have the shape of ID, image URL, name, and price. If you look through them, they all have this same shape. So here, even though what we have with this Firestore is a NoSQL database, what I want you to think about is that with a SQL database, this is very rigid. There's actually a lot more other additional nuances to SQL, but the main thing you want to think about is just that the shape and the expectation of what fields are present inside of every single document of one collection must be the same. So that means that every single document and categories must have an items as an array. And inside of the array, they all must have the same values of like ID, image URL, name, and price. Similarly, title must be a string. So you might be wondering, well, Yihua, in this Firestore database, if this is not in that shape, why is it that all of these still look the same? So that's actually one of the things about using a NoSQL database. While it is flexible in the sense that it's not held by that same rule set, meaning that on this set of categories, I could easily make a new document, for example, and let's say we call it something new. Let's say we call it kids, meaning that we have some kids clothes. If I save this, and let's say what I'm going to add as well is those fields on here. What I could do is I could actually add an age property, and this might point to string, and the string might say, hey, it's between 11 and 18. Similarly, I could add even yet another field. For example, maybe I could add address, and the address might be an array, and this array might contain values of the location, for example. Instead of having something like that, I could have a map. And a map you can see as an object, except the only difference is that with a map, the objects all have unique fields, meaning that you can't have duplicate fields. So in this sense, if we think about this map, the field for address might be city. So let's see in our particular case, one city is Toronto, but then I could also add another one for another different city. And that city might be New York. I can even, in this group of arrays where they're all maps, I can make a new one where the third one is a string. And for some reason, I could say Beijing. None of this matters. I can still equally save this document, and this field will live alongside these other document objects. So really, the main benefit of this is that you get a lot of flexibility. You don't really have to adhere to any kind of structure. You can just save whatever you want anywhere you want. But the problem with this is that your data becomes really inconsistent. Can you imagine mapping through this array of potentially 6 different documents, but for some reason the shape of all of these objects are completely different? This becomes extremely unpredictable and very hard to work with, which is why despite the fact that this might be a NoSQL database and you can save whatever you want onto it, we want to be very diligent when it comes to what we're actually saving the structure of this data to be. So let's take a quick look at this structure. So I'm just going to delete that kids document that I made. Really what this is that these are just objects that contain an items field, as I mentioned, that has these objects, as well as a title field. So what we're going to do is we are going to try and actually add this into our own Firestore. I don't expect you to manually create every single document individually. That would be absolutely a waste of time. So what I'm going to do is actually give you the JSON object, and then we're going to figure out how to create some utility functions that allow us to do so. But the primary thing I want you to see is that this is the type of database we're going to be working with. So now that we know this, let's try and create our own categories in the next video. But before that, I'm just going to delete this category so that we're all starting in the same place. So here, I'm just deleting the categories. And now my database probably looks like yours. So let's get started with adding our products into Firestore. Welcome back, everyone. Currently inside of your front end, you most likely have this shop-data.json file that we made a couple lessons back. In this video, instead, we're going to replace this with a much more verbose collection of multiple different categories that include different products. So these that we have are all hats. They will now live under a hats object. So what I want to do is actually show you that your data inside of your front end doesn't even have to be JSON. It can easily be a JavaScript file. And in that JavaScript file, it can contain some variable that points to a JSON-like structure with all of the data. So I want you to go into your resources folder, get the shop-data.js code that I have embedded in there, and copy and paste that into this new shop-data.js file. And here what you will see is that inside I have just some const shop data that points to an array of objects which contain the title of the hats and then the items, where you see a very similar pattern to what we had before. Except now we have numerous categories. We have the sneakers, we have the jackets, we have the women's, and we have the men's. And then what we need to do is just export out by default this new shop data. And this JavaScript file now we can import into our projects however we want in order to utilize them. Now, in order for us to properly utilize this data, we're going to have to find a way to get this up onto our Firestore. But there's a couple things we need to do and disable so that our project doesn't break. Because right now, if you remember, our products context is still using this products from the original shop-data.json file. But we don't have that anymore. Well, now we have a shop-data.js, and this is now shop data. So what we're going to do is we're going to utilize this shop data as well as this context to actually store the new shop data on there. But because we're still exporting out these products in some way that we have different components that rely on, what we need to do is just convert this over into an empty array. So at the very least, everything works even though you won't see anything anymore on the shop page. If we save this now and we go back to our application, what we see inside of shop is we still have the route working, but there's just no data to display because right now we have an empty array. So that's just setting this up so that our code doesn't break on us. What we need to do now is we need to go into Firebase utils. With these utils, what I'm going to do is I'm going to walk you through creating a method that allows us to upload these categories from that shop data up into the respective collections up in Firestore. So to do this, we're going to need to bring in a couple methods. The first one that we need is we need the collection. So collection actually isn't even from Firestore Auth, it's from Firestore. Because Firestore is what governs our database. So we need both the collections method and we need the write batch method. And I'm going to explain to you what both of these are. First, the collection method is the most important. We need the collection method because it'll actually allow us the same way when we were getting a document reference to get a collection reference because we're trying to write to a brand new collection. So here what I'm going to do is I am going to create a new function and I'm going to call it add collection and documents because that's what we're doing. We're adding in some new collection as well as the actual documents inside of that collection. So what I want to call this for my first variable that I'm going to pass in is the collection key. This is going to be that key that we saw inside of our DB. So for example, this collection has users as the key. We want one that has categories as the key. So we're going to pass that as a string, but this is just what I'm calling a collection key. And then the next argument is going to be the actual documents that we want to add. So here, let's just call them objects because they're really just JSON objects. So I'll call it objects to add. And this is our function. The other thing to remember is because we're adding to an external source, this is most likely going to be a bunch of async behavior because we're essentially calling out up onto an API in order to store data. So this is async. What we want to do now is I want to think about how it is that we actually create the collection. Because right now it doesn't exist. But as we learned with user document references, as long as we try and find something in the database, Firebase is actually going to create one for us, even if it's not populated. Because that's what the document reference is. In our particular case, now we're making a collection reference. So here I'm going to say const collection reference is equal to collection, passing in our DB, because we're saying, hey, go with our DB instance. As we know, we did with auth. This is exactly what we're doing with Firestore as well. We have one DB singleton instance, and we're saying, hey, get me the collection within the DB. And within this DB, what specific collection key are you looking for? Well, this is going to be the collection key that we pass in. So you can imagine that when we actually call this function, we're going to give it categories. So now that we have our collection reference, what are we going to do with this? Well, now what we have to do is we need to think about how to store each of these objects now inside of this new collection ref as a new document. Now, we are writing multiple different documents into a collection. So for us to do this, we need to actually think about this concept of transactions. A transaction is a word that represents a successful unit of work to a database. Now, a unit of work differs. It might be multiple sets of setting values into a collection. For us, we consider a successful write to this collection if all of the documents successfully wrote to that database. This means that there are numerous writes involved in this one single transaction. The single transaction being we stored all of the objects into this collection. The reason why you want to think about transactions like this is easily demonstrated when you think about a bank. If you imagine, and let's just use some examples. Let's say that we were a bank and we had a database that included me, Yihua, and in Yihua's bank account was $1,000. Then for Andre, he also had $1,000. We are two instances in the bank's database. Let's say that I wanted to transfer $100 from my bank account to Andre's bank account. What needs to happen on the database is that this database needs to see minus 100 on this value. So setting this value should go to 900. But Andre's bank account needs to see a plus 100, meaning that his value in the database must go up to 1100. As a result, these are two different writes, which means both of these writes have to go through in order for this transaction of me transferring $100 to Andre to be deemed as a successful transaction. This is considered one unit of work, even though there are two separate write events happening. There is a minus 100 that is writing to the database so that my 1,000 becomes 900. And there's a separate write so that Andre's 1,000 becomes 1,100. If only my minus 100 happened and Andre's 1,000 stays the same, this is not a successful transaction because this means that my account lost money, but Andre did not gain money. So that money disappeared. This is the concept of a transaction, meaning that if Andre's write to the database, where writing this to 1100 for some reason failed, then this entire transaction failed, meaning that my write gets overturned, so that both accounts are back where they were before the transaction ever started. Only now is it possible for you to reattempt this maybe when your network is more secure or whatever issues that cause this to happen is fixed. This is the concept of a transaction. So we want to do the same thing. We want to make sure that all of our objects that we're trying to add to the collection are successfully added. And to do that, we need to use a batch. So a batch is what we get from that write batch method that we also imported from Firestore. So how to use this and continue building out our add collection documents is what we're going to cover in the next video. But now all you need to know is that we just created some collection. We got the collection reference. Now it's time to batch write these objects to there. So join me in the next video where we'll figure out how to use batch. Welcome back, everyone. In the last video, we discussed about creating a batch so that we can add all of our objects to this collection in one successful transaction. So to do this, we need to use that write batch method that we imported from Firebase Firestore. So here, how to use it is we need to instantiate a batch class by saying, hey, I want to make a batch, and this batch is going to call write batch. Write batch is going to return me a batch, and we have to pass it the database that we're trying to make this batch on. So as you've seen with this trend, we just always pass the database to whatever these methods that we've imported are. So now that I have this batch instance, what batch allows me to do is attach a bunch of different, let's say, writes, deletes, sets, whatever. We can attach all of those to the batch, and only when we're ready to fire off the batch does the actual transaction begin. So what we need to do is we need to create a bunch of set methods, or not set methods, but set events. Because each of these objects we're saying, hey, I want you to create and set that object into this collection as a new document for me. So to do that, what we're going to do is we're going to say, hey, objects to add for each. So for each of these objects, I want you to batch set for me. So here we're going to receive this object. And if you remember, this object is inside of the shop data. It's each of these category objects here with the title and the items array. This is what we're adding in. So each of these is the object, and we have 5, as you can see here, 5 different objects. So how we're going to do this is inside of Firebase Utils, again, with this object now, I first want to get the document reference. So to get the document reference, I'm going to make one called docref. And this is equal to calling the doc method, which we've done before when we got the user doc method, except in passing it DB, I'm going to pass it the collection ref. Because the collection ref actually tells directly this doc method which database we're using. Because we've got this collection ref from calling collection where the DB was already passed. So this doc is smart enough to know, oh, you're giving me a collection ref. Most likely you got it because you've already told that collection ref what DB it's from. So then with this collection ref, what we also need to get this document is the title or the key. What is the value, the key value here? So here, these are actually the title on the object. So I'm going to say, hey, give me object, give me the title, but then lowercase it. Because right now it's in normal case, meaning the first letter is capitalized. Then what we want to do is we want to say, okay, I want you to batch.set on this document reference, because as we know, Firebase will give us back a document reference even if it doesn't exist yet. It will just point to that place for this specific key inside of our collection. And now what we're saying is, hey, set that location and set it with the value of the object itself. You can pass it some JSON object and it will build out that structure for you. And this is our entire batch. Then what we need to do is we need to await actually firing off this batch. Because what happened is that we iterated over each individual object in the array. We added an additional batch set call on there, creating a new document reference for each of those objects where the key is the title and the value is the object itself. So now we say batch.commit, and this will begin firing it off. And then when we're done, we can just quickly console log done to ourselves so we know it's finished. So I want to save this. I want to come over to my products context, and then I want to import it in. So I want to import in add collection and documents from our utils /Firebase utils. And then what we want to do is we want to fire this off once. So one important thing here is I'm going to use a use effect. And for this use effect, what I'm going to say is just use effect should fire only once. And what we fire is this add collection documents with both the string of categories, because that's the name that I want for the collection. And then we're going to pass the shop data as the actual objects we're trying to add. So now what I want to do is I want to save this, and inside, just make sure that it ran successfully. If it did, we should see done, which we do. Now, if we go back to our Firestore and we refresh, what we see we should see the new categories collection here, which we do. And inside we see our different documents that reflect our different categories now. So there we go. What I also want to do though is make sure that I delete this use effect, because every time you run it, it's going to try and set new values inside of the database, which we don't want to do. We just wanted to do this as a one-off thing. Typically what happens is you wouldn't do this on your front end, but just for us, because we're only controlling it on the front end and we have access to all these documents, I figured it's a good time for you to at least see how you might interact with Firebase when it comes to storing values in your database. And we also learned about batch along the way. So now that we're done with these, we don't need these values anymore. I'm going to keep this import and this use effect because in the next lesson, it's actually important for us, because what we need to work on now that the data is inside of Firestore is to pull that data down. But at the very least, we now have the data inside of Firestore, and we now have some method that we can utilize. If you don't want it to be title, you can make this more generic, because here right now we're saying, hey, directly, I'm going to pull this off of objects to add, when in fact this might not always be present on these objects. I know that I said this would be generic, but in this particular case here, we just wanted to use the title to get this through. In your particular case, you can pass some additional field value, which designates which of these values you want to use. So here you could do it like so, like that. And then now you just pass the field in as a third argument. So in our particular case, this would have been equal to the string of title. That's another way you can do this to make this work. You can also pass this dynamically inside if you want as well. There's numerous ways you can do this. But for us, at the very least, with what we needed, we just needed to get the title. But here we have this inside of our Firestore. And now that we have our data in Firestore, let's pull it into our application and figure out how to use it. So with that, I'll see you in the next video. Welcome back, everyone. In this video, we are going to actually now retrieve the categories from our Firebase, and we are going to build out the documents inside as well, all in one accessible JSON object. So here what I've done is I have mapped out this temporary reflection of essentially what the JSON object looks like. It's pretty much just an object where you're going to have the different categories by their title value as the actual key. And then the value is going to be some object where inside it contains title, which points to a string of the actual name of this category. And then inside they will all contain an items array where the items themselves will be the actual item documents corresponding to the category. So in order for us to actually write out this function, what we're going to need is we're going to say export const get categories and documents. And this is going to be an async function because, again, we're making a retrieval from the actual Firebase. Now, inside what we need to do is we need first the collection reference. So just like we got it before, I'm going to say collection reference is equal to collection, passing it the DB, but also the aforementioned collection key. Here, though, we know exactly what the collection key is. It's the categories key because we just made this collection. Then what we want to do next is a little bit more complicated and convoluted, honestly, but unique to Firestore. What we need is we need to generate a query, and from that query, we need to get docs. So we need to import two new methods from Firestore, query and get docs. After I write this, I'm going to explain a little bit about why we set up our code this way, primarily to guard against Firestore. And this is often not even unique to Firestore, but front-end development as a whole typically falls under this trap, or you could argue JavaScript development as a whole falls under this trap. But what we need to do with the query is we need to say, hey, I'm going to generate a query off of this collection ref. So I'm going to use the query method by passing in the collection ref. This gives me some object now that I can get a snapshot from. So I'm going to say query snapshot is equal to await of calling getDocs on queue. So getDocs here is the asynchronous ability to fetch those document snapshots that we want. Because now it's all encapsulated under this query snapshot. From here, we're actually able to access the different document snapshots off of query snapshot.docs. This will give us an array of all of those individual documents inside, and the snapshots are the actual data themselves, as we've seen before when we use snapshots. But here what we want to do is we want to reduce over this to create this structure we've been discussing. So here I'm going to say const category map, which is what we're trying to build, is equal to query snapshot.docs.reduce. So we're reducing over this array in order to finally end up with an object. So here for the actual structure of my reduce, my first argument, of course, is the callback that gets invoked on each document snapshot. And then this is the final object we want to create, but this is the initial instance of it, which is an empty object because we're building out the map as we go. The first argument is going to be accumulator. The second argument is going to be doc snapshot. And then from here, what we're going to do is we are going to first need to destructure off the values of the data of this doc snapshot. So I want the title and I want the items. And I'm going to say, hey, take this doc snapshot, give me the data, which will be the object, and then take off the title and the items. Then what I'm going to do is I'm going to say the accumulator at the title value is also needs to be lowercase. If we remember, our title is actually, as I mentioned, uppercase. This value is going to be equal to the items. And then I return my accumulator now that it's been updated. So now what this will be is the actual category map that we've been building out. And I'm just going to return this as is. So if you're looking at this and you're like, wow, what are these queries? This get docs, this is async, and then we need to reduce over, and yet somehow here on the docs, we get like these document snapshots. I know this seems confusing, and quite frankly, it's changed every single instance major version of Firebase. It's actually one of the more annoying things about how Google builds out Firestore is they do make it backwards compatible. You can use the previous versions if you've taken this course before of how you build out these different data models, fetch this data, store this data. But here, the main thing that I want to highlight what we're doing is we are creating these helper functions. And the main thing they do is they isolate the areas that our application interfaces with things that might change. In this particular case, it's third-party libraries. The third-party library might change their implementation, but at least we're isolating them all into these individual functions rather than directly using these Firestore and authentication methods throughout our application. Because if we did that, then let's say Firebase or Firestore changes the way they work. Then across our entire application, we need to change all of those different places. Whereas now we've at least isolated them all into this one file, into these individual functions that are clearly defined as to what these functions are trying to do. For example, with this one, we're trying to get our category map here. If they change the implementation here, we just need to change this one function. Anywhere that's utilizing the category map is still just going to rely on this one function. So as long as we fix the function, then we know that as long as we're returning category map, our code is still going to behave throughout the rest of our application the way we need it to. And that's why we structure our code this way. So this is one important thing you need to remember, because unfortunately, the world of JavaScript development moves very quickly. Libraries are constantly changing, patterns are constantly changing, frameworks are constantly changing. We need to figure out these patterns so that we can at least best isolate and minimize the impact that these changes have on our code base from working. And this is one of them. So now that we've generated our category map, let's actually see if it is indeed working. I'm going to copy this method that we just made, and I'm going to move it into our product context. So here now, I'm going to replace this add with our get categories documents. And then what I'm going to do is I am going to call use effect. Now, use effect is going to simply just call our get categories. But one thing I want you to know, and this is a new thing we're doing with use effect here. This method is an async method, which means we get back a promise. So the promise of this value doesn't resolve until our way of get docs is complete. And then it still have to run through all of this to build the category map. When you're using an async function inside of useEffect, you don't want to pass a async callback like this. You want to, inside of your anonymous callback, actually create a new async function. So here I'm going to say const get categories map is equal to an async function. And inside of this async function, we're going to actually perform the async call. So here, again, const category map is what we get back, is equal to our await call of get categories and documents. Any async things you need to do inside of a use effect, wrap it in an async function, and then what you need to do is then you call this method at the bottom. So to show you, I'm just gonna console log the map, and then after we've defined it, I'm gonna invoke it. And of course, I only wanna run this on when this provider gets mounted. So if I save this, I go back to our application. What we'll see after it fetches is, here we go. This is our categories map. We have an object that contains our hats and our jackets and our men's and our sneakers and our women's. This is exactly what we wanted. And now we have all of the data we need to actually finish fleshing out our shop. But again, the main things that we've learned here are two new lessons. One, we got a better understanding of why we set up all these utility functions, because we want to minimize the impact that changing third-party libraries have on our code base. And secondly, we also learned about using async functions inside of useEffect. We want to make our own new async function within the callback. And then what we want to do is we want to call it inside of the same callback after it's been initialized. So now that we have this working category map, we need to actually change up the structure of what we called this provider, as well as make some new components. So that's what we're going to do in the next video. I'll see you there. Welcome back, everyone. In this video, we want to talk about utilizing our new category map inside of our application. As a result, it makes this products provider seem a little bit incorrect. So what we need to do is think about refactoring our products provider so that it more accurately contains these categories that we want to use through our category map. To begin with, let's start with renaming. I'm going to name this categories context. And similarly, I'm going to have to rename this product context as categories context. Instead of showing products, we want to be more explicit that what we have is a categories map. And similarly, with the categories here, we want to switch provider also to categories provider. As for products, we're now showing a categories map and set categories map. Capitalize the C. And instead of this being an array, what do we want to know about a map? We know that the map's empty state is when there are no categories to show. So instead of showing null, we can just show an empty object. And the reason why we're going to use an empty object is because we're really interfacing with the object's keys in order to get the responding item for the category. So if we're trying to get it and there is no keys, then we're just going to get nothing back. And that's why we want to use an empty object instead of null, where you typically want to store like a full object. Here, it's kind of like a collection. And when you use maps, typically an empty map is the empty state of a map. So now that we have this, let's think about the actual value, which will also be our categories map. Similarly, we want to update the name of this file. So here, I'm going to switch this over to categories.context.jsx. And then with this now, we also have to update wherever we're calling it inside of our index.js. Because now we are no longer using a products provider. We are now using a categories provider. And similarly, this is no longer products context, it's categories context. So let's copy this over into our products provider. And then now everything should continue working. So if we go back to our application, we should see everything still works as we expect. If we have any issues, let's figure it out. Inside of our shop component, we can't resolve products context. Of course, we still have one more place where we're using it, shop context, or shop component, sorry. Here we see that our products context is what's being pulled in. So let's just call our categories context and pass that in here. And then similarly, we no longer have a products context. It is now a categories context. So let's save this again. Now, again, with use context here, we're not actually calling anything here inside because now products is no longer an array. So let's just comment this code out for now. And instead of showing products, let's also just delete this. And now if we come back, go to shop, still empty. Okay. Now let's go into our categories context And now what we want to do is we want to set this category map to the actual value that we're exporting through our value here. So I want to call this set categories map setter on the category map that we get back from our method. And then I'm going to save this. And now back in the shop component, we need to think about how to utilize it. So remember, when you look at the shape of this component, it is an object that has a title for the key, which we need, as well as the items itself. So we need both of these values. And what we want to do is we want to iterate through this different items array to show the first 4 items for preview. And before we build out the component, let's just make sure we at least know how to work with this categories map object first. So I'm going to leverage this products container because all it is, if you remember from our styling, is that it is just displaying 4 columns. And what we're going to do for now is just display the first 4. We can actually display all of them, in fact, if we really wanted to, inside of the grid. The key thing is really just that we have some way to show that we're able to work with this component properly, this categories map. So what I'm going to do is I'm going to wrap this inside of a fragment. And if you've never seen this before, this is shorthand for fragment. Instead of importing fragment, you can actually just use this. But let's be consistent and let's just import fragment because that's what we've been doing up until this point anyways. And consistency is very important in a project. And now what we need to do is we need to figure out how to map through this categories context. But this is an object. How do we get these individual fields inside of this object? Well, there's actually a way you can do this. You can do object.keys, which will essentially allow you to pass this an object itself, and it will return you back an array of the keys. So here I can say, hey, let me give you the categories map. And what this will give us back is an array of all of these key values. So it's an array of strings where it contains hats, jackets, men's, sneakers, women's. And with this, what I'm going to do now is I'm going to map through this. And I know that what I have for the key is going to be the title value. It's not necessarily the title because it's capitalized, but remember, they're all lowercase when we put them into our map. Here, what I want to do is I want to now, again, use a fragment, because inside of this fragment, I want to show an H2 where I have the title. And then underneath this, I want to use this div. So here I can really actually just copy this over and place this inside. Now let's uncomment this out. And here, what is products? Products is the array of products associated to this specific title, whether it be the hats, the sneakers, the jackets, the men's, the women's. How do we access this now? Well, remember, we had categories map, which is the object, and the object has these key values. The key is the title, which we clearly are destructuring off, or not destructuring, but we're getting it off of this object.keys. So this, when we call this, should give us the corresponding value of the associated array of products. And now we can just map through this with the appropriate product, and this should now work. Now it does look like I have a bit of an error here. Oh, it looks like that I have an extra bracket set. So this is not necessary. We only need one set of curly braces to render our JavaScript. So there we go. We also here need to explicitly return something back. So let me tidy this up right here where this is mapping through. I don't need this one, and I don't need this one. There we go. Okay. This now cleans up what we had before. Before I was not returning from my function because I had squiggly brackets, but now I'm using a single line return. So if we come back, we see each child in the list should have a unique key prop. So let's do that as well. Inside of this fragment, I'm going to give it a key of the title because I know those are unique because it's a map. And now, if I refresh, there we go. We see hats shows us these hat values. Jackets shows us these jacket values. Men's shows us these men values. And shoes shows us these different sneakers. And women's shows us these women's. So everything here is working. You'll notice also that because we're rendering our product cards, our cart continues to work. There we go. So here we've figured out at least how to work with this categories map. What I want you to do now for your challenge is that actually this should not show all of these products. We actually need to create separate routing for this at this shop level. What we need is we want the base route to just show these 4 first elements inside of each of the categories. And then when you click this actual value here, it should in turn take you to a corresponding / whichever page that shows the actual items there. There's actually one particular nuance to the routing that we're going to have to learn about in the next video regarding using dynamic parameters. But really what I want you to do is just really think about kind of how you might separate this. You don't have to code it out yourself, but just think about it. And in the next video, let's do it together. Welcome back, everyone. In this video, we are going to start working on breaking out this nested route of shop. Inside of shop, we have mainly 2 different routes. We have the base route, which shows these different collection previews of our categories. And similarly, deeper down into the shop route, we also have the individual routes that point to each specific category that shows all the products inside of it. So here, hats shows all of the hats. And of course, jackets shows all of the jackets. But notice how this value is dynamic. Well, we're going to learn all of that in this upcoming section. But the first thing we want to do is just figure out how to build this base section for our shop page. So let's go back to the application. What I'm going to do is I'm going to make a new component that is a preview of a category. So of course, I'm going to call this category preview. Inside of this folder, we need to set up our base files. So I'm going to make a category preview.styles.sass. And I'm also going to make a category preview-component.jsx. Nothing new here. The component is going to import in the style sheet. And then we're just going to set up some base component. Category preview equals a functional component. And we're just going to export by default category preview. Now let's think about what this category preview is going to do. So this category preview is going to live at the shop component level. Inside of shop component, what we're going to do is we're still going to receive this categories map because we need to generate a separate preview for each of these different categories. So that means that whatever's inside needs to receive both the title so that it can generate the appropriate H2 title, and then it needs to create the appropriate container that shows the first 4 objects. So that means that for our category preview, we can anticipate that we will receive both a title string as well as a products array. Then what we're going to return back is we will return a div, and inside of this div is going to be the content. So as always, we have an outer containing element, and we always tend to call these the category, or the name of the component at least, -container. And once we have this now, let's think about what goes inside. So we know we have to display the title. So I'm going to make an H2, and this H2 is going to contain a span. And within the span is where I'm going to have the title, and I'm going to uppercase it. Now you might be wondering, why is it that we have a span inside the H2? Well, remember, this H2 becomes clickable. It becomes a nav link for us. So what I want to do is I want to make sure that this only is clickable on the text, not the H2. The way that we're going to set up this container is that it's going to use Flexbox. So that's going to actually make it so that the entire H2 spans across the entirety of the width, which we don't want. We don't want all of that clickable. We just want the span. And you'll see once we actually add in the styling. So I'm going to add a class name here of title. And then what I'm going to do is I'm going to add a div. And in this div, this is where it's going to contain all of the actual products. So this, I'm going to give a class name of preview. And then what we'll do is we'll take the products array we receive. And remember, we want to filter out anything but the first 4. So here, what I'm going to say is that I want to get some callback. This callback is going to get the product, which I'm going to ignore. So I'm going to use an underscore saying that I don't want to use it. And then the second argument of this is the index, which is the index inside of the array. So the placement in the array First element being index 0, second being index 1, third being index 2, etc. and onwards. And what we want to say is that we want to filter it out if the index is greater than 4. So we'll say, hey, keep it if the index is less than 4. Because greater than 4, as we remember with filter, whatever evaluates to being false is what gets thrown away. So here we're saying, hey, as long as the index is less than 4, so the first 4 indexes, because it starts from 0, I want you to keep these products. And then after we filter them out, then we can map through them. So here we pretty much just do what we had before. We're going to take our product and then we're going to pass it to some product card component that we need to import in. So let's import in product card from the product card component folder and file. And here inside, we're just going to render the product card. And of course, we're going to give it the key of the product ID. And then product goes to product. Now again, inside of your preview styles, I've included the file for you, so please copy and paste that from your resources folder. So now that we have this pasted in, what we need to do now is use this category preview component. So here, let's import this back into our shop component. And here we can just say, instead of importing the product card, we're not doing that anymore. We're importing directly the category preview, which will replace the need for a lot of what we have inside now. Let's just say category preview goes up one more into components / category preview component. And now what we can do is start replacing this code. So instead of this fragment, I'm going to use a div. And for this div, I'm going to give it a class name of shop container. And then inside of here, we don't need all of this fragment code. What we do need though, is we need the actual object keys. So let me also fix this because instead of doing one line return, we now need to do multi-line. The reason for this is because I need to set the products to a const because I want to get this out of my categories map using the title. And then what I'm going to return is this category preview, which we've already determined needs to utilize. First, I'm going to pass the key for the title. I'm going to pass it a title, which is the title. And then I'm going to pass it products, which is products. So now if I save this, get rid of the need for the fragment up here. If we go back to our application, here we see it. Everything is as we want it to be. So we have our previews showing our 4 different elements. Awesome. So this is our preview. What we need to do now is actually start building out the next route, which is where when you click this title, it takes you to the corresponding shop/hats route and shows the full collection. So let's figure out how to split up our nested routes now that we have our collection preview in the next video. Welcome back, everyone. In this video, what we're going to do is we are going to create our nested routes. We have this page already that we want as our base route. So we need to figure out how to set this up as its own component. And then we need to set up this nested route while accounting for it in our current routing structure. So the first thing we need to do in order to make this component of shop nestable with its routes is we need to say, okay, when you start matching this path, I know there will be a subsequent URL parameter set after shop. Whatever that set is, I don't care. That's what this star represents. It's the wildcard. This just means that I want you to match shop/anything. It doesn't matter. As long as you match that, I want you to forward them and render this component, the shop component. Because now the shop component is going to have its own routes inside. Now, before we actually start implementing the routes, we need to duplicate this into the appropriate page component. Because now this shop component is going to be a collection preview. So let's make a new route folder. And I want to call this my categories preview because we're previewing multiple categories. And similarly, of course, we'll need the categories.styles.sass. And we'll also need a categories/preview.component categories.jsx. Actually, I misspelled this. This is not just categories. This is categories/preview. There we go. Now, inside of the categories, wow, I cannot spell categories. There we go, categories. I'm going to paste in the appropriate code that we had from before. So all of these are still relative. So you can double check. This is going to the correct context. This is going to the correct preview. And what we need to do now is we need to modify this. So instead of importing from shop, this is now categories-preview. And this component will now be categories preview. We no longer need we still need the categories map because all of this functionality is still going to stay the same. Except the only difference here is that instead of category preview container should be the name instead of shop container. So everything else though is the exact same. We actually already had this component fully finished. It was just a bunch of updates to the naming, and also for preview styles, we didn't even have any styles. So actually, since we don't have any styles, we don't even need this file. Let's get rid of this. And inside, we don't need this import for the styles file anyways. If we're not adding styles, there's no need. And if this div isn't doing anything, then we can also replace this div with a fragment, which as we learned about this shorthand of just doing this for fragment. But again, as I mentioned, for consistency's sake, let's just import fragment like so. And let's bring this categories preview now into our shop component. So now our shop component doesn't need any of this anymore. Now what it primarily needs is nested routing. So this means that we need to import in routes and route. The reason why is because you cannot use a route component unless its immediate parent is a Route-Sa component from React Router DOM. So here we don't need this context. In fact, we don't need any of this code. Let's get rid of all of this. And let's start creating our routes. So here I'm going to say routes is going to match a route where the index route is going to render the element of our new collections preview or categories preview. So here, let's import this in. Import in categories preview from categories preview route. And then we're going to render the full component. And now if I save this and I go back to my application, there we see it. Everything is still present. So nothing has broken yet. If we come back now, we need to add an additional route for our new category individually. But before we do that, let's just quickly go over what we had done. The main thing with nested routes is that you want to say with React Router DOM, React Router DOM takes a look at the path value and it says, hey, whenever I match this path inside of the URL relative to what my parent path is, I am going to render this element that you've given me for this route. Now, what we're saying is that, hey, if you match shop / any wildcard of whatever URL parameters that follow, render the shop, because inside of the shop, you can expect further routes. And these routes are all going to be relative to the parent route, which was shop /. Whatever is rendered inside as the parameter will be dealt with inside of this route. So this is the benefit of nesting the code like so. Now what we can do is we can actually build the next category route, which utilizes a URL parameter. And we'll learn about that in the next video. But really, if you think about nesting routes this way, it becomes much more intuitive as to what's happening. Because remember, the whole thing about the path is that the path just matches the URL, and then React Router DOM is like, oh, I'm just going to render this element. Anything afterwards here, I'm not going to worry about, because the fact that you did this means that you have routes set up for that component that will carry on and figuring it out. And this is true for any subsequent children routes that get nested. They're going to follow a similar pattern. Right now, we just have an index route, but in the next component, we're going to do a dynamic URL parameter-based route. So let's do that in the next video together. Welcome back, everyone. So let's build out our category page. To do that, what we need to do is we need to build a new routes component. This one will be category, because that's really what we're showing, is the full category listing. I'm going to call this inside category.styles.sass, and then category.component.jsx. Our component, of course, is going to import in our category styles file. And then I'm going to say const category is equal to this functional component, which we export by default. As for the category itself, what do we need to do? Well, what we need is actually this value from the URL, because if you remember in the final application, when we go to hats, we know that we're on the hats route. When we're on jackets, we know we're on the jackets route. So this URL parameter is actually going to be the thing that tells our category component what data to get. And this is a little bit of architecture that we need to think about. So the first thing we need to do is figure out how to get these parameters. So let's start at the route level first. I'm just going to copy this over into my shop component. And here I'm just going to duplicate this and reflect the appropriate placement like so. And now for the route. It's not an index anymore. It's going to match a path. And what this path will match is actually going to be a unique string. This string only works when you're trying to say, hey, I want a parameter here, meaning that you can access it from a component. And you say semicolon and then the name of the variable. So I'm going to call it category. And what I'm going to render is the category component. Now, inside of the category component, in order to access this new parameter, we need to import in the useParams hook from React Router DOM. useParams now will allow us to actually get this value. And the way it gives it to us is it actually gives it to us as an object. So if there are multiple parameters that match, then we'll get multiple. But for us, because we know there's only category, that's what we called it, category, we can destructure this off from the return of useParams. Now what we also need, once we get this category value, if you think about it, once we get jackets, well, we need to call jackets on our categories map to get the associated products to this category. So that means that we need to now bring in the context. So let's bring in useContext from React. And let's also bring in our categories context. So many C's. So with our categories context, we can get the categories map. Use context, passing in categories context. And then with categories context now, we want the actual products from this category. So typically, what you could do at this point, you could just say const products is equal to categories map at category. You could do this. There's nothing wrong with doing this. Essentially, whenever this component re-renders, these products will be gotten. But this will happen every time this component re-renders. So what we instead want to do is bring in useState and useEffect, because essentially the only time that we want to change these is if the category value changes or if categories map changes. So here we can say we have products and set products, which is equal to useState, which by default has an empty array. And then we'll just say useEffect whenever category changes and categories map changes. Then what you can do is call set products, where we set the value equal to categories map at category. This way now, if our component re-renders or anything like that, our products will not update unless category or categories map has changed. That's the only time we will do that. And now what we're going to return back is just our div and us mapping our products through using the product card component, which we don't have. So let's import that in as well. So here we'll just say, use the product card. And of course, key will be product ID. And the product is going to be the product. For this div, though, we know we need some styling, so I'm going to give it a class name of category container. And inside of category styles, we can just directly style category container, which is going to be display grid. Very similar to what we had before. Grid template column rows, or columns, sorry, 4 columns. So we're going to say repeat for 1FR. I want a column gap of, let's say, 20 pixels. And then I want a row gap of 50 pixels. You can change these gap values to whatever you want. But now if we come back to our main application, and let's say I navigate to /hats now. Now when we navigate here, we seem to see that something breaks. Here, if we scroll up, we see it cannot read properties of undefined reading map at category. So when we look inside of our categories map, at this point, remember, our categories map is saying, hey, you cannot call map method on undefined. So for some reason, our products is undefined. The reason why this is undefined is because we're trying to call category on an empty object when this app first mounts. Remember, our categories context fetches this data asynchronously. But when our application mounts for the first time, it's still trying to actually run this code synchronously. This is happening before we actually get these categories from our Firestore. So what we need to do is build in a safeguard. In order to do that, what we can do is we can say, hey, if products is undefined, then don't render it. Only render products map if products has a value, which means here, in fact, what we can say is that instead of calling this by default with an empty array, we can call categories map at category as the starting value here. With this now, this will still work because we know categories map by default is an empty object. So now if we save this and we come back here, let's just get rid of this so that we can at least see. Now we do see that we are rendering our component without errors. This styling conflict is actually a separate issue that we'll discuss, but I don't want to move on from this topic just yet. Remember, if you have components that rely on asynchronously fetched code, you will need to put in some kind of safeguard so that you only render your component if the actual data is present. And that's exactly what we did here. We defensively programmed against our products being undefined. So now that we have our products in and we have this check in, let's talk about this styling issue. What I want you to do is actually try and debug it yourself. This is a good chance to see and think about why some of these errors might be happening. So what I want you to do is I want you to take a look into these different elements on the side here and try and identify why we have this issue. If you can't, don't worry, I have the answer. I'll give you a little bit of a hint. If you click on this component right here, you should take to this page and see that this is also broken. Why is this happening? Well, take a look into it. And then in the next video, we'll fix this together. Welcome back, everyone. In the last video, we discovered that we seem to have this styling clash. And what you would notice if you look inside of the category container is you see that we have both styling coming from our category.styles.sass, but we also have styling coming from our category item.styles. Our category item, if you remember, is what we named these components. So this is actually an unfortunate side effect that does happen very frequently when we write CSS in Sass. The reason being that if we forget the naming and the nomenclature of these components, it's very easy to accidentally write the same class names for specific elements that you might have forgotten about for some time now. This is also a very common problem in general web development when you're writing CSS and Sass. CSS is present across the entire page. If you're not super diligent with your strategy, it's very easy to find these clashes. So for us, this is actually a twofold problem that we can solve. The first is solving this immediately. The next is figuring out if we can solve it using something in the React ecosystem. And I'm going to talk about that later. First, let's just fix this with the first solution, which is just to resolve this conflict. So back inside of our component, we have this category item component. This component is what we use to demonstrate on the main page these 5 different selectable options. What these are is, instead of calling them category item, we can call them directory item because they're housed in the directory component, if you remember. So let's start renaming these. I want to rename this to directory item. And similarly, the code inside, this should be directory item.component. And also directory item.styles. For this directory item, of course, we need to update all references to this. So let's focus on our internal files first. Directory item like so. And then instead of category container, this should be directory item container. And instead of category bottom container, we'll call this directory item body container. In fact, let's just call it directory item body. So now let's save this, and inside of our directory item styles, let's remember what we changed this to. This is now directory item container. And similarly, it's just now body. If I remember correctly, did we just call it body? No, we call it directory item body. No, let's call it body. Body is pretty clear because it's housed under directory item container. So it's the body of the directory item. And let's see if anywhere else we might have this. Yes, we do. Let's fix this here as well. And now if we save this, we need to now make sure that we're leveraging the new item in the correct place, which will be inside of our directory component. So here now, this is no longer a category item. This is a directory item, which we can now save. And now if we come back, let's see. Our component is now working. And now if we navigate to /shop/hats, we also see that our shop page is working. So what about the other routes? Well, here, if we go to shop/jackets, we see that it also works. The last thing that we need to do that we seem to miss with our collections preview is we did not make these clickable links to take us to the appropriate place. So you can actually leverage the link component we get from React Router DOM to switch this over. Let's actually do this quickly together. Go to the navigation component, pause the video, and try and figure out how to leverage this link component and use it inside the category preview component. I'm going to give you a second to try it yourself. And now let's do it. So what we need to do is import in link from React Router DOM. And then what we're going to do is we're going to replace this span with link. And then the to is going to take us to title, because we're using title as our routes. If I save this now, if I click hats, it does take me to hats. Inside of this page, we can also render the title up here as well, since we haven't done that. So let's go into our category component. And at the very top, before any of this, we can render a H2 where we just show the actual category. And we can give this a class name of title. Now, similarly, we are going to want to style this title. So inside of category styles, we can target.title. And let's just take the same font that we've been using throughout the other parts of our application. So inside of our category preview, component right here, let's take this font size and let's just put this inside of here. In fact, let's increase it to 38. And now if we save this, when we come back, oh, we see that our hats is being rendered in the wrong place. Of course it is, because it's a grid. So now let's go back to our category component and let's move this above, which means that if we're going to do that, then we want to wrap this in a fragment. And now you can say fragment. Let's paste this in like so, and then move the div below it. Save, come back to our application, and now we see hats up here. So what we can also do is to uppercase. We need to call the method like so. And here we see hats. So you can further style this if you want. If you want to center this more, if you want to make this bigger, all you need to do is, because this is no longer inside of the category container, you can say title like so. But the problem with this, of course, is that now any of our other titles might inherit this style if they have this class name of title. So here we actually need to be more explicit. We need to call this something like category title. But again, this is assuming that we can properly remember that this is called category title. This becomes that same problem where we're getting these styling clashes that keep happening. So this is actually what's going to bring me towards my next topic. But before that, let's finish up styling what we need to style. So category title, I'm also going to add a text-align center here. And then I'm going to update the corresponding component in our category component so that it's category title. And now let's save, come back, and there we go. This is pretty much it. We've built our entire application. There's a couple things that we're missing, such as the checkout, or not the actual checkout, but the payment step. But we can discuss that in a later video. It's not the most pressing thing right now because it's just an additional feature. What I do want to do is take a second and really congratulate you because you've built a rather complicated React application that utilizes a lot of the modern technology and a lot of the complex base of what React has to offer. In the next video, we're going to discuss the first thing I mentioned at the beginning of this video, which is that there is this styling clashing problem that we keep seeing. The styling clashing issue comes from the fact that we are relying on CSS to style these individual components, and thinking about how we name their classes may not be the most accurate option. What we're going to do is talk about CSS-In-JS solutions. So that's what we're going to do, and we're going to talk about that in the next video. But until then, take a quick breather, appreciate the work that we've done. You've come a long way and you've really built something great now. You've learned a lot about React, and that is no easy feat. So pat yourself on the back and then join me in the next video. Welcome back, everyone. In this video, we are going to discuss CSS and JS, particularly regarding React. As we saw when using CSS and Sass, there is a high chance that you may rely on your human error to create issues with styles clashing when writing your CSS rules. One of the big advantages of using React is the fact that we're allowed to leverage these new libraries that are called CSS-In-JS libraries. What they allow us to do is leverage JavaScript to build out the CSS for us. What this means is that the JavaScript will dynamically build out unique class names that are tailored to specifically the components that we're trying to style. What this allows us to do is scope our styling exclusively to components, which gives us a huge advantage of never ever even having to worry about these issues ever again with styles clashing between components. In order to get started with style components, we need to install the library. So here we are back in our terminal where we're going to install style components. Now, style components, which is the name of the library, is really just one flavor of CSS and JS. It's arguably the most popular format. There's actually another one called Emotion Styled, but that has arguably almost the exact same structure as style components. If you learn style components, you've learned Emotion. The main thing about the difference between the two is which one came first, and a couple much more significantly nuanced points that aren't important for our learning right now. Style components is most arguably by and far the most common CSS and JS library that you'll come across in your React development, so it's important that I teach you this specific library. So here inside of our project, what I want to do is I want to replace all of our current Sass styling with style components. And I'm going to walk you through the basics as well as some of the more advanced usages and architecture patterns that can emerge through the usage of style components. One of the other big advantages that we get is that because we're doing it at this point where we have so many components newly styled, it's very easy to get a lot of practice, which you'll definitely get to do once we learn some of these basics. So where I want to start is the navigation component. In order for us to transform a Sass file into style components, the first thing we need to do is actually switch it from Sass over to JS. You can do JSX, you can do JS. It's really up to you. Personally, I prefer JSX, even though really what we're writing is JS, but you'll see why sometimes JSX is more important. Here what's happening is that because we've converted this over, these rules no longer apply because this is Sass. In order to use the library though, it all comes from this styled keyword that exports from styled components. What this style keyword allows us to do is generate components. So here I'm going to go, hey, I want to make a navigation container, which is the div component that this .navigation was. If you remember, inside of our navigation component, this div was really the one with the class name of navigation. So our styling was targeting the navigation class name, but now we want to make a new component for it. And the component gets built by saying, I want to call styled. And on style, there's a method called .div, and this div will give us back a div that we can then apply styles to using these backticks right after. Inside of these backticks is where we're going to insert our style code. So we can actually directly just cut this right out and place this inside. This is considered valid style components. So before we do anything else, I'm just going to comment this out and show you how you use this. So once you generate this, you actually do need to export this out as well. So let's export out our navigation container. Let's copy this and let's comment out this. Actually, no, we're going to leverage this because what we need to do is import directly from our navigation.styles file. We don't need the .jsx. Here with navigation container, what you can now do is actually comment out all of this code because there's a couple things I want to show you before we even do any of this. What you'll do is replace the div right here with this new navigation container. If we save this, of course our nav bar is going to be empty. But once you go into your application, what you'll see is that it's technically still there as a component. Now, when you inspect it, this div right here is our style component. We see all of the styling that we added. But notice how this says EGGKPO. This is a uniquely generated class name. This style gets generated on build so that when we are working with our style components, there are no clashes that will happen because style components will ensure that every one of these components that we write now has a unique class name. And this way, the styling is also going to be locked into that class. So by doing this, now we can really be sure that there will be no overlap in our styling with one another. So this is the thing that really gives us this big benefit. Let's unstyle this, or uncomment this code, and continue styling. Next here, we need this logo container. So another great advantage is that you don't have to just leverage this .div or .span or .p. Usually on style, it comes with all of the different HTML base elements that you're used to using, like .button, .span, as I mentioned, .paragraph, .h1, h2, h3. They're all here. But let's say you wanted to style over an existing component. You can do that by using brackets. So first, let's import link from React Router DOM. And now in order to use it, all we need to do is copy the component, come down here, and create a new component. So I want to call this one logo container. So your naming convention follows exactly how you name a React component because that's what they are. They really are just React components. And here I'm going to say styled. And then in order to use the link, I'm going to say bracket link. I'm going to pass link into styled like this. And now I can add these backticks and once again, insert the styling that's relevant. So here I'm just going to copy and paste this over and get rid of that. And now we have our logo container component. So let's continue. We still have navlink as well as navlinks container. So here, navlinks container, this is a div, if you remember. Coming back to our navigation component, you'll have to keep going back and forth. Navlinks container is a div that contains all of the links on our right-hand side. So here, what I'm going to do is I'm going to create export const navigation or navlinks container like this. And this is going to be a style div. And then I'm going to paste this in. So actually, according to our naming convention, once we're inside, I don't even need to name this container. Now I can just call this navlinks like this. Similarly, the internal actual navlinks, I'm going to export a new component called navlink, which is a styled link component that will contain the code that makes them navigation links. And now let's just get rid of this code. Let's save this and I'll show you how to use them. So what we need to do is import the remaining logo container, navlinks, and navlink. So here, let's import in. We need our navlinks container, or our navlinks. We need navlink. And then finally, we need the logo container. So what we do now is we just replace the corresponding elements. So here, logo container, up to the class name, because we don't need that anymore, can now be replaced like so. Navlinks can replace this div like so. Now remember, you still want to keep your methods. What will happen is that even though this is a logo container, it will forward all these props over to the underlying link component. So this will still behave like a link component. Inside here, our link is now a navlink. So for these links, this will continue to work for both these links that have a to property, because these are actually link components. But now you might be wondering, well, Yihua, with the benefit of using the class name, we could apply the styling, but now aren't we locked to specifically whatever component it is that we generated? You would be correct here. However, Style Components has actually given us unique props that can fit into any generated component using styled. Meaning that because we built this navlink component ourselves using the styled library, what this now allows us to do is actually give it an as keyword. And as allows us to pass a string of what component or base HTML element we want this to be rendered as. So here we want it to be rendered as a span, not as a link. And if we save this now and we go to our application, what we'll see is that everything is working. All our styling is the same. But notice how inside of this component right here, again, you see all these uniquely generated classes. Now, of course, these two are the same because they're both navlinks. But let's say that we sign in right here, Mike@Gmail. I want to sign in. But notice now that the sign out is indeed a span. So it's smart enough to be able to know, oh, you want this as a span? I'm going to give it to you instead and change the underlying component to the corresponding element you want. Extremely powerful. So this is one of the beautiful things that we get now with style components. But the main thing, again, is that now all of these components will uniquely generate class names that we can now leverage in order to properly protect ourselves from having any style clashes. Now that we have this, what I want you to do is start going through all of the components and just start restyling them. In the next video, I'm going to talk about one of the emerging patterns we can do by adding style components to our buttons. So do everything but the buttons. And in the next video, I'll show you how we can do buttons and a new pattern that emerges through style components. Welcome back, everyone. In this video, we are going to dive into modifying our button component by thinking about how we can leverage style components in order for us to make our code a little bit more solid in other ways than just the styling aspect. So what I'm going to do first is I am going to show you one of the patterns that emerges with style components that you may not have used yet. So inside, again, I'm going to convert button styles over to a JSX file. And then what I'm going to do is I'm going to import in styled from styled components. And now what I'm going to do is when thinking about buttons, we know that generally speaking, the button has some base styles, and then depending on the class of either Google Sign-In or inverted, or potentially any future additional stylings we add, they just modify some of these values, but they do inherit a large portion of the base styles for this button. So what I'm going to do is I'm actually going to create a new base button component. And this is going to be a styled button component that has all of the base styles here for what we had before on our button container. So now this base button is the normal button without any of the additional classes on it. What we can do for another button, let's call it our Google Sign-In button, is we can actually extend on the base button the same way that we were doing it with the link component. So I mentioned before, you can take any component and add additional styling on top of it. And because our base button is just a button, we can now say, hey, this new component extends upon the base button these additional stylings that are unique to just the actual Google button. And similarly, we want to do the same thing for the inverted styles. So here, what I'm going to do, I'm just going to copy this over. And once again, I want to duplicate this button with a new inverted button, which is equal to styled on base button. And inside, I'm going to paste my inverted styling. And then just delete this now. So now we have three types of buttons: inverted, Google Sign-In, and the base button. What we want to do inside of our button component is modify and import the correct style components now. So I want to import in from button styles. I'm going to bring in the base button. I'm going to bring in the Google Sign-In button. And I'm also going to bring in the inverted button. So now that I have these three buttons, what we had before was this button type classes object. However, we didn't really get to leverage it as well as we wanted to. Now, what I mean by this is that when you think about this button type allows us to not have to pass strings. Instead, we can directly just use this object, which allows us to leverage autocomplete. Autocomplete anywhere just means that if you type button type classes dot, you actually will automatically see that there is Google and inverted as options that you can choose. This makes it a lot easier for us to import in button type classes anytime we want to figure out, hey, what are those different button types that render different styles of buttons? You can just use this object instead of trying to figure out by typing in a string and then coming to this component and checking. I'll show you what I mean once we finish writing this out. So in order for us to leverage this now, what I can do is I can create a new function called getButton. And what getButton should do is it should take the button type string and it should return us back one of these three button components. Because remember, these are individual components now. So what I'm going to do is say, hey, I'm going to get back a button type. And by default, I want there to be a base button because the base button is what's going to push to this base button component. So by default, I'm going to say there is a base. Then what I'm going to do is I'm going to say, okay, the button type's default value, if none is passed, is button type classes dot base. And then what I'm going to do is I'm going to return back from a special map object. And this map object is going to be passed the button type value. So we're essentially saying, hey, what I want is off of this button type, return me the specific component that I want. And the specific components are going to be mapped here. So first there's button type classes like this, dot base. If I get base, then I want to return the base button. So here we just want to return the literal functional component right now. Similarly, I'm going to repeat this 3 times for the other types. If there's Google, then what I want to return is the Google sign-in button. And finally, if there is inverted, then I want to return back the inverted button. And now I'm going to save this. And what we can do now is we can take this get button and come into our button component. And what we'll say is that the actual button that we need to render, so the custom button in this particular case, is equal to calling get button and passing it the button type. Now what we do is that this component is now pointing to one of the 3 relevant buttons. So we can take this button and replace it with this current button right here. Like so. And now we don't need these class names anymore. All of the other props we still want to spread through. But now what we can do is leverage this button type class anywhere we're using the button. So let me show you. First, let's go into our sign-in form component. Here we're using a Google button. So in order for us to leverage it, we want to say, hey, take in the button type classes. And we're going to come down here. And what we can say is, instead of button type pointing to the string Google, which we can make a mistake on, what we can do now is we can render button type classes.google. And now if we save this, if we come back to our application and let's sign out and then go to our sign in page, we see that we still have our Google button. Similarly now, let's go to our actual product form, which is where we show our other button type. Here we use inverted. So now if I import in button type classes, and instead of button type, again, I pass in button type.inverted. If I save this, I come back here, I go to the shop. There we see we have our inverted button. But the main advantage of doing this style of pattern is that now we can really just leverage this object that very easily tells us all the styles of buttons. We don't have to guess for that string. We don't have to mistype that string. These are all ways to eliminate the error of people, humans, writing code. And this is one of the big advantages, and it kind of actually gives us a little insight into a different kind of pattern where it's very intuitive now for us to look at these different components and see them as what kind of styling is relevant. Because we know, oh, there's base buttons, and then these similar additional components are just additional styling on top of base buttons. It's much more intuitive to look at components than it is to read giant walls of CSS and Sass code. But this is the new pattern that we really can leverage now utilizing style components. So now that we've learned these 2 main forms of using style components, we've done it with our navigation and we've done it with the button. My challenge to you is to convert the rest of the application over to style components. So once you've done that, join me in the next video where we will discuss perhaps some of the more challenging style components that I found to be ones to convert. There's a lot to go through. If you want to compare ahead of time, I'm going to post a repo link inside of your resources folder that will show the entire application migrated over to style components. If not, join me in the next video where we'll discuss some of the ones that I find a little bit more challenging to think about. I'll see you in the next video. Welcome back, everyone. In the last video, we styled our button, but now what we need to do is we need to style our cart dropdown. And I'm going to teach you a new concept that works with style components as well inside of your styling strategy. So first, let's create what we need for cart dropdown. We need to convert our cart dropdown.styles.sass over to a .jsx file. Inside of cart dropdown, one quick thing I want to note is that I've actually left out a very small feature. And that feature is that when you have no cart items, what we should show is that there is some kind of message that mentions we have no cart items. So for example, inside of cart items, what we could do is say that if cart items.length is existent, meaning that it's greater than 0. If a value of 0 evaluates to falsely, meaning that we have no cart items, then we show the empty message. But when there is cart items, then what we want to do is we just want to actually iterate through mapping the cart items to the corresponding cart item component. which is pretty much what we've had done up until this point. After this, then, we need to show some kind of empty message. So this is where I would add somewhat of a span, and inside of the span, I would say your cart is empty. And that is pretty much all we need in order to demonstrate that we have an empty cart. So what I'm going to do is I'm also going to style this span as well. So going back to our cart dropdown styles, let's talk about how we're going to convert this. So the first thing that we want to do is we want to, of course, style and make a style component. And to do that, we need to import in styled from style components. Once we have this, what we're going to do is we're going to say, okay, I have this. What I want to export out is the cart dropdown container component, which is what this class pretty much reflects. And this is a styled div because it's the parent level component. I'm going to capture all of these different stylings that we have. And then what I'm going to do is I need to think about what I'm trying to also style here. These ones don't need any context anymore, meaning that they don't need to live inside of the cart dropdown container because the targeting is not specific anymore. We can now just create new components that reflect what they are, because now we know will be scoped within our cart dropdown component thanks to style components. So here I can say export const empty message, which is actually that component that we had just made inside of our cart dropdown when it's empty. And we can just copy these in like so. And then I'm going to do the same thing for our cart items. So I'm going to say export const cart items. And here you can call them cart items container or cart items. I'm just going to call them cart items. And here I'm just going to make sure to bring over these same styles. And now what you've seen I've done is I've left this button for last, because this button is specifically targeting any buttons inside of our component, meaning inside of our cart dropdown component. So what you could do is you could say for any button, I want this style. But let's say you wanted to target specifically our own button, not every button, but just our own custom button, the one that we made in our own component. How would you do this? Well, this is where we get a really powerful nesting ability and targeting selector ability inside of style components. As I showed you before, each of these components get custom class names when style components actually gets compiled. If you remember when we looked inside the inspector, we saw that each of these different components that we made using style components had a very unique randomly generated string for the class name. And on that class name is how these styles got attached, which is how we're able to make sure that in our finally compiled CSS, it doesn't actually conflict or clash. But this also means that style components actually knows what those new randomly generated class names will be. And the way that you actually target them inside of your styling for a style component is you can directly reference the style component that you've made itself. So for example, we have inside of this file other style components. As in cart items knows that what comes before it is empty message and cart dropdown container. But what this also means is that you can actually target these inside of your styling. So if inside of empty message, for some reason, you wanted to target your cart dropdown container, you can just do so like this. You can say, hey, I want to apply styling on any components that have this cart dropdown container component inside of it as a child of empty message. So this is where the nesting applies the same with selectors. When you have nested, like we have button here, we're only targeting buttons that live inside as a child of cart dropdown container. What you're saying with empty message is you're saying, hey, I want to target any cart dropdown container that is a child of empty message. So you can target any style component, and inside you can overwrite and make nested styles. So if you wanted to change the position, you can do so just like this. So what we want to do is we want to replace this button with our button component. But the thing to remember about our button component is that our button component renders a regular component that in turn determines which of these three style components to render. So in order to target all three of them, which could be conditionally rendered, we actually need to import all three of our style component buttons. So to do that, I'm just going to go up here. I'm going to paste this in, and I'm going to make sure that we're going to the correct component. So we're going to go to button, and then from button, we need to go to button styles. So let's just make sure, like this. And now we can copy all three of these. And here we can say, okay, I want you to target base button. I want you to also target Google sign-in button. And then I want you to also target inverted button. So if any of these three components get nested inside of cart dropdown container, then apply these styles to them. And now that we've saved this, what we want to do is we want to make sure that we replace the correct components inside of our styling. So here, I know I don't need cart dropdown anymore. And I'm going to import in cart dropdown container. I'm going to import an empty message. And I'm also going to import in the cart items. And now to replace the correct components. So first, let's replace the div. Let's also replace the empty message. And now let's also replace cart items, which is also a div. And now it looks like I have an extra D there. So that's it. We've updated our code. Let's double check, make sure everything is working, including our new empty message. Now back inside our application, we actually see that I have a resolution error for getting this component. So it looks like what happened is I missed a slash. And now if we save this and we come back, we see that our application properly loads. We open up the cart dropdown, we see our empty cart message, and when I add, we see that everything still works and our button still works. So there we go. The key takeaway here is that you can target inside of your style components different other style components as selectors. So one important thing to note is that if you're going to use them inside of the same style file, just make sure that whichever component needs to target an earlier one comes after. Because if, for example, in cart dropdown container, you try to target empty message, well, what you'll actually end up seeing is that this variable will not exist at the point of this style component being initialized. So that's an important thing to note. But other than that, you have a lot of power in this ability to target your style components as well as nested styling selectors inside of your styles now. So with that, what I want you to do is try and style the next component, which is cart icon. Otherwise, we're going to do it and we're going to learn some more tips and tricks with style components. Welcome back, everyone. In this video, we are going to style out the cart icon with style components. So as normal, we are going to first convert our style sheet over to a JSX. And the key difference in this component is primarily that there is an SVG in here. Now, one thing I want to note about converting and targeting SVGs is that you can even do this without style components. So I'm going to show you how I would tackle styling this specific component. Normally, you got to think about your components when it comes to whether or not you want to make a brand new component to wrap it, or if you want to target some other way. So the way that we want to target this shopping icon is we know that there's some styling that's going to be applied on this component. And as I mentioned before, we can actually directly just target our own components, including these SVG components. So here what we can do is we can actually say export const shopping icon. And instead of this being shopping icon, let's call this shopping SVG because we want shopping icon to be the name of the style component that we expose. I'm going to say styled on this shopping SVG component. And then what I'm going to apply is the styling here with the width 24 and the height 24. And then we can just style everything else as normal. So here, I'm going to do cart icon container, which is a style div. Oops. Let's just fix that. That will have this width. Now, as I mentioned before, instead of doing it this way, you could have also technically targeted it with the SVG, like so, which is the typical styling way. But this way, I find it a little bit more within the alignment of how style component wants you to write your components. And then the last thing is our item count, which I believe is a span. Yes, it is. So here we can just paste in those styles that we had. And we can save this and now import this into our component. So of course now we already have this coming from our style sheet now. So we got our shopping icon, our cart icon container, as well as our item count. So now our shopping icon can stay the same. This will replace the div right here. And then the item count, of course, will replace the span. And there we go. If we go back to our application, we see that everything here still works. Our icon still has the styling. It's still at the appropriate size. So now let's style the next thing. And this is our directory item. So the directory item styles are pretty comprehensive. Plus, there's one additional thing that we're going to learn through styling the directory item, because right now we actually apply a custom style property using what React gives us as this style prop. We actually don't need this because we can pass props directly into all of our components that we make with style components. And this is actually a very, very powerful thing. Because now what we can do is we can treat these components as if they were regular components. But there's a little bit of syntax we have to learn. So let me show you. So first we import style from style components. And now what we need to do is let's think about what it is exactly that we're trying to do here. So first things first, let's talk about the targeting. This component needs to target a background image class. We can actually make a component for this background image, but we have to make it in the order in which it will get called. So if inside of directory item container, one of our styles targets this component, then we need to have that component already declared. So here I'm going to say const background image is equal to a style div, because that's what this background image is. So this style div is going to have a couple stylings on it by default. So the first one is going to be all of these styles. So let's just copy this over. And then what it's going to have is typically when you use this background image. As you can see here in this div, we pass the style, but we can't do this anymore. Instead, what we're going to do is we are going to actually pass this as a value, and we can call it image URL. You can call it whatever you want. It's really just the prop name that we're going to access the same way we will later inside of our components. So let's imagine instead I pass image URL into this component. The way that I can access it is I can actually say background image is going to point to, and then I'm going to string interpolate, because this is just a backtick string. So now I can actually access the different props that get received in just the way that you would like a component. You write a function, and what this will be is props, which means that we can destructure off image URL because that is being passed in as a prop. And now what we can do is we can return back a string that says URL wrapping the image URL. It's the same thing that we had before, but now we're passing in as a prop and then rendering it within the CSS of our background image. So after this now, we need also to look inside. Notice how we're also targeting a body. We're changing the opacity when this component gets hovered on. So we actually need this body first before we can target it inside the component. So I want to say const body is equal to a style div. And this style div is going to accept all of this styling here. And also inside, it targets the h2 and the p tag. So if you're wondering, with this h2 and this p, is it worth creating a new separate style component for it? Well, this is where you need to think. If you know that your component only has one h2 and one paragraph tag inside of this body div, then you don't need to. If you start adding more h2s and you want different styling, then you can start splitting it up more at a granular level into more different style components. But generally speaking, it's based on how you would normally write your CSS anyways. So this is one of those things. It's just really a matter of thinking about your composition and what you need and what you don't need. So now that we have both the background image and the body, we can finally do export const directory item container. And here it'll be equal to a style div. And inside, let's add these styles. So this hover style is very important. We want to take this over. And inside, notice on the hover. So here we target a background image. Instead, what we're going to target is directly the background image style component that we have. And the same thing is going to apply for the body. There we go. And that is pretty much all we need, unless I'm missing some other styles. Let's just double check. Oh, I'm missing these styles right here for first child and last child, relative within, side of our directory item container. But I think this is it. As far as this large, I actually believe this is not being used anymore. So we actually don't need this styling. So let's just clear out that old CSS. And now let's import this and use it in our directory item component. So here I'm going to import from our directory item styles. And now what we need is the background image, we need the body, and we need the directory item container. So here at the top level, we're going to get rid of the container. For background image, we are going to get rid of this div while making sure to pass the actual image URL value still through. And then for div body, let's just get rid of the div. And it looks like perhaps there is a bit of an issue here. Oh, I'm missing a opening tag. There we go. Okay, let's go back to our application. Let's go to the home page. And there we see we have everything working. We can also capitalize these titles if we want very easily with a little bit of CSS magic. We can just go to the H2, which is actually inside of the body. And here we can say text transform uppercase. And now if we save this and we come back, we should see that all of our titles are now uppercased. Okay, so this component, the primary thing I want you to realize is that you can pass whatever props you want into these style components. This gives you a lot more power in deciding what CSS rules you want to generate inside of these components. You can even determine if you want to add additional styling here and there by using this pattern. So this is another great benefit that we get with style components. You can treat them like components and they can receive props. So now after this, the last thing we need to style is going to be actually one of the more complicated components, maybe the most complicated one, which is our form input. And we'll do that in the next video. Welcome back, everyone. So the form input is going to be the most complicated thing to style. There's a couple things we need to tweak, and there's a combination of all the little things that we've learned up until this point about style components in order to make this work. So to start, again, I've converted the file over to JSX, and I'm importing and styled from style components. There's actually another thing we're going to need, which is called the CSS block. And what really this allows us to do is encapsulate some CSS inside of a block that we can use as a variable and inject into our different components. The other thing is we need to convert these variables from Sass over into just regular JavaScript variables. So we can actually say const subcolor is equal to the string gray. And we can say the const main color is equal to the string black. So really, that's one thing about style components, is that instead of using Sass variables, you can use regular JavaScript variables. Here for this mixin, this is what I'm going to call a const of shrink label is equal to the CSS block. And the CSS is also going to take backticks. And inside the backticks is where you add the styling. So here, this styling, instead of using main color like this, I'm going to use the JavaScript variable of main color. But here, really what we did is we created those same mixins and those CSS variables as these new JavaScript variables. In fact, I'm going to call this shrink label styles, so we know exactly what this is. Next, what we're going to do is we need to create this form input structure. So inside, notice how we target a label. We target this label because we need specifically a way inside of this group styles whenever something happens, such as when we focus on it. So for this, I'm going to make this form label first. As I mentioned before, you want to pick the things that are going to be targeted later. So here, what I need to make is this form input label. I'm going to say const form input label is equal to a styled label. And inside, I'm just going to drop in all of these. Now here, notice how instead what we use is the shrink class. So what we can do instead now is utilize a prop called shrink. So we would do a very similar thing, but instead, remember what we're trying to include though is shrink label styles. So what you can do is you can actually directly say, hey, I'm going to access the props right here. And I'm going to get off shrink, which instead of passing it as a class name, we're going to pass it as a Boolean. And then I'm going to say if shrink is true, then I want you to add in the shrink label styles, which means that when this is true, this entire line is going to evaluate to whatever is here. So this is just going to get applied like so. Imagine if when this shrink value is true, then we have these three styles. Otherwise, we don't. So that's really what this line is saying. So again, very powerful because now you can leverage your JavaScript inside of your style components. This becomes extremely flexible because now you have all of the flexibility that comes with JavaScript by default. We also want to make sure that we are using the correct subcolor and also that we are exporting this out. So now that we have our form label, the next thing we need to do is the input. So this form input. Here, I'm just going to call this input because our component is called form input. And because, again, this is scoped within our component anyways, it really does not matter. So I'm going to call this styled input. And here, I'm just going to bring in all of these styles. So just like before, we need to make sure that anywhere where we're calling, we need to make sure that we use our own components. Here, in fact, I didn't wrap this either because they're variables and we're working in strings. So whenever you need to use a variable, you need to remember to use interpolation. Oftentimes, I make this mistake and it's hard to catch. So let's do that there as well for bar or bottom. So now we don't have any more of those old Sass variables. Focus is fine. And here is what I was talking about. When you focus on this input, we want to find the immediate nearest sibling, subsequent sibling of the form input label, which we now have as a component. So we can now target it using JavaScript as well, like so. And then whenever this happens, what we want to do is we just want to add these shrink label styles, like so. And now this will just essentially render those styles whenever this gets focused. And then the last thing we need is our group component. So our group component is probably not going to contain that much else. So I'm going to say group is equal to a styled div. And what's remaining is these position values as well as targeting input password like so. And that's it. We have now recreated everything that we need to into style components. So now let's go back to our form input component and let's actually utilize this. So instead, again, we need to re-import in all of the new components we've made. So form input label, as well as input and group. And now we can start replacing. Let's replace our div with our group. Let's replace the input with our new form input. And now for the label. So our form input label, as I mentioned, we need to make sure that instead of using this shrink like so as a class name, we can now pass it as a value. And this value is essentially just going to be equal to whatever we want it to be. So here, I'm just going to know that, well, if I'm using length anyways and its truthiness is being evaluated, I don't even need to do this ternary. I'm just going to directly pass the number in. Because if the number of the length is 0, then this will be falsy. If it's greater than 0, then it'll be truthy, and shrink will be true inside of my actual shrink value prop. So let's just test this now. Let's come back to our application. Let's go to the sign-in. And there we see our form input is still working. The label is shrinking. Everything works. So here, a lot of the complexity is just about thinking, okay, when I'm going to target these later inside of the styling, I need to make sure that I declare it beforehand. If this comes after this, there will actually not be a valid target when this is being evaluated. So that's an important thing to think about the order of your style components. Otherwise, the other thing is just the fact that we are rendering a lot more JavaScript inside of this component. And it just is so much more flexible to do it this way. So that's it. This is pretty much the majority of the hardest parts to style. We've touched upon arguably all of the different types of tools that we have in style components now. This CSS block, if you need to pass blocks of styles around and conditionally render them, this is another really great tool that you can use. So now what I want you to do is style the rest of these components yourself. If there are any components that you're a little concerned about how to do, or you want to test yours against mine, there are numerous ways to do this. There's no perfect right way, as there is with any kind of styling or JavaScript. What you can do is check in your resources folder for a complete styled folder of the repository of this project, where I've styled everything over to style components. That is going to be the baseline project moving forward for a lot of any other further optimizations that we make, because this is pretty much the typical way that CSS and JS components are really written in most projects nowadays. But again, finish styling out all of these components, compare your work against mine if you want to see an idea of how you can do it if you ever get stuck. And that's it. Best of luck, enjoy the challenge, and I'll see you in the next video. Welcome back, everyone. In this video, we are going to clean up the last few remaining things inside of our website. The first thing is we're going to remove this console log of our categories map from our categories context. And then the next thing is to make it so that these front-end directory items link to the appropriate pages now that we have them. So let's go back into our application. To get rid of the console log, very simply, we can just remove line 15 inside of the use effect of our categories context. As for actually fixing the routing, here inside of our categories, we have this categories object that currently lives in the home and passes it to the directory. What we can do, in fact, is move this somewhere else and modify it so that our home page doesn't do any of this prop drilling. Now that we've learned a little bit more, because we set up the directory really early. So let's move this out of directories, come into the directories, and now instead of ingesting categories like so, we can actually just move the categories into this component. In fact, let's move it above because it's pretty much a constant. Now, similarly, as I mentioned before, there are different ways we could tackle this. We can attach this onto our collection inside of Firestore with the category itself if you want to do it that way. The main reason why I'm doing it here is because we need something like a route name, or a route more specifically, because this route is going to tell our directory item where it needs to go, which is kind of exclusive to the application. Making it so that it's on the back end makes no sense. If you have other applications that consume these categories, that property might not apply to them. It only applies to our front-end application. So really, we can attach the route ourselves here. And the route we need to go to is specifically shop/hats. This is for our hats. For jackets, of course, it's shop/jackets. For sneakers, it's shop/sneakers. For women's, it's shop/women's. And then for men's, it's shop/men's. So now, when we pass this category into our directory item, inside of the directory item, we also want to destructure off the route. And in order to use the route, we can either transform our directory item container into a link component, or I can show you another programmatic way to do it by using a hook that we get from React. Router DOM. And this is the use navigate hook. With use navigate, it actually gives us a function called navigate, or whatever you want to call it. I'm going to call it navigate, which we get back from calling use navigate. Navigate is essentially a way for us to route. So we can say on navigate handler, which is equal to a function that calls navigate, and then we give it the route. Oh, I'm missing a const. There we go. So now if we just pass this to the on click of the directory item container, if we come back now, anywhere we click, it will take us to the appropriate place. So there we go. Our application is pretty much finished being built. In the next video, I'm going to show you where we're going to host this, and it's a great place that's really easy and really quick. And we'll have our website up in less than 5 minutes. So join me in the next video where we will finally host this application that we fully built. I'll see you in the next video. Welcome back, everyone. In this video, we are going to host our website live using Netlify. Through this great platform, Netlify, we can actually have our website hosted by the end of this video. And the reason why is because Netlify is a platform that focuses primarily on getting front-end modern applications up as easy as possible. They've really taken the world by storm in the last 2-3 years, and they're only continuing to grow. So this is a really stable, great service to use for hosting your applications, and we get great things like continuous integration right out the box. I'll talk more about that once we start signing in and taking a look at Netlify. So if you have not already got an account here, I want you to sign up and go through the process. And once you've successfully signed in, join me, because what you should see is a page like this one once this loads. So now that we're back, hopefully you've signed in and you are seeing this similar page as I am. There's a lot of different options here, but the primary thing we want to look at is the sites section. So down here in sites, what I want you to do is just click this import from Git. What this allows us to do is directly choose the GitHub account that we have that we want to host our application through. And the great thing about this is because whenever you make a push to GitHub to the specific branch that you want to deploy, it will automatically rebuild on Netlify, meaning that your website is always up to date to a specific branch that you have that you want to be your live website. So if you haven't already, make sure that your GitHub is currently up to date with all of the code changes that we've made in the last few videos. Here, what we're going to do is we're going to choose Git as our Git provider, but we could have chosen other ones. What it will ask you to do is authorize GitHub. So mine, I'm already authorized, but just go through the steps. It's very simple. It's essentially allowing Netlify to access your repositories inside of GitHub. Once you've done that, what you want to do now is you want to go and find your specific repository where you have our project. Now mine is called Crwn-Clothing v2. So you can either search for it right here or you can find it. And I'm going to look for mine, Crwn-Clothing v2. This is the latest version. The branch that you want to deploy is the one of your choosing. So mine is going to be main, because that is the primary place with my up-to-date code. Now what we need to do is we need to look at these commands right here. Nothing I want you to change except for build command. The build command is the command inside of our package JSON that builds and serves the final packet of our website after it's been minified and uglified and all that stuff. Minification and uglification is the process where we convert our fancy readable code into a less readable but much more optimized code, and it's handled all by Webpack. Here, what you need to add is CI equals and then yarn build. And the reason why you need CI equals is because of the continuous integration aspect of our website. Now let me explain. So CI, continuous integration, is the process in which we're allowing this platform to deploy our website based on very quick code changes that we make to some repository in a Git environment. Git environment for us right now is GitHub. Now, typically with deployments, this is actually a manual and arduous process if you were to set up the infrastructure and coordinate some of the potential cloud solutions or maybe the infrastructure solutions required for a full deployment, because you need to allocate resourcing. You need to figure out where these build files are going to be living in order for you to serve them to a website whenever they request them. Because remember, what's happening with our website is it's getting built into the final version, but that final version has to live in a resource somewhere, a server somewhere, that then needs to be able to serve that to websites that are asking for it. And it has to be the latest version of the code, or at least the version of the code that we want to deploy. Typically, you can imagine how this process might be complicated and arduous. But this is what these platforms like Netlify do, is that they've essentially turned all of this infrastructure into the primary thing that they offer as a service. So behind the scenes, they're coordinating all these deployments. They're figuring out all of these build pipelines. They're figuring out all of the resourcing required in order for you to easily and quickly deploy your website while listening to some Git repository for those changes. Now, we rely on a Create React app in order to build our project. What's happening inside of Netlify is that Netlify is essentially going to scaffold up Create React App and run Create React App's build command. So that means that you're essentially, instead of building on our local terminal, we're building inside of a Netlify environment. Netlify, of course, is, as I mentioned now, a CI environment. So what happens is that because it's still using Create React App to build up our project, it's relying on Create React App to look at the CI environment of Netlify and look for any potential issues. Now, what will happen is that some of these tools, because in a CI environment, might throw a couple warnings inside of our build step. The moment that happens in a CI environment, Create React App has decided to be a lot more strict, meaning that it'll treat warnings as errors, which is why if you don't have CI equals, to overthrow that CI variable inside of Create React App, then what happens is that Create React App will fail inside of Netlify. But that's only because of an overly aggressive treatment towards warnings, which will get thrown from these internal libraries we're relying on inside of Netlify. So by saying, hey, ignore that, don't worry about it, just build, now it all works. As for the publish directory, this is just what directory we want to serve our build files from. And knowing that yarn build with Create React App builds into a build folder, that's exactly the folder we want. So now I just want you to hit deploy site. Now what should happen is you should land on this page. Here you'll notice that we have a random string that's generated for our website, and it'll say site deploy in progress. If you scroll down, you will see these 3 steps that Netlify is suggesting we go through in order to have a fully secure and up-to-date website. We don't need step 2 and step 3 right now. All we need is to leverage the existing URL that they're generating for us, which is going to be based off of this randomly generated string. And we just need to wait for our site to finish deploying. If you scroll down, you'll see that these are our production deploys. So generally speaking, this process takes about 2 to 3 minutes, but it really depends on how much code you have, because what's happening behind the scenes right now is that Netlify is running our Create React App build script in order to build out the final folder that is going to actually use to host our website. So let's just quickly wait until this finishes. And there you should see published. So now if we scroll back up, we'll see our website is located at this address. If you click this, it will open up our web application. And you'll see that our entire application works the way that we had originally designed it to. In fact, if you click around, you'll see that you have everything working, including all of our features. And let's check our sign-in. So here I'm going to sign in with an email that I know we've already created. I hit sign in, and there we go. Our user is also authenticated. Oh, it'll get all these different checks and balances if you're using Chrome browser, which will tell you whether or not you want to update or store your passwords. But either way, our website works. Our authentication works. Everything is built in. So there we go. Our website is live. But there's one last step we need to do. If you click on jackets or any other deeper nested route, if you hit refresh, notice that we get a page not found. Now don't worry, this is perfectly normal. We'll discuss why this is happening, and it'll be a really quick fix for us related to Netlify. And we'll do that in the next video. So see you there. Welcome back, everyone. In the last video, we hosted our website on Netlify. But what we noticed is that if we navigate into deeper routes than our base route, when we refresh, what we see is that we get this page not found. So in order for us to fix this, I need to explain to you why this problem is happening, and it has to do with web servers. So to begin, let's imagine that you are on your left side, a user. This user is on a browser and trying to access your website. Here I'm using Crwn-Clothing.com, but you can replace this with your Netlify URL. None of it matters for the point of this example, but the main idea is that you're trying to access some website that is now live and hosted by Netlify. So when the user tries to access this base route of Crwn-Clothing.com, what happens is that this browser actually makes a request to Netlify's web server that's hosting our build script. So our website is deployed, yes, but this access and these files still live on some web server somewhere, which is being provided by Netlify. So this user is going to say, hey, I want to request any resources for this slash endpoint. What happens here is that Netlify web server is like, hey, do I have anything for that slash endpoint? Yes, I do. I'm going to send back the index.html. Now this index.html file is going to represent the built version of our website, because on this HTML will be the JavaScript tags and the CSS tags. That is the built version of also our React code, our styled components code. All of our code is now living inside of this index.html file. So what will happen is that the website will take these files and it will start building out the website. So at this point, what will happen is the JavaScript now loads onto the page. The JavaScript includes all of the React code that we've written, as well as all of the libraries we're leveraging. So at this point, what happens, JavaScript contains React, React Router DOM, everything that we've built throughout these lessons. Using this, it will look at the website and say, oh, what do I need to match? Remember, this is a single page application, which means that it's building out all of these different pages that live on these routes, which is what our router is doing in React Router DOM. So it sees, oh, I'm on the base route. What base elements do I need to build? In our particular case, we know we need to build a directory. So the corresponding HTML, CSS, and JavaScript for that page gets built, and that is what gets used to populate that page. Now, let's say the user already has our JavaScript code now. What happens when they navigate further to shop jackets is that our JavaScript code, which contains our React Router DOM code and all the code to configure what routes get what components, will see, oh, this user is now trying to access /shop/jackets. There is going to be some route matching that happens through the React Router DOM routes components that we've written. And then the corresponding element, which is the category element, is going to run. All of our context get pulled, all of our data comes in, and that in turn builds the correspondingly correct HTML and CSS files that need to be used in order to build that page. So this is really what's just happening from a single page application standpoint. But the key thing to remember is that at this point, the reason why this worked is because we were asking for the slash endpoint. Our Netlify web server understands, oh, whenever anyone tries to access the slash endpoint, send back the index HTML. And then the index HTML and the corresponding JavaScript, React, and React Router DOM code that's in there is going to be the resource that will take over any additional routing that happens on the browser. Because at that point, there's no more need to communicate with the web server for more resources unless required. The main thing is that now all of our routing is handled on the front end by our single page application. However, if when starting, the very first request you make for is instead for //jackets, this point Netlify web server does not have anything to serve for that route because we expect our front-end application to be the one that actually builds out the page. Before single page applications were a thing, a web server would essentially have all of the different pages for every one of these endpoints. So then when a user requests for it, it would send them back the web page. We're not doing that anymore. You can do that with server-side rendering, but our application is a single page application, so that does not happen. Instead, what happens is that Netlify web server is like, oh, I got no resource for this shop jackets, which is why we end up seeing that error where there is no page found. In order to fix this, what we need to do is we need to say, oh, whenever you request for a resource for any endpoint at all, always send back index.html. So on this initial request, whenever they try to access anything, we send back index.html. Index.html will render our React code. And from that React code, we're going to then be able to determine, oh, from this route, show this page. So that's really why all of this is happening. And we can solve this really easily by creating a redirects file. Now back inside our application. In order to build this redirects file, we need to go into our public folder and make a new file called _redirects. This _redirects file is specifically for Netlify. It tells Netlify, if you ever get any route requests, I want you to redirect to this other route and with a specific status. So for us, we want to match any route at all, which is what this /wildcard is going to represent. If we remember inside of our own routing, we've seen this wildcard before. This just means match any route at all that follows /. What you want to redirect towards is index.html. So here we're saying, hey, if you get a request for /anything, redirect them to index.html, which in turn will send them index.html. And then just return a status of 200. That's it. Save this file, go back to your terminal, and just add this and make a commit. Because as I mentioned before, we've set up our GitHub repo now to be connected to our Netlify. So as long as we make a push request, adding redirect for Netlify, and we push this up, Netlify, when you go back to your Netlify instance, you should see that your Netlify is rebuilding. So through this rebuild, as I mentioned, we're connected now. So this is one of the great advantages. Through simply pushing to GitHub, we are rebuilding our website. And now we just wait for the build to finish, and then we can recheck and see if we fix the error. So there, we've just published live. And now if we go back to this website, and let's navigate deep into jackets again, if I refresh, there we go. We don't get the 404 anymore. And the reason for this now is that when Netlify receives that request for shop-jackets, it's still just going to send index.html, which is going to build out our website and rely on the single page application nature to fix everything. That's it. Our website is now fully deployed and live. And any further changes you make, as long as you push to the correct GitHub repository branch that is building towards your website, you have a easy to update website that you can really quickly maintain and really quickly deploy changes to. This is an end-to-end process that we now have built in. So that's it. This is as far as the base library of React goes and 90% of the patterns that you're going to use on the day-to-day when it comes to building React applications in exclusively the React library. What we're going to learn next is going to be some additional, I want to call them tangential libraries or patterns that exist in the greater React ecosystem. This is where you're going to learn about things like Typescript integrations, things such as Redux and state management. Within that state management, we're also going to learn things such as side effect event handling with things such as Thunks and Sagas. And then beyond that, there will be topics on testing, different things around existing React libraries that kind of make building React applications a little different. We're going to talk about integrating with tools like GraphQL. In general, it's just now from this point forward, a lot more of the potentially optional parts of the React ecosystem, where depending on the company you work at, you may or may not use these patterns at large, but a lot of the times, you're probably going to encounter them at one of these companies. You're definitely going to encounter one of these optional, perhaps I want to call them, libraries and patterns, because a lot of the companies are shifting towards these solutions at scale. So it's still very important, and I do want to equip you with that knowledge. So that is what you can look forward to in the upcoming sections. But as far as the base React library goes, building our Capstone project, deploying it live, and then seeing and interacting with it, this is it. Thank you, everybody. I'll see you in the next section. Hello, everyone, and welcome back. In this video, we are going to talk about one of the most common libraries inside the React ecosystem that you have to get used to when it comes to being a professional React developer. This library is, of course, Redux. But in order for us to understand Redux, we'll need to understand this concept of a reducer. But I want to take a second just to talk a little bit about Redux and where it fits inside of our current architecture. So, in order for us to understand Redux, we need to actually understand and think back upon context. So, as we remember with context, we have some context inside of our application. Let's take the user context as an example. And this lives somewhere that wraps our entire application. We're able to make an update to the user data that lives inside this user context. Now, of course, this user data, as we know, can be pretty much whatever we want to set it to. But in our particular case, with our own user context, it's really just a current user value. It's either going to hold null or it's going to hold an object. But the main thing to remember is that user context lives outside of the application in a sense that it's at the parent level, so that we can say, I have some component down inside my application. I want to set the current user because this component, let's say for example, is our sign-in page. It will be able to then get that user from Google API or whatever, and then we can propagate that object up into our user context and update current user appropriately. From there, any part in our application, of course, can access this user context. So any component, no matter how far deep down into this application it is able to get that current user object. So here, the main thing I want you to think about this is a state management strategy. When I say state here, I'm not talking about component state, I'm talking about application state or global state. Because now this current user is globally available inside of our application. But the key thing to remember here about this user context, this is one type of state management strategy. We're leveraging user context, if you remember, as a React component, meaning that we're using useState or we're using useEffects in order to update the value of the user context state inside of this context component. Now, the thing to remember is that this, again, is React's context API, which is the default state management solution that React ships with. Redux is an external library that serves a very similar purpose. Not entirely one-to-one, but we'll break down more of the details as to why Context API and Redux are slightly different and why you would want to use one over the other once we understand Redux. But in order to understand Redux, we need to first understand reducers. And reducers is actually a pattern for state management that you can use inside your application. More specifically, you can actually even use it in the current React context that we've written. And let's understand a little bit more about what reducers are. So right now, when you think about your user context, it really just holds an object which has the value of current user, which is either null or an object. It's a very simple context. It's just storing one thing. But let's take a more complicated example, like our cart context. Our cart context is something that contains multiple values. It can store cart items, which is an array of cart item objects. it can store a cart count, which is an integer that represents the total number of things or cart items inside of our cart. And we have a cart total, which is a value representing the total cost of goods inside of our cart. The thing here about cart context is that when you think about cart context inside of our application, I want to zero in fact, on just this little example where we have our shop page. So this is a component tree representing the shop page portion of our application. It has also a bunch of different products, which are represented by product nodes down there, which are those lower level circles. Cart context, as we know, let's say we click and interact with the fourth product card. And here we say, oh, I want to add this product to the cart. Cart context, of course, will update with the added product. But what also needs to happen is cart count needs to update and cart total needs to update. These three different values all update due to an item being added to our cart. And the way that we manage this inside of our cart context as a React component is we have those use effects that trigger whenever the use state value of cart items changes. And if you remember, in fact, each of these three values are being stored as separate use states. How they update is based off of use effect. So there's a bunch of hook architecture that we've set up inside of cart context in order to make this work. So this is a very React defiant way of updating these three values inside of our cart context. But at the end of the day, what we do is we still update these values correspondingly so our application can use this cart state inside of our cart context. How reducers work is reducers are pretty similar, except it has a bit of a more intuitive way of thinking about how this object gets stored, and it completely distances itself away from the React way of updating state. So we don't use effects that way. But in order to understand that, let's go back to what it is that a reducer represents. So as we saw before, we were storing some object as our state value inside of cart context. That doesn't change. A reducer is still an object. So let's think about a cart reducer. So just follow me. I promise that once we explain it, it'll make sense. Cart reducer is an object, and it stores the same values. It's going to store the cart items, which is an array. It's going to store the cart count, which is an integer. It's going to store the cart total as an integer. And let's also just, in fact, store the last value that we also had in cart context, which is readable, which is cart open. If you remember, this is the Boolean that tells us if our dropdown is appearing or not. This cart reducer object, still the exact same. Nothing different here. The thing that changes is that instead of leveraging use state and use effect in order to update these values, we now utilize something called an action. And an action is very simple. It's also just an object, and it's an object that has two values on it. It has a type value, which points to a string, and then it has an optional payload value, which can be anything at all. Anything you want. Objects, integers, arrays, undefined, null, whatever you want as the payload, you can have it, and it's purely optional. Actions don't even need to have payloads. But if it were to have any properties, it can only have a type. In fact, it must have a type, and then an optional payload parameter. So now, how do we utilize these actions in order to update the cart reducer? Well, let's look at the action that gets fired, and let's look at the cart reducer and what happens in turn. So let's say, for example, we have some string value for the type. And this string is a very clear identifier. In fact, it's a unique string. And this string should describe what it is that's happening. So for us, let's say we wanted to toggle the isCartOpen value. We would want to say, hey, I'm going to fire an action, or there's going to be an action. And this action has a type of toggle cart is open. That's string. There is, again, an optional payload because we're toggling a value. We're using the previous value and switching it to the opposite value. So if it's false, it's true. If it's true, it's false. So payload doesn't matter here. We don't actually need a payload to toggle anything. So because payload doesn't define, we don't need to pass it. It's just an action with a type of string toggle cart is open. What happens now is that isCartOpen is the thing that reacts to this action. isCartOpen, we know, is the only thing that gets modified inside this object based on the fact that This action has a type toggle cart is open because we only want to toggle this value. So now that value updates to true. The other 3 values do not need to update. Now, let's say we wanted to make another action. And a very common one that we know we need our reducer to store is, let's say we were adding an item to our cart. So now let's say we have this action type string as add item to cart. Well, if we're going to add something to our cart, we need to know what specifically we're trying to add. We need the product object. This is going to be the payload. That's what you're passing. You're passing the object that is the product you want to add to the cart. Here, of course, now the reducer is going to say, oh, okay, I've got this action with this type add item to cart. I'm going to take that payload, which is the object, and I'm going to update correspondingly the value to that care. Cart items, cart count, and cart total all need to update whenever an item adds to cart. So what we're going to do though is that we know is cart open is completely unaffected by adding items to cart. So cart items will add that corresponding item into it. We might do some modifications here as we do where we create a new object that has a quantity value on it. But all that happens, the main thing is that the cart items gets updated, that array. Cart count updates its count, and cart total updates its total value also to whatever the new cost is. This flow of actions modifying cart reducers is the key thing of how reducers are different than how we're currently storing our context state inside of our cart context. So I'm going to go into how we can convert what we have now over to reducers, because this is the step-by-step to learning Redux. The first step is just learning about reducers because we can use them inside of context. And then afterwards, we'll figure out why Redux might be a better solution with reducers inside your application. But for now, this is the main thing you really need to understand. Reducers are really just these object representations of these values that receive actions, and then these actions in turn will update the values inside of the reducer object. So now that we understand this, let's learn about creating reducers inside of our context. Welcome back, everyone. In this video, we are going to learn about how reducers look as code. We're going to start slowly replacing our contexts to reducers for the practice, and then we're going to really understand how we can use reducers inside of our context to improve upon what we already have. Sometimes it's an improvement, sometimes it's really just the equivalent of what we already have inside of context, but the key thing is that we want to understand reducers so we know their place inside of our ecosystem. To begin with, conceptually, reducers as code are very simple. They're pretty much just functions that return back an object. So here our const user reducer is just a function, and what it will do is give us back some object that has the shape of the data that we want to store. In our particular case with this object, we want to store anything related to the user. So for us, we already store current user, so we can just make sure that current user is a property that we also store and return inside of this object. So it could be null, it could be some object with whatever values. All of that is up to you. But for us, we know that our current user is either going to be null or that user object that we get back from Firebase. So for us, we know that that's what we'll want to store. And we want to make sure then that current user is on this object and that this object reflects whatever the actual current value is going to be. Nothing different so far. The thing about reducers is that these reducers change the object that we get back and the properties and the values inside them based on the action. But we also receive something else, which is the current state. So as I mentioned, reducers return back an object. This object is the state in the reducer. So what we get back is actually this current value from the reducer. And the reason why is sometimes you want to reference these values in order to derive what the next value should be. So the reducer gives that to you. And based off the state and the action is how we can determine, what type of object do we return? Or not what type, but what are the values on this object that we want to give back? And that's really all it is. Reducers are just these functions that always return a new object. And as we know, the reason why we always return a new object is because that is how React determines that something has changed. So if your reducer has changed, then this object must be different. Make sense? Okay, let's move forward. So how do we utilize these reducers inside of our context? Well, it turns out we actually get a useReducer hook. And the useReducer hook is very similar to useState. So let's start commenting this out so that we can start utilizing it. In order for this to work, remember, context still is context because the context is what values that we expose. The only difference now is that how we're storing current user is a little different. We're not using useState to store that value anymore. We're now using a reducer. So the first thing we need to do is we need to create a reducer function. So I'm going to say useReducer is equal to a function that gets the state and the action, as I mentioned. And then it's going to return back some object. So let's figure that out. First things first, we know that on the action, there are only two possible properties. There's either a type, and then there's maybe an optional payload. So let's destructure those off the action. Now what we need to do is we need to conditionally return back an object with those values depending on the type. So let's talk about what kind of actions we have, because that's what the type represents. We know that we have some action that is set current user, because when we get set current user, what we want to do is we want to say, hey, I want you to give me back an object where the current user is equal to the payload. Because as I mentioned, the payload is going to store the value that is important for this reducer to know what to update this state value with. So if we're saying, hey, I want you to set current user, well, what am I going to set it to? Any information related to what to set that to is going to be in the payload or the payload itself. So here, what we can really think about is that, okay, we want to say based off this type, I want to return some object. And as I mentioned, there's some set current user. So what we'll use is what's known as a switch statement. Now, a switch statement is a special block of code where you pass the switch some value. We're passing type in this particular case, our type string. What it will do is then it'll say, okay, inside you can give me a bunch of different cases. A case being what you expect the value of what you pass me to be. So in our particular case, we can say, hey, if type is of the string set current user, then what I want you to do for me is run the code right here. And then you also have a default case, which is to say, hey, if none of these cases match the type value that I got, then run the default. So here inside of our case, we're going to say, hey, if the case is set current user, then what I want you to do is return for me current user, which is equal to the payload. So it's a new object. Return back this object, current user equals payload. So what about the default value here? Well, what we know is that reducer, this useReducer, should only be receiving types that it recognizes. If for some reason we get a type that doesn't match any of our case statements, then we need to throw an error. Because we need to tell our code somehow, hey, for some reason you gave me a type that I've never seen before. And we want to do this because this reducer should only be receiving actions with types that we recognize. Otherwise, it's some kind of silent error. So here I'm going to say, hey, there is an error of the unhandled type in the useReducer. So this will just help us track whenever we see something like this. Now, if you wanted to have more cases, we can definitely do so. But for now, we don't even have that many different cases to work with. This is enough for us. So what about this state object? What do we do with the state object? Sometimes you can use this state object to derive your next value. Like let's say, for example, you imagine we have some kind of increment counter. Let's say this just kept track, for example, of a number. And if you increment, and what you're keeping track of is some value that's equal to 0 or whatever integer. If you're increasing, then what you want to do is you probably want to increase the previous value by 1. So that's what you're setting the new value to. That's one case where the state might be valuable. Another is that on our state, we might actually have multiple values. So imagine if we have some state object where we have, yes, current user, which is equal to null, or some kind of Google auth object, right? We know that. But what if we were also keeping track of first name, which might be a string, and last name, which might be a string? All important values that are related to a user. Well, in this particular case, if these were values, if we're setting current user, probably first name, last name, we don't want to modify. So then we don't want these to be set in here somehow, right? So to do that, we're just going to say, okay, I want to spread through the previous state. And what this will do is this will spread in all of the current values for your object. Because remember, you're returning a new object and you want all of the previous values, except for the ones you modify. So what you're doing here is you're saying, hey, give me the same values on the previous state object that you had, but anything afterwards, I'm going to overwrite. And that's really what this is doing. So now, this is how we should always write our cases. Always return an object that spreads through the previous state, and then just update the relevant values that you care about. And then the last thing that we need to do, which I've started up here, is we need to keep track of these variables, these string values. Because we don't want to rely on human error to remember what all these cases are. We want to keep these as some kind of constant that we can access. And I'm going to call this user action types. And this is just an object which has these key value pairs where it's the actual value. So I'm going to say set current user is equal to the string set current user. So now in order to use this, I'm just going to say, hey, if the case is equal to my user action types dot set current user. If this is the case, then do what you need to do. Now, how do we actually utilize our user reducer? To utilize it, we're just going to say, okay, I want to use the use reducer hook. This use reducer hook takes two arguments. The first one is our user reducer or some reducer. And then the second argument is the initial value for the state. In our particular case, our initial state is going to be an object, and current user is equal to null. Because when we initialize our application, we have no current user. And now, what do we get back from user reducer? Well, this gives us always two arguments. The first one is the state object. So the current values that's being stored by this reducer. The second is a dispatch function. This dispatch function, the way that it works, is that it's a function that whenever you call it, you pass it an action object. So if you want this user reducer to receive an action, you have to call dispatch, and dispatch will take that action and then pass it in, where it will then run through the switch statement and update the reducer accordingly. So just for our own sake, let's just modify what we have from useState over. So current user before was being stored on state. Now this is an object. State is a whole object. So we need to destructure off current user. So we can say const current user is equal to state, like this. We can also destructure directly right off the state, like this as well. Both are equally valid. And now our set current user function that we're also sharing from our context, now we need to define it. So we can say const set current user is equal to some function that gets a user value. This could be null, this could be the auth object, whatever. What we're going to do is that this function dispatches out a object which has the type of user action types dot set current user, and then a payload value of the user. And this is what we need in order for this to work. Now, the main thing though about this user provider is that we still get some subscription value for the auth state changes from Firebase, and then once that happens, we call set current user like so. All of this will still work. It's just that instead of using useState, we're now using a reducer. So let's just get rid of these variables. And now let's save this. And just to make sure that everything's working, let's also console log out the current user. And just for safe measure, so we understand our reducer, let's also console log out the action. And here I'm also going to log a string that says dispatched. So now we know every time our user reducer runs, it's because we have called dispatch somewhere. So going back to our code, here what we see is when our app initializes, we get null, of course, because current user initializes with that null value for current user. And then because of our actual auth listener, what happens is that our user, because they're signed in, will get signed in because their auth state is being kept for us by Firebase. So then what happens is that it dispatches out a new action of set current user with the payload being the user object. And that's what we see here. Then our current user updates because use reducer as a hook knows, oh, my reducer value's updated. Because of this action type, I'm responding to set current user. I am then going to generate out a new state object. And then this use reducer hook is going to be like, oh, there's a new reducer value for this actual state object. Rerun this whole functional component, which in turn then dispatches out a current user update to all of the listeners that are hooked into this context. So this is the flow. It's very similar to use state. Whenever set state gets called, state gets updated, and the functional component reruns. With reducer, whenever dispatch gets called and a new state object is returned, then we also will rerun this functional component. So all of this is pretty much the same. And one quick thing I also want to do is I want to show you what happens if we run the incorrect type. So I'm just going to say this as a string of not handled type. If I save this now, again, we're going to go through the same flow, but we throw an error. So here we see an error that says that, hey, there's an unhandled type of not handled type in our user reducer. So exactly what we want to see, because we should never have code that will fire unhandled types. And that's it. Now our code is working. Now you might be wondering to yourself, why did I include all of this boilerplate? Why did we write all this additional stuff when useState was doing it so easily for us? It seems like this is much more convoluted. Now, again, as I mentioned, I just picked a simple user context for us to learn. And the reason for this, of course, is because there's so much here. We learned about action types. We learned about the reducer function. We learned about use reducer as a hook. We learned about dispatching actions. There's so many little things that we had to learn just to get this reducer working. So I wanted to pick the most basic example. And you're absolutely right. Most of the time for a context this simple, where we're just storing current user and one setter function, you don't want to use a reducer. You can just use useState perfectly fine. But the value of using reducers becomes more apparent in more complex cases, such as our cart context. And reducers have actually been proven to scale quite well when it comes to state management, hence the popularity of libraries like Redux. So my challenge to you is actually to take what you've learned in this video and try and modify the cart context yourself before moving on to the subsequent videos where we will do it together. And don't worry, reducers have a notorious reputation for being difficult to learn. For me, it was very difficult when I first picked it up as well. But again, I've seen the benefits and I've worked on numerous projects at massive scale in enterprise applications where it really proves itself to be incredibly useful. So it's a very, very valuable tool to learn and a very valuable pattern to understand. All of the pieces are there already. We've gone through it with our user reducer. It's up to you to see if you can figure out how to piece it together. And struggle is good. If it's challenging, you'll definitely learn little nuances in it while you're trying to convert the cart context over to utilizing reducers. So please try it. If any of this was challenging, rewatch this video, understand all these pieces. All of these interactions make sense between every one of these different parts that we've added. You just need to be able to put this flow together. So that's my challenge to you. Try it yourself, and then join me in the next video where we will do it together. I'll see you soon. Welcome back, everyone. In this video, we are going to migrate the cart context over from using useState and useEffect to use reducer. So I want to use reducer strategies when it comes to migrating some of these more complicated contexts like we have. To quickly go over what we did, we know that primarily inside of our current cart provider, we have a bunch of use states that track 4 individual values that we then read from the cart context. These are the isCartOpen, the cart items, the cart count, and the cart total. What we've determined is that we are exporting out from this context different methods that a user can fire or a developer can fire in order to update the current cart items. And then whenever these cart items get updated, what we do is we then also derive new cart count and new cart total and then respectively set them from their useState setter functions. So what we need to do instead with a reducer is we want to extrapolate out these 4 readable values into a reducer, because reducers only store readable values. So how are we going to do this? Well, first what we need to do is we need to think about the shape of our final output. So the easiest way to do that is to actually create the initial state object first. And this initial state object is going to include all of the readable values that we currently have inside of our context, because the context is just storing these values individually inside of their own use state. They also already have their default values, so this initial state just gives us the object that we need to keep track of when it comes to what our actual reducer should return. So let's create that reducer now. This is going to be our cart reducer. And as you remember, it's a function that gets the state as well as the action object. And then what we need to do is we need to destructure off the 2 properties that come on the action, which are the type and the payload. Once we have the type and payload, now we determine with these 2 values from the action, what do we need to return as the updated state? So here, when we start thinking about this, oftentimes you need a reducer and it gets a little confusing. So it's important that you just set up the reducer first. You need a switch statement and the switch is going to be off the type. You know that you're going to have some default, and the default is most likely always going to be us throwing a new error, where the error is going to be us saying unhandled type of, and then the type in cart reducer. And the reason, of course, as we do this is because our cart reducer should only be receiving actions that we have accounted for. If there is, for some reason, we're getting an action that we have not accounted for, well, we shouldn't be receiving that action. Or it tells us that we have written code that we have not covered, if we're expecting this reducer to receive an action and we need to respond to it appropriately. After this, now we need to think about our cases. So when you think about the case of what you're going to do in your reducer, here is a very important distinction about your reducer and a best practice as well. Your reducer should not handle any business logic, meaning that inside of a reducer, if we were to receive some item, some of you might be thinking, oh, let me just create actions, for example, like an add to cart action. And this action should receive, or should be in the shape of the action object, or the type, let's just say, is add to cart like this. And then the item that I'm adding as the payload is going to be the item to add. Let's just assume that this might be a valid way to create this action. There's no problem with us dispatching out an action like this. This is perfectly writable code. But the reason why you don't want to do this is because now inside of your reducer, in order to appropriately respond to this, might have to be something like this, where what you do is you then inside say, okay, I need to figure out what these new cart items are. So that's the add cart item. So I might say something like return back, of course, spread through state, and then cart items points to add to cart item, and then the payload. As we know, the payload is the item to add, and then add to cart. In fact, we can even here, we know that our add cart item needs also the cart items. So we can even just say, hey, give me the state.cartItems that is currently there. And then of course pass the payload. Now this logic may work, but the problem is that this makes your reducer a lot harder to read. So what you should do instead is actually make it so that your payload should already be whatever you need to update. Because now if you think about it, inside of add to cart, we also need to update the cart total and the cart count. So how are we going to do this? We're going to write additional logic to take the output of this cart item inside of this code somewhere so that we can conditionally decide, oh, we need cart total. So then cart total is going to take this cart items reduce function off of the new cart items we're getting in, which we receive back from add to cart item. You see how it already gets really convoluted. We have to figure out all these conditional checks so that the right logic is happening here, right? You can see how we do new cart items like this is equal to add item to cart. And then of course we need to get the new cart total. Like this is equal to new cart items dot reduce as we wrote before. And we just have to then update it here. But this makes your reducer, as you can see, really bloated and hard to read. This makes it very difficult as well for us to make these changes because you can imagine if we had multiple case statements, we're looking at a giant reducer function. And we want to keep our functions as light and tight as possible, even if they're reducer functions. All this reducer should care about is really just updating the state. It shouldn't worry about anything regarding how to update that state. As in like what values, what business logic that state should end up in. Instead, that should all be passed to us. Our reducer should simply be the one saying, hey, I got some payload. I'm just going to update it with the appropriate values. So to do that, what we need to do is split up some of this logic. So to split up the logic, you want to think about dispatching an action that already includes all of the values that this needs. Now, before we start thinking about it being add to cart, that was just my example. You want to think about the type here. What's the type of action we want to set? Well, we can actually take inspiration from what we've written here inside of our typical hook-based flow. We have these values that we get from state. And then what we do is we respond when the cart items update so that we actually generate the new total and we generate the new cart count and then we set them respectively. So instead, technically, we could include cart count, cart total, and the new cart items all inside of one action. And as we can tell, based on our logic, it's generic. If cart items changes, then we generate a new count. Whether it's clearing an item from the cart, whether it's adding a quantity to a cart item, whether it's decreasing the quantity of a cart item. The cart count function and the cart total functions are all generic enough. It's really these actual adding, removing, and clearing that are unique. So in this case, what we can do is we can actually create a generic action that says, hey, whenever cart items get set, then what I want you to do, I want you to update the state with the payload. And this payload is going to contain the shape that we want. So it's going to have the cart items on it, or the new cart items. It's going to have the cart count on it, and it's also going to have the cart total. And these are all going to be the new values that we finally want to store. And that's what we should do inside of this code. So that is going to be my challenge to you. Figure out how to create a new function that can encapsulate all this so that you can dispatch a correct action that will then update according to what we've written here. So give a crack at that. You're going to have to write the function in here. And just to give you a bit of a hint, it's going to be something, I like to call it something like update cart items reducer. This is a function that is just going to receive the new cart items. You can even call them new cart items if you want to be explicit. And what they're going to do is they're going to have to utilize the code we already have inside of our effects and then respectively update the actual reducer value. Where you call this function, that's my challenge to you as well. So figure out, based on what I've mentioned here, how you're going to split up this logic and write out this function. And then in the next video, we'll do it together. I'll see you in the next video. Welcome back, everyone. So in the last video, I talked about separating out this new function that will allow us to dispatch the appropriate payload so that we can update our reducer with the correct value. So in this video, we're going to talk about how to actually generate those values. And also, let's think about where we're going to use this function. So what I'm going to do is I'm just going to write a little comment here so I know what I want to do with this function. In the end, what I want to do is dispatch new action with payload that looks like this object. We should have new cart items. We should have the new cart total, and we should have the new cart count. Once we're inside, though, we need to figure out how to get these values. As I mentioned, the actual update cart items reducer, this is a generic function that should already be receiving the new cart items. Hint, hint, nudge, nudge, that kind of tells us where we're going to use this, but in the interim, we need to figure out how to get the new cart total and the new cart count from the new cart items. So that's really another thing we need to get. We need to generate new cart total, and we need to generate new cart count. So utilizing these three things, let's actually build out this function. So first, we have to figure out how to get these new cart items into update cart items reducer. So here, we already have these three different helper functions that explicitly, as we know, give us the new cart items. So here, instead of setting them, let's just cast them to a variable called new cart items inside of the function. And similarly, we're going to do that in each of these areas like so. So now that we have the new cart items, let's just also run our function passing them through. And we can pass this to each of our three functions. And now the cart items that we receive, we know will be the correct cart items because we've already made sure that our functions do exactly that. They give us the new array for what these cart items should be. Then what we want to do is we want to generate the new cart total and the new cart count using these new cart items. And luckily for us, we kind of already have the code that does that. So here we can actually just copy this from our effects because what they do is they work off of cart items changing whenever it changes to the newer cart items that we need. So instead of reducing over cart items, we now can just reduce over the new cart items that we're getting in to get the new cart count and the new cart total. Now that we've solved for these two, the last thing we need to do is dispatch the new action with the appropriate payload. So here, what I want to do is instead of using all of these values, I am going to figure out how to use reducer to help us do this. So first, let's think about use reducer. Use reducer, as we know, is where we're going to get the actual dispatch that we need. So to do that, I know that I get state and I get, dispatch like so. And then from use reducer, I need to pass it both our cart reducer as well as our initial state. As for dispatch, now we can actually just dispatch away the new action that we want to generate. The type here is going to be set cart items as a string. And the payload is going to be an object where cart items is new cart items, where the cart total is the new cart total, and the cart count is going to be new cart count. And that's it. That's all we really need. Now we can get rid of this. But here we actually notice that we need our cart items from our new use reducer. So to do that, we can strip off cart items. In fact, we know that we have to pass both cart items, cart count, cart total, and is cart open all through into our context value. So let's actually destructure off all those values that we have anyways. So we also need cart count, and we also need cart total. Now, if we save this, we see that our warnings are gone, but we still have set_is_cart_open. So this is going to be a new function that we have. But we'll figure that out after we finish cleaning up what we have inside of our cart provider. So we finished setting up our method. We finished setting up our action creator functions, if you want to call them that. And we finished setting up this reducer that has set cart items. Let's just make sure to test that all of this is working. And the best way is to just quickly make sure, for now, this is always going to be true. Because by doing this now, technically it's untoggleable, which is perfectly fine. Whoops, actually, sorry, let's just set an empty function. And let's set is_cart_open to true by default. Because I want to be able to see the cart to make sure that all of my methods here are working now that we've converted them over. So yep, we see our cart. Let's go into shop. We add our items. We see that everything works. We go to our checkout. We see that our remove item works. And we see that our clear item works. So all our code is still working. But now we need to make sure that we do our is_cart_open. So here, before, if you remember, we had a setter function that we were using with useState. Now instead, we need to create and dispatch a new action that will set the actual is_cart_open value. So here, I'm going to flip this back to false. And this is going to be my challenge to you. I want you to update this cart reducer and create a set_is_cart_open method that is going to be a function that will update our cart reducer with the appropriate value for our cart. So do that for me, and then join me in the next video where we will tidy up this cart context, as well as figure out some minor optimizations and utility functions that will make modifying our reducers easier in the long run. I'll see you in the next video. Welcome back, everyone. In this video, we are going to replace that set_is_cart_open function that we had before from a useState into a new action creator that fits inside of our reducer pattern. So here, let's first create this method, set_is_cart_open. And this is going to be a function that receives a Boolean value. It's this Boolean value that we use to update is_cart_open. So all we need to do is just dispatch a new action object where the type goes to whatever we want to call it. So I'm going to call it set_is_cart_open. And the payload is going to be the Boolean value. Then we can just pass this function through into our value. And now all we need to do is make sure that our reducer is prepared to receive this value. So inside, let's just make a new case statement where we're listening for set_is_cart_open. And then what we do, instead of spreading payload, is we say is_cart_open is going to be the new payload value. Now, as I mentioned before, and some of you might have already done, these case statements should be stored in some type of const somewhere so that we don't make mistakes when we're typing out strings. So let's make a const cart action types object like so, which is equal to an object. And inside, I will receive set cart items, which goes to a string set cart items, and set_is_cart_open, which goes to a string set_is_cart_open. And now I can just update all of the places that call the old strings. And now let's save this, and let's make sure that everything continues to work. So let's go back to our application, and there we go. We see that our set_is_cart_open still works. We see that adding to cart still works. And we see that we can toggle even with cart inside. So that's the migration. It seems a little bit convoluted and complicated. I definitely feel you there. Oftentimes when working with Redux, it does have this weird feeling about it. We're not even actually working in Redux right now. We're working inside of cart context, just using the use reducer hook. But the primary thing around reducers is really just that there is this added value that we get for being able to separate what sets state into these separate action creators. We kind of had something very similar with our effects, but each effect was calling its own separate set state. Now this is all being handled in one dispatch in order to update 3 appropriate values. So this new strategy is really just so that we can congregate some of this logic into one separate function, and primarily remember that the good time to use reducer is when one update needs to modify multiple readable values inside of your state somehow. So for us, this is an exact time to use a reducer because we want to update 3 separate values. Because whenever our reducer spits out a new object as the state is when the provider and the context decides it's time to rerun. Whereas before, every time we were setting state, technically speaking, yes, they were batching together, and React is smart enough to know that. But at least now it is a little bit more clear that whenever our set cart is getting called, 3 values are updating. Whereas before, we were less certain about what's happening here. Plus, this logic is a lot clearer. You know that it's all happening in one function rather than happening through 2 different effects and then split over 3 different other set states. So now that we have this, let's talk about some optimizations we can make. One thing that we notice is that every time we have to generate this object, what we can do is actually create a helper function. This helper function I'm going to create inside of our utils. So here I'm going to make a new folder called reducer. And inside I want to make a reducer.utils.js file. This is going to be a create action function that receives a type and a payload. And all it does is it just returns back for us an object like so. Very simple. The only reason we do this is so that we don't have to type out the name of these keys, which oftentimes leads a little bit more to human error. So this is really just a more nitpicky kind of optimization we can make. I'm also going to remove these unused hooks that we had before. And of course, I'm going to import in our create action from our utils folder, reducer utils. Now let me just make sure I'm properly exporting this. No, I'm not. So let's just export out const. And then what we'll do is we will use it in any place where we have to dispatch. So here, instead of generating this object like so, what I'm going to say is that I want to dispatch create action passing the type as the first argument, and then this payload object as the second argument, which is our payload. And then I'm going to remove this call like so. Let's just make sure all our brackets are correct. And also, I'm going to do the same for this new dispatch here as well. Let's take the first one. Let's take the Boolean here as the second argument. And now let's just once again go back, make sure that our code is still working. Yes, it is. Everything works. Once more, what we're going to do is we are going to go into our user context, and we're going to do the same thing. We need to import in our create action from our utils reducer utils. And then what we're going to do is just update the dispatch in the same way. We're going to pass the first argument being our action type, and then the second argument is, of course, our payload. And now we save this. And now let's just make sure everything still works. We go back to our application. We see that we're signed out. We sign just out like that. We sign in. Everything still works. So our code is up to date. And this is it. This is pretty much how you use reducers inside of your context. Now again, inside of our user provider, do we need to use context? No, not necessarily, but if this were to scale, at least we've already set up the reducer so that it's easier to scale off these values. If we were to do this with cart context, this is actually the exact place we should have used a reducer, because as I mentioned before, 3 different readable values update every time we need to update the cart. The only additional consideration that really needs to factor into whether or not you want to use a reducer is also going to be up to your team. Some teams prefer to keep everything in the realm of just React components with useState and useEffects. Most, though, if you're familiar with using Redux before, will like using reducers because it's a familiar pattern and it has proved that it is scalable. So now that we know how to use our reducers inside of React using the useContext as well as the useReducer hook, in the next video we're going to talk about Redux as a library. Redux as a library takes this concept of reducers and extrapolates it out into an entire Redux-based ecosystem. And we're really going to dive deep now that we at least have a good idea of how reducers work into using Redux as a library as well as the ensuing additional complexity that comes with using a library like Redux for your state management. I'm also going to talk about when you want to use context with useReducer versus using Redux in the next video as well. So stay tuned and join me in the next video.